Check, check. Prof, you want me to speak? Check, check, check. Mic test, 1, 2, 3.
I hope you've all picked up your coffees from outside. Welcome to ART Fertility Clinics' inaugural annual scientific congress in India. This year, our conference's key theme is Reproduction in an Individual Medicine Era. The conference will bring forth the latest clinical advancements and the research in the field of assisted reproductive technologies, as well as showcase the unique approaches and treatment in reproductive medicine. The conference features participation from top international IVF specialists, health organizations, and related experts who have pioneered reproductive medicine techniques in their respective fields. We shall attempt to identify and address region-specific challenges in fertility treatments, as well as highlight personalized treatments and present successful case studies for new learnings. Last but not the least, the Congress gives us an opportunity to network with the most renowned clinicians, embryologists, and geneticists in the field of reproductive medicine. We hope that this Congress provides all the delegates and participants a stimulating environment and an enjoyable interaction. Thank you for being a part of the wonderful gathering. With this, may I please introduce Professor Dr. Human Fatemi, Global Medical Director, Consultant Obstetrics and Gynecology, Consultant Reproductive Health at Fertility Clinics. Professor Fatemi graduated with an MD in 1999 from the University of Brussels with magna cum laude. In 2005, he won the Pfizer Educational Grants as the Best Fellow in Gynecology in Brussels. In 2008, he was recognized as a subspecialist in reproductive medicine and surgery by ESHRE and EBOG. During his training and later on, also as a consultant, he has performed several studies in various fields of gynecology and reproductive medicine and surgery. He successfully defended his PhD in endocrinology of the luteal phase in stimulated and substituted cycles in 2018. Professor Fatemi is the author of more than 150 internationally peer-reviewed articles and several book chapters. He held more than 150 invited spoken presentations at international conferences. In 2009, at the age of 35, he received the title of Clinical Professor from the University of Brussels. Over to you, Professor.
Thank you very much, Dr. Erika, for the kind introduction. I would like to thank you all to be here on a Sunday morning early. Also, of course, our international speakers. You know, we had the same meeting yesterday in Dubai, and actually the day before we had a workshop also in Dubai. So I think our international faculty, the battery lamps are lighting empty, but I hope they will have enough energy for today. But I'm sure with the Indian colleagues and the challenging questions they will ask, we will be reanimated again. Now, why do we organize these meetings? And I think this is going to be the beginning of many years of these kind of meetings. You know, when I was working in different parts of the world, I was born in Iran, I lived in Germany, I studied in Belgium, then we moved to Kuwait, and then Dubai, Abu Dhabi. So we had the luxury of dealing with patients of different ethnicities. And while coming very often to India and working in Dubai and Abu Dhabi and Kuwait, we realized that there is something like geography and infertility. It means based on your ethnicity, based on where you are, the physiology might be different. The causes of infertility might be different. And it's not that we have to take granted studies which are done, I don't know, in Belgium or in the US or in the UK or in Australia. Because we are different, the body is different, the lifestyle is different, the cultural habits are different, and all that might have an impact on infertility. And this is exactly why we have to put a question mark behind everything what we do. And I think the worst thing that you can do is following a dogma. And I think that's the biggest mistake that most of us do. Repetitively doing again and again the same thing. You know, I had the pleasure to work with our colleagues in India who have joined to work with us in our teams. And the first thing I always say when we have new physicians joining us, you have to unlearn and relearn. And this is the only way of progress. This is the only way of going forward. And I'm really happy today that we have a really esteemed international faculty, people I personally look up to, where I know I can learn from them, in order to share the knowledge. And I can tell you it's going to be a very interesting day today for all of us. Even for me, it's going to be the second day listening to these presentations, but I'm very keen to listen again, because every time I'm listening, I'm learning something new. So I welcome you today for the meeting, and I would please ask the colleagues to come for the lamp lighting, so we are not going to lose too much time in order to start with the meeting today. So can I please ask the colleagues to come for the lamp lighting, please?
Please invite Professor K.D. Nair, Dr. Parul, and Dr. Richa Jagtap on stage with Professor Fatemi for lamp lighting. Please.
You are the experts, so.
Give it to the professor first. Before moving on to the first session, I have two important announcements. Anyone who has registered for the SIGs, they're going on parallel. The first SIG starts at 10:45 on fertility preservation by Dr. Barbara Lawrence, Dr. Richa Jagtap, and Dr. Nalini Mahajan. You can move on to that area and go for it at 10:45. Please report 5 minutes before the scheduled time. Also, we won't be having a coffee break. It's a working conference, so you're free to pick up your coffee and teacups and come inside the hall. Moving on to the first session, may I please introduce our two chairpersons, Dr. Parul Katiyar, Co-Medical Director, ART Fertility Clinics, India. Dr. Parul Katiyar is a senior infertility specialist with MD in obstetrics and gynecology and advanced training in the management of human fertility from Leelavati Hospitals, Mumbai. She has over 15 years of experience in the management of all kinds of infertility cases, leading hospitals in Delhi and NCR. Dr. Katiyar has a special clinical interest in reproductive endocrine disorders, endometriosis, PCOS, and fertility preservation. She is a life member of OBGYN and Fertility Societies, Indian Fertility Society, and the Indian Society of Assisted Reproduction. May I please invite Dr. Parul Katiyar on stage. Introducing our next chairperson, Dr. Rohit Gurgutia. He's the medical director at Nova IVF Fertility, Eastern India. Dr. Rohit is a medical director of Nova IVF Fertility. He has helped set up and formulate clinical protocols at Genome, the fertility center in Kolkata. Currently, he's engaged in nurturing and developing an enabling environment for fellow clinicians and embryologists to provide best-in-class treatment and assistance to couples seeking conception. His professional credo, in his own word, is we are forever striving to ensure the quality of care and service for everyone and everywhere. May I please request Dr. Rohit to come on stage. Requesting Dr. Parul to introduce the first session.
Good morning, everyone. So our first session is about frozen embryo transfer. We all know that frozen embryo transfer is a new norm in IVF practice. And it is who else than Dr. Fatemi can enlighten us on this topic. So it gives me immense pleasure to invite Dr. Fatemi to present his talk on frozen embryo transfer cycles. What is the appropriate or optimal approach? Dr. Fatemi.
Thank you very much, Dr. Parul. So those clinicians who are working with us, they, in the beginning, I have to convince them why we prefer a frozen embryo cycle above a fresh cycle. You know, 2 years ago, I had a debate, even not 2 years, I would say 1.5 years ago, I had a debate on Kogi in Berlin, in Germany, and I was astonished to see the arguments that still some top scientists are using to promote fresh cycle. I'm going to try to put a little bit of light in the knowledge that we have in the field of human reproduction, why fresh and frozen are completely two different entities, and you cannot promote the fresh cycle. And personally, I think in the next 5 to 10 years, maybe rather 10 years, the fresh cycles are going to disappear because we're going to understand more and more that it is better to go with a frozen cycle. So I'm going to highlight the mistakes which were made in the past to promote the fresh cycles. Now, if you take a look at the prevalence of frozen cycles, there is a reason that the freeze-all is increasing. Why is the number of frozen cycles globally increasing? And this, as you see, is a few years ago. That was 2018, 77. I can tell you today is even more than that. There are many clinics in Europe, in the US, who are not transferring any fresh embryos anymore. If you ask me, what do you do? I'm not talking about our clinics in India, but for example, in Abu Dhabi or Dubai, it's 100% freeze-all. You might say, why do you do that? Why do you transfer all the embryos in a frozen cycle? Before I go and put some light into this question, I would like to ask you a question. Let's say you are flying with Air India from here to somewhere. And this is the runway you're going to land. Would you prefer to land here or to land here? And here, it's a cliff going down several hundred meters. Good? So where do you prefer to land? Here or here? Obviously, the answer is clear. You want to have a wide runway, you want to have, in case your brakes are not working, whatever, or the pilot is inexperienced, that you have enough space to land. Good. Now, you could ask yourself, this guy comes from Abu Dhabi, Dubai, to Delhi to tell us about a runway. What's the link between a fresh and frozen cycle with a runway? There is a link, and I'm going to try to highlight that link. So please keep that picture in your mind. Now, this paper was recently published, I think 1 week ago, 2 weeks ago, in Fertility Sterility. It's a huge sample size. Now, these big databases, they all have a lot of heterogeneity and biases, but I think the message is very clear. The message is very clear. You see, if you have a fresh cycle, obviously without PGTA, based on the number of eggs and your pregnancy rates. This is frozen PGTA. So obviously, because you do PGTA, your results are better. Obviously, good. So forget the yellow line. Just look to the red and green line. So you see no PGTA, frozen, and fresh, no PGTA. At any given point, the pregnancy rates are better. At any given point. Why is that? And these are huge databases. And the frozen cycles, and you will see that, are far from being ideal. So there is a lot of room of improvement for these frozen cycles. So even the way we do it, which is not perfect, the pregnancy rates are superior. So what if we can even enhance our frozen cycles, the preparation of the endometrium for a possible pregnancy? Now this is the number of children born. There are in fact countries like Denmark where a good part of the population, up to 6.5–7% of the population, is born after ART treatment. And you see the numbers of freezing are increasing. So when we speak about a cryocycle, frozen embryo transfer cycle, the first question we need to ask ourselves, how do we prepare a cycle? I mean, that's a valid question. How do you put back an embryo? You might say we do a natural cycle, we do an HRT cycle. Yes, but how? How do you do that? And this is a question. You see, in Germany, they say the devil is in the detail. And that is what it is. The devil is in the detail. So we need to look into detail. What do we have to do in order to improve the receptivity of the endometrium in a frozen cycle? If you look around the world, you see 70% they do an HRT cycle, and then you have 25% natural cycle, and then 5% they do a managed natural cycle. But then I would ask myself, what is a natural cycle? It's a valid question. And if you do an HRT cycle, how do you do an HRT cycle? How many days of progesterone do you give? Do you synchronize the embryo with the endometrium? If so, how do you do that? Is it based on a division pattern of the embryo, hours of embryo division pattern, hours of progesterone exposure? If a patient is ovulating naturally, does everyone ovulate on the same pattern? Do you look into detail to the LH rise, drop of estradiol and progesterone rise? Do you synchronize endometrium and embryo? So there are a lot of small questions which might help us to identify how to improve the receptivity of the endometrium in a cryo cycle. You see, this was also published about a year and a half ago. If you freeze an embryo, should you wait 6 months, 1 year, 2 years before you put it back, or does it happen that the longer the embryos are frozen, the chance of conception goes down? It seems to be so. So again, a study with a lot of heterogeneity, but it seems if you wait more than 6 months, that the quality of the embryos might somehow be jeopardized. On the other side, you have heard all over the news, a few weeks ago, it was on CNN, BBC, everywhere, embryo born after, I think, 30 years of the sibling embryo being born. So yes, of course, it can happen, but it seems globally, the longer they are frozen, the lower could be the viability of these embryos. Now, if you go to the receptivity of the endometrium, the most important thing we need to understand is that the endometrium is being prepared to become receptive based on the hours of progesterone exposure. These we have to keep in mind, the hours of progesterone exposure. So once you have progesterone, on hourly basis, the endometrium starts to change. What changes do we have? On the left side, you see the follicular phase. On the right side, you see the luteal phase. Every line that you see here is reflecting a day of the cycle. It means in the luteal phase, every day that you have, there are significant changes. You see it's a huge variation of what's happening in the luteal phase. And this is under the influence of progesterone. And that's exactly why we have to respect the hours of progesterone exposure. You might ask the question, what is progesterone exposure? From which level of progesterone are we talking about that there are changes of the endometrium? The answer is very simple. We know that from a progesterone level of 1 nanogram per ml, more than 78–80% of patients will have what we call secondary transformation. Could you please put on the monitor in front of me here? So if you go above 1 nanogram per ml, you will have 80% of women having secondary transformation. Now, you remember the picture I showed to you. I showed you a picture about the runway. This is the picture of the runway. You might ask, this is modern art. Why is it looking like a runway? So I'm going to elaborate a little bit on that. This is the gene expression of the endometrium. So you see in the follicular phase, you have proliferation with the gene expression, then you start having progesterone exposure, the endometrium starts to cook, and at some point, the food is well done. The biryani is ready, let's say. You see, the genes are suddenly downregulated. The genes are downregulated, and you have opening of the window of implantation. So this is the time frame, this is the runway where the embryo can implant. So you can imagine, the longer this runway, the bigger is the chance of an embryo to implant. Easy. So let's consider this time the runway. And then you have a sudden, further down regulation, the window of implantation closes. So please keep in mind, the uterus has a runway, a time frame after progesterone exposure where it is receptive to receive an embryo for implanting. If you put an embryo outside the so-called window of implantation, here or here, you might have the most beautiful embryo. It will not implant because it's outside the window of implantation. The endometrium and the uterus and the embryo, they need to be fully synchronized. If they're not synchronized, you will fail to have a pregnancy. Successful pregnancy, good embryo, receptive endometrium. Now, you all know if you stimulate a patient, you have an elevated steroid levels. So we know that estradiol goes up. But with some patients, not only estradiol is going up, but also progesterone goes up. And it's nothing novel to you to say if progesterone is elevated, the receptivity of the uterus in a fresh cycle goes down. Everyone knows about that, right? So if progesterone goes above 1, 1.5, you have a sudden drop of pregnancy in fresh cycles. We might ask the question, why? I'm going to try to highlight it a little bit. So if you take a look at the gene expression of the endometrium, and this is a paper we published with Inge van Varenberg a few years ago, we demonstrated that the gene expression of the endometrium starts to change from progesterone of 1, but above 1.5, it's a major change of the gene expression of the endometrium. So the endometrial gene expression changes significantly the moment your progesterone goes above 1 and then further 1.5. So there is something happening in the endometrium if you have more progesterone. But we were naive to think that this 1.5 is really a cutoff level that needs to be respected. Now I'm going to ask you a question. Let's say you have a patient, she comes to you, and she has, after 9-10 days of stimulation, a progesterone of 0.7, 0.8. Let's say at 4 p.m., 5 p.m. So everyone is happy. 0.7, 0.8 is less than 1, 1.5, we are happy. Then you trigger the patient because she's ready for the final oocyte maturation. So she's ready, you trigger her. So you did all your efforts and your progesterone is good, 0.7, 0.8. At 4 p.m., 5 p.m. Now you trigger that patient, let's say at 8 p.m., 3 hours later. You're happy, 0.7, 0.8. You trigger at 8 p.m. What is her progesterone after 2 hours? What do you think? Double. If it's 0.8, within 1 to 2 hours, it goes to 1.6. What's the rationale of measuring progesterone? Because it doubles immediately. And this is a paper we just published a few months ago with Dr. Carol from our clinic in Dubai. So we need to understand that endometrium of all stimulated cycles is advanced. Not because of high estradiol, because we expose the endometrium to progesterone immediately after the trigger shot. But the egg retrieval happens 36 hours later. It means the endometrium of all women is advanced at least by 34 hours, all women, if there is no high progesterone before the trigger shot. Because if you have high progesterone before the trigger shot, the endometrium is advanced not 34 hours, but more than that, because you're already exposed to progesterone. What happens in nature? In nature, you have an LH rise, the day after you have a drop of estradiol, the day after you have a rise of progesterone. So in nature, it takes up to 2 days before you have your progesterone rise. So this is something we published with Dr. Barbara, I think in Gynecology and Endocrinology 2 years ago. So there are clear descriptions of what happens in nature. And we were the first actually describing a natural cycle and how to prepare a natural cycle in order to put back an embryo. And initially we promoted a full natural cycle without any interference. But some people promoted the idea of managed natural cycle. But I think the question comes back, how do you do a natural cycle? If you don't do a natural cycle, of course, the managed natural cycle will be detrimental. So here, this paper demonstrated fertility sterility. Natural cycle is superior to managed natural cycle. And this paper published by Marie Montagu, also from Brussels at that time, that a complete natural cycle without any luteal phase support seems to do much better than even if you give luteal phase support or managed natural cycle. So the way forward is to go with a complete natural cycle. But the question is, how do you do a natural cycle? Of course, it's easy. If you do a natural cycle, you see a dominant follicle, endometrium is decay, then you give the trigger shot, so it's easy if you give a trigger shot. But is it the same as a full natural cycle? If you do a full natural cycle correctly, the answer is clearly no. So also some people said, look, you have to report to support the luteal phase, but the question is if it's really correct to report to support the luteal phase. This is a commentary we published in Human Reproduction Update 1 year ago, 1.5 years ago. Again, the devil is in the detail. How do you do a full natural cycle correctly? We know that if you start measuring progesterone in the systemic circulation, the values that you measure here are completely different than the values you would see in the collateral blood vessels of the ovary, because the concentrations besides the ovary will be much, much higher than what you measure here. This is also something we need to understand. Now, a patient who is being stimulated and who is being triggered, she is exposed on day 5 transfer to 150 hours of progesterone exposure. Because you have seen, you trigger, and when you do your egg retrieval and you do embryo transfer after 5 days, that endometrium is exposed to 150 hours of progesterone. But the endometrium is advanced because of a trigger shot. Hence, this is why we have all women being stimulated having endometrial advancement. So you see, this is a natural cycle. This is a stimulated cycle. You always have around 1.5 to 2 days of endometrial advancement. Always. This was published many years ago by Claire Bourgain. Going back to the runway, and I want to that you think again the length of the runway that I showed you in the beginning of the presentation. You see, normally in a natural cycle, you have the follicular phase, you have your LH rise, you have your ovulation. You have seen ovulation takes 2 days, normally 2 days, until you have your progesterone rise. But then you have your blastulation, and basically, after 120 hours, you have opening of your runway. Then you have a very, very long runway. This is called window of implantation. And after approximately 2.5 to 3 days, the runway closes. Good? This is a natural cycle. Now, what is happening in a stimulated cycle? In a stimulated cycle, obviously things are completely different. Why? Because the moment you trigger, you have your progesterone rise. You have seen that. Immediately you have your progesterone rise. But once you have your progesterone rise, the moment you do your egg retrieval, the endometrium is already exposed 34 hours to progesterone. You have seen that. So the moment of embryo transfer, day 5, your endometrium is already exposed to 150 hours of progesterone. Very simple. That means that basically your window of implantation has shortened. The runway is shorter. Do you have a runway? Of course you have a runway. Can you land there? Of course you can land there. But can every plane land there? No, because it's too short. So some embryos will fail to implant because the runway is too short. Now, which embryos do implant, which embryos do not implant? Valid question. And I'm going to give you an example, and this is beautiful work from Bruce Shapiro from Las Vegas in the US. You see, if you have a fast-developing blastocyst, really a fast-developing blastocyst, and you have low progesterone the day of trigger, so you stimulate it well, the progesterone didn't go up, the endometrium is not advanced, all is TK. You have a large blastocyst, really good developing blastocyst. So endometrium is not a lot advanced, it's a little bit advanced because progesterone is low, the embryo is developing very fast. The fresh and frozen are very similar. But let's go to the worst case. You have a slow developing embryo, a plane with difficulties to break, so it needs a long runway to sit. Progesterone is elevated. It means the endometrium is more advanced than it should be because progesterone is already elevated before the trigger shot. Small blastocysts look fresh versus frozen. 50% difference, come on, it's a huge number, huge number. So as you go down step by step, you see the chance of conception changes. Why? Because your runway is short. So there are two variables you need to put into equation here. One is how does the embryo develop? The other one, what is your endocrine profile and how much endometrial advancement do you have? This is a paper we published last year, I think, in RBM Online, where we compared the HRT cycle with the natural cycle. And as you can see, in the HRT cycle, and these are own eggs. This is not donation. So donation is not allowed in the UAE. With own eggs, 65% clinical pregnancy with HRT, and natural cycle, without anything, no trigger shot, around 74%. So it depends how you do the natural cycle. That's the art in our field. Now, people have done Cochrane reviews, meta-analysis, and looking right and left, comparing HRT with natural cycle. The problem is there is a lot of heterogeneity. And for example, this is a Cochrane meta-analysis. I was looking for many years to find this paper. This was never published. This was presented as an abstract somewhere in 1994. So we have lack of data. And you see the mistake we do a lot nowadays, big mistakes we do, also in major journals. Really, it's ridiculous if you see that. You see, these are people, they do beautiful studies. They randomize the patients. The concept is good. The concept is perfect. And they compare fresh versus frozen cycles. And they say fresh is superior to frozen. Very clear conclusion. But if I ask you, in a good prognosis population, less than 35, 36, in a frozen cycle where you have a beautiful embryo, what is the chance of a patient to get pregnant? Give me a number. 40%, 30%, at worst 30%, in a good prognosis population, right? In their hands, in this good prognosis population, the pregnancy rate in the frozen cycle is 8%. 8%. Now, if you crash a car, maybe it's not the car which is the problem, maybe it's the driver. Maybe they did not know how to freeze, but they publish in Human Reproduction 8%, and they say, yes, it's fresh is better. Yes, in your hands, fresh is better. But is it replicable for everyone? Of course not. And these are the mistakes we do. The reviewers do, editors, associate editors do in these journals, publishing these kind of papers. How can you dare to publish 8% a good prognosis population and draw conclusions? Because next, the same people will do meta-analysis, and it will change completely the outcome to promote fresh above frozen. Of course, again, we commented, that's what we usually do nowadays. And actually, I have to say, we told to our staff we will stop commenting because the world is going to hate us because we are commenting on papers. But fortunately, this time we were not alone. Other people commented again also that this is nonsense, how you can publish this kind of data. Now, another paper which was published very recently stating that freezing is damaging the placenta. The topic is impact of freezing on placenta. And they say, look, freezing damages the placenta. Nonsense. Why nonsense? Because if you freeze and you put back the embryo, the question is, how do you put back the embryo? Is it a natural cycle or is it an HRT cycle? A natural cycle, you have a corpus luteum. HRT cycle, there is no corpus luteum. If there is no corpus luteum, you have more preeclampsia, hypertensive disorders, and. Corpus luteum, less preeclampsia, less hypertensive disorders. Why? Because corpus luteum is not only progesterone. Corpus luteum is also relaxin, vascular enteral growth factors, and, which is having an impact on vascularization of the placenta. So the problem is not the freezing. The problem is that all these cycles were HRT cycles, lack of corpus luteum. So lack of corpus luteum is damaging the placenta, but not the freezing of the embryo. But that's the title of that paper in Human Reproduction a few months ago. And unfortunately, this is where we are. So this is the quality of, unfortunately, where we are and the papers that are being published today. So this is, again, what we published in Human Reproduction last year to say, guys, be more cautious when you accept these kind of papers for publication. Basic knowledge. The embryo needs always one more day of progesterone exposure than the age of the embryo. So day 3 embryo is 3 plus 1. Day 5 embryo is 5 plus 1. Day 2 embryo is 2 plus 1. Basic knowledge, right? So this is a New England Journal of Medicine paper, the Bible of medicine. They accepted this paper with a kindergarten mistake. It's a kindergarten mistake, comparing fresh versus frozen, because they did not know how to transfer an embryo correctly. Day 2 embryo received 2 days of progesterone. Day 3 embryo received 3 days of progesterone. What's wrong here? 1 day discrepancy. Come on. I mean, if you do it wrongly, the conclusions you draw are wrong because you did not plan your transfer correctly. And this is New England. It's not just a journal of Timbuktu. This is New England Journal of Medicine. Now, some people started looking also to the levels of progesterone. It should be 8.8 or 9.1 in an HRT cycle. Others have looked into values of progesterone in a natural cycle. But again, what's the value of that, for example? This paper, they said 1 day before day 5 transfer, your progesterone needs to be more than 10 nanogram per ml. One big mistake they did. They did not confirm the ovulation. They thought with a urine stick that these patients are ovulating. But is a urine stick really a reliable tool to detect the progesterone rise? Of course not, because a urine stick has big variation in detecting the ovulation. In fact, if you put a urine stick, you will miss 30% of ovulations. This is number one. If you detect the ovulation correctly, there are different patterns of ovulation. The progesterone rise, this is what you're interested at, can occur after 22 up to 56 hours. Up to 56 hours. And this has an impact on the tumulus of the eggs, right? So we have to be very cautious when we speak on LH and progesterone rise. You want to focus on the time, not of LH rise, on the time of progesterone rise. And this is why these papers, you have to read them with a lot of caution. And please don't read the title and the conclusion, because that is a mistake. By the way, this is a paper that Dr. Carroll just submitted a few days ago. This is in the urine, this is in the blood. So we did the same thing in Abu Dhabi in the blood, and we saw between 20 and 60 hours difference. So if you have an LH rise, some women after 20 hours will have a progesterone rise, some women after 60 hours will have a progesterone rise. It means you have 40 hours difference. That 40 hours in the window of implantation, it means a huge difference in the runway that we are looking at. So many studies looked into natural with HRT, and more studies are confirming that natural cycle is superior. A last interesting paper, just to criticize how it should not be done. This is a paper, Fertility, Sterility. Good journal, we agree, it's a good journal in our field, right? Because I was criticizing human reproduction update, let's go also to fertility, sterility. You see, they compare in an HRT cycle, vaginal progesterone versus intramuscular progesterone. Simple, HRT, vaginal progesterone, intramuscular progesterone. Because our American colleagues, they think women has to suffer to get pregnant because this intramuscular is very painful. They have to suffer to have a baby. So vaginal versus intramuscular. And the conclusion is very clear. Intramuscular is superior to vaginal, which is nonsense because many studies failed to confirm these findings. But why did they come out with that finding? Very simple, because the study design was wrong. Very simple. You see, you have two variables here. You have vaginal progesterone, they receive it for 4.5 days, intramuscular progesterone, 5.5 days. So now you have two variables, vaginal versus intramuscular, and the hours of progesterone, which differs by 24 hours. Come on. If you draw conclusions, it's not because of intramuscular, it's possibly because you gave different hours of progesterone exposure. I'm highlighting this to make you have a critical way of thinking. So don't take things for granted. Of course, with frozen, you also have significantly less ectopic pregnancies because the uterus is simply more receptive. Last but not least, you might say, yeah, but didn't you hear with frozen cycles you have more preeclampsia, hypertensive disorders, and postpartum hemorrhage? Yes, but again the question is HRT or natural cycle? Because natural cycle, corpus luteum, relaxin, and vascular growth factor. And obviously, if you compare natural cycle with HRT, with natural cycle, you don't have more preeclampsia than in nature because it's a natural cycle. You don't have more preeclampsia, you don't have more hemorrhagic disorders, and you don't have more cesarean. So the way to go is indeed natural cycle. More and more data are showing that there are significant differences with preeclampsia, hypertensive disorders, and other collateral damages. They do not exist if you go with a full natural cycle. So at the end, the question is, where do you want your embryo to grow, here or here? So the way is going back to nature. So just to conclude, we need to respect the basic physiology if we want to transfer and plant a frozen embryo. The hours of progesterone need to be respected, and this needs to be fully synchronized with the hours of embryo division pattern. Thank you very much for your attendance.
Thank you. Thank you, Professor, for a wonderful talk. It makes it worthwhile to travel 2 hours in the flight and come and listen to you all the time.
Thank you.
So the message, I think, is very loud and clear for all of us. With my co-chair's permission, maybe one question could be allowed from the House. None. Okay. So then...
I think can you have the microphone, please?
Hello. Yeah, it was amazing. Actually, we don't think with that broad mind, and you really opened eyes because we just read a paper and we think that it is very, it is genuine. So you have suggested that urinary LH and the serum progesterone levels, they vary. So there is a window between 20 to maybe 60 hours. So how did you measure your serum progesterone? Did you do serum progesterone daily for these women and found out? Or how was it?
Thank you for this very important question. Thank you for that. So basically, what we do is we see the patient day 2 or 3 of the cycle. We do a scan to make sure there is no persistent corpus luteum, that everything is okay. We ask the women, what is the cycle length? Because obviously you cannot do a natural cycle with a PCO woman or with an extreme poor responder. So you just can't do that with patients who have a regular cycle. So if they have a regular cycle, let's define it as 28 days, we see the patient somewhere, so day 2 or 3, to make sure everything is okay. Then we see them back somewhere between day 11 to 12. So day 12 we just do a scan. With a scan, we observe if there is a dominant follicle growing. Because some women, because they are stressed, they don't ovulate. So we make sure there is a dominant follicle growing. If you see there is a dominant follicle growing, we draw once blood. We draw estradiol progesterone LH once. Why? Because we want to know how much steroids does this follicle produce. Because not every follicle produces the same amount of estradiol. Some follicles produce a lot, some follicles produce a little bit. So we measure how much estradiol does this follicle produce. Let's say at the size of 14, 15, it's maybe 150 or 160, whatever. Now we know that the ovulation occurs usually in 2 to 3 days, usually. And we know that women usually ovulate with 17, 18, 19 millimeters if they are normal responders. So we see back the patient after 3 days. So you see here when the follicle is around 13, 14, 15 millimeters. You see her back after 2 to 3 days, 2 to 3 days. No more scan. If the endometrium is good, you know that the thickness is okay, you're happy with that, you just draw one splat. You measure estradiol, progesterone, and LH. The blood test you did before is your reference value. This blood test is referring to that value. So if estradiol was, let's say, 150, LH was basal, progesterone was basal, this blood test that you draw 2 or 3 days later, normally your estradiol will be further up because the follicle is growing. But it might be that the day before she started having an LH rise. So the LH rise occurs in blood over 3 days usually. The first day of LH rise, your estradiol is higher than what you did before. So if the previous estradiol was 150, if you captured the first day of ovulation, your LH is up, but estradiol is higher than what you had before. So instead of 150, it's maybe 220 or 300, right? But progesterone is still low, 0.2, 0.3, 0.4. Maybe you captured the ovulation the second day of ovulation. Maybe LH went up, but here your estradiol is lower than what you measured previously. So if it was 150, if your LH is up, your estradiol is maybe 120, 130. So it's going down, but your progesterone is still low, maybe 0.7, 0.6. Maybe you captured the last day of ovulation. Estradiol crashes down, LH is still up. Estradiol is not 150, it's maybe 80 or 90. But you see progesterone is going up. So you don't need to do everyday blood. If you know these physiological changes, you can identify with 2 blood tests in a month that she ovulated. What we do, but it's mostly for study purposes, we confirm the time that progesterone is above 1. That is for us important. But I have to tell you, the labs in India, because we have 6 clinics in India, and we are looking in detail, they are not detailed enough to detect, because for most of the labs, if it's 0.8 or 1.1 or 1.2, they are not really detailed oriented. So we are working on fine-tuning these cutoff, because for us it's very important. This is where we take the decision to start the time 0. So if you rely to your lab, the moment you are between 1 and 1.5 is the moment that you have time 0. It's the moment that you consider the ovulation. And then you count the days, for example, day 5 embryos, today is day 0, 1, 2, 3, 4, 5, and then you put back the embryo. If you want to be on the very safe side, just the day before the transfer, you can measure progesterone, because some women, they don't have an incomplete ovulation. So there is an unruptured follicle, and they don't produce a lot of progesterone. So then you have to cancel the cycle. But if you see your progesterone is 7, 6, 8, then you can go ahead.
Thank you again.
Thank you.
You had one question, right?
Yeah, so just one question. We always talk about the window of implantation being reduced in stimulated cycle. So why does it get reduced? I understand that there is a rise in progesterone post-HCG, but the window of implantation, is it the time at which the embryo would implant, or is just shortened due to stimulation?
Yes, it is shortened because, you see, if you consider the window of, initially, if you go back in time, in 1973, there was a guy, his name was Psychos. So he published a paper that the window of implantation is 5 days. LH plus 7 to LH plus 11, 12. But at those times, we didn't have the knowledge we have today. Today, we know the window of implantation is maybe 2.5, max 3 days. So with all the patients where stimulation was done, you shorten it, if there is no progesterone rise in the follicular phase, by 34 hours with all patients. That means you have a window of implantation with most of patients 1 day. So in this 1 day, can embryos implant? Yes, of course they can implant, but only the ones which are advancing fast. The ones which are slower or smaller, they will fail to implant, as you have seen with this paper from us.
So is it because of the stimulation, the suprathreshold level of estrogen or whatever?
You see, because you have multiple follicles, you have multiple corpora lutea, and you have administered a lot of FSH. FSH by itself induces LH receptors. So the more LH receptors you have, the ACG that you administer is going to cover these LH receptors. Because you have multiple follicles, you have given FSH. So these are two detrimental factors. First of all, multiple follicles. Secondly, FSH, multiple LH receptors. So you have two bad guys which are promoting this accelerated progesterone rise. And I think this is leading to the advancement of the endometrium. So it's multifactorial, actually.
Thank you. So I have a few more questions, but I think we are running late, so we will move on to the second talk of the day. Thank you, Dr. Fatemi. It was really, really interesting, and I think we will all be able to talk to him and ask more questions during the session breaks.
Thank you so much, Professor. A quick reminder, the SIG sessions have resumed in the hall next door. You can go straight and right. The first session on fertility preservation, if anyone has registered, you can move on. And a humble request to the audience to put their phones on silent, please.
So moving on to the second talk, it's my pleasure to invite Professor Pasqualina Loy, who's the Associate Professor at Università degli Studi di Roma. He has dedicated a lot of effort to embryo multiplication since he began working with the embryos 30 years back. Using somatic cell nuclear transfer, he's demonstrated for the first time that non-living cells could also produce offspring, very interesting. A breakthrough that laid the groundwork for cloning of lyophilized cells. He's jointly delivered many publications which are a milestone for nuclear transfer research. And we are going to eagerly wait for his talk on 50 years of giving hard time to the oocyte. So.
Thank you, Chair, for the kind introduction. And thanks for the organizing committee for inviting me and giving me the opportunity to share 25 minutes of my scientific life with you. First of all, I'd like to comment on the title. As you see, it might definitely looks unusual, maybe for you. And then I want to spend a few words on the genesis of such a title. Because Luca Gianaroli last November invited me in Bologna, and then he asked me, what about talking about embryo quality or oocyte quality? I told, look, I really am not an expert on oocyte quality or embryo quality, but definitely I give the oocytes of the embryo very challenging task, and then I do select the best ones. So what I will do in these 25 minutes, I'll take you with me 35 years back, and I will tell you what actually I'm doing with the oocytes, what I've done with the oocytes, with the embryos, as an experimental embryologist as I am. Embryologist. First of all, I'm a veterinarian with a PhD on developmental biology, and these are my passions. I work on small ruminants and wild ruminants as well, and that's really, these are my passions. And these are the subject of my activity. These are sheep oocytes, maybe you haven't seen one yet. And then this is a blastocyst. They're very familiar with these subjects. So these are rather unlinear talks, so that's what I did my best to organize it, to provide a structure. First things, I will tell you what actually kind of manipulation I've done, that can be done on the embryo. And second, actually, how I lived the transition, because I started my career where the embryos were all derived from superovulated animals. But then I've seen how we shift from in vivo ovulated oocytes or embryos to the in vitro produced ones. And yes, so I started my career in the heydays of superovulation. It was the time where farmers asked us to multiply the reproductive performances of the cows or horses or sheep. And then actually put a lot of efforts in optimizing the synchronization treatments, artificial insemination, superovulation, and so on and so forth. So the quality was not an issue. Everything was, recovered from the superovulated animals, and were beautiful. We can actually do a lot of things, and then naturally what we did. The idea was to multiply, as I told you, the reproductive potential of the top producing animals, the genetically relevant ones, okay? Every farmer who told you, look, what a wonderful cow, she makes rivers of milk, she's never sick, she never got mastitis. I would like to have, as many as possible calves from this, okay? So superovulation was actually doing very well, but once you have the embryos in your hand, why not try to multiply them somehow? And this actually was something developed by, is also a vet, Steve Wilhelmsen from Denmark, working now in the United States, a genius, actually, a master experimental embryologist. And what he did a very, very simple technique, just, get out the blastocyst from the sheep, and then he split them in two parts, 12s, with a glass needle. The two half embryos went to the empty zonette, and then you got identical twins. Let me tell you that identical twins, okay, are they are only humans. There is any other species we actually produce who makes identical monozygotic twins, but you can make them artificially. But splitting the embryos is quite kind of reductive. Why don't we try to make more? Okay, and so this is just few slides, few pictures, just to show how to do it. That's very, very straightforward. Actually, could do this manipulation even by freehand on a dissecting microscope in the field. And that's been done quite a lot in Australia and New Zealand. They buy, let's say, 10 embryos and chopping them in two, you could multiply the number of animals you could put on the ground at the end of the story, okay? These are my very old pictures. So, and then why don't you exploit the totipotency, which is a characteristic of the early embryos? As you know, before the activation of the embryonic genome, all the cells, the blastomeres are totipotent. They can make into a completely a normal lamp. And then that's what I did. So you take 4, 6 cell embryos, okay, which is this one. You just remove the zona pellucida with the manipulation tools. We make them all the time. And then you put, previously emptied zona pellucida, and then you multiply. From one embryo, you get 4 embryos. That's, again, very, very nice kind of embryo game, which I really enjoyed when I was a PhD student. And of course, as I told you, by the time there were no support for in vitro stuff at all. So to do the embryo culture, it was actually done. First of all, we need to embed the embryos into, you see, these agar chips. That was a system developed by Steve Wilhelmsen, because when you culture the embryos in a legated oviduct, if you don't do so, the macrophage actually, they go inside and they eat your embryo, okay? So you could avoid it by providing them this kind of agar chips, first embedding, second embedding, and then into the ship for 7 days. After 7 days, you put again the ship under anesthesia. You do the flushing of the oviduct, and you could actually see what you did, the success of your work. That's one of the first blastocysts you can see here, made by blastomer separation. That's the profile of the agar. All the little animals in here are macrophage, very willing to attack your embryos, but prevented mechanically by the agar chip. Okay? So, one of the first triplets from blastomer separation. We made many of them. Just, by the time it was very common to multiply embryos from top size, top quality sheep, and also cattle breeding, okay? Well, and then nuclear transfer, actually, yes, you can get twins, you can get 3, 4 very rarely. And then again, Steve Wilhelmsen published in Nature 1986, nuclear transfer of embryonic cells, blastomer into enucleated oocytes. That's another much more, like I said, trickier definitely, but much more fun, of course, for an experimental embryologist. You can see these are 16-cell embryos. You just remove the zona pellucida with a glass needle, and then you get the blastomer isolated very easily by putting them in a calcium magnesium-free solution. The forces attracting blastomer are calcium dependent. That's a very, very easy. You can dismantle an embryo very quickly, and then you get, localize your chromosome inside. You just cut a window, okay, through the zona. You get them out, chromosomes out, polar body chromosomes, and then you put the blastomer, okay, in the perivitalized space, you give them electric pulse, you fuse them from one embryo, you end up with 32 embryos. Again, it was raising the stake, making things more complicated, but really fascinating indeed. And yeah, that's okay. In vivo culture again, that was a very good experimental day. 85% of the clones made with embryonic cells made into blastocysts. And they very, very easily, they get into offsprings, okay? These are the first set of nuclear transfer lamps. But we made many of them, 10, 12, it was very realistic, we've done so many. Even now, I have to tell you, in New Zealand, people are still doing nuclear transfer with embryonic cells to multiply high-value cows, okay? Especially dairy cattle. And then, as I told you, so getting oocytes or embryos in vivo was, complicated, expensive. Why don't we simplify things? And then this has been done mostly by this guy called Cesare Galli. He's he's the CEO of Avantea. He's a company who makes, any kind, actually applies any kind of experimental embryology and artificial reproduction in cattle, horse, any kind of animals. And they made first, they developed a very nice system for in vitro production of embryos and then, calves. They sell these in vitro produced embryos, and now it's become a reality. Everybody in the world is actually making, test tube, as you can say, horses, sheep, cattle, and so on and so forth. Okay, we did also our contribution. That work has been done by my former wife. So we developed, even for the sheep, in vitro embryos. That's very easy. You go to the abattoir, you get the ovaries. These are leftover organs. We can get as many oocytes as you want. And then actually we did many embryos. Again, that was work done in a farm, experimental farm, which provide a service for the farmers. And we put on the ground more than 200, lambs made completely in vitro from frozen. Any kind of, embryo biotech was applied in these days. And yeah, so just a few picture of my past activities. And then why don't we, if you are a vet, it is very important to accelerate the genetic progress, to reduce the generational interval, okay? So that's very important in animal breeding. So if you can predict that, an animal has a very high genetic merit, if you start to make them, to reproduce them, you actually are increasing the genetic progress, okay? So these are the ovaries and the uterus of a prepubertal lamb 5 weeks after birth. Before the birth and 5 weeks later, it has happened in sheep, in cow, but human too, I guess. We have a mobilization of follicles, which is finalized to atresia. But so you can see these follicles in here. Really hundreds of them. You can get hundreds of, oocytes from prepubertal lambs, and then you actually fertilize, and then this is a very important achievement. You see, this is a very high genetic merit sheep, is a dairy, okay? She's still prepuberal, she cannot breed, but this is her lamb, taken from, ovaries at 5 weeks of age. The pregnancy was carried out by this foster mother, and she has a lamb before even she's able to conceive. So that was the very first proof that you can get, embryos from prepubertal lamb. We did a lot of work also with, wild animals. These are mufflons. We made any kind, all, in vitro production and even cloning of these animals. But I want to cut the story very short. I don't want to give you, the final message. We have in vitro embryos. In vitro embryo production simplified enormously everything. So it could actually speed up very much our experimental embryology work. And then eventually, I've been working for a couple of years with these guys in the Rosalind Institute. Dolly the sheep was produced by nuclear transfer of somatic cell. And then, of course, I shift to do this cloning using somatic cell. Technically speaking, is much easier, no fusion. You just enucleate the oocytes, okay, and then immediately inject a somatic nucleus. I made something like 12 of these, clones. which are not really doing very well, I have to say, because, there are a lot of problems related to the insufficient nuclear reprogramming, but that's not a completely story. If you want, I can discuss it with you later on. But we did also this. Okay, raising the stake. So why don't we change things? So this lamp has been made using cells that have been killed by treatment. I didn't kill cells because I'm a cynic guy, simply because I wanted to remove proteins from the nucleus in order to make the nucleus more accessible to the reprogramming factor in the oocytes. But still, you can kill a cell and transfer into the oocytes, and you get a lamp. That was really incredible to see. And then if you are dead, but why don't we freeze dye them? And this work has been done by a friend of mine from Israel. These are granulosa cells from sheep collected and dried in Israel, sent by ordinary mail to Italy, stored for 8 years in a shelf, at room temperature. After 8 years, you inject them into the oocytes. You still have, blastocysts after 8 years. That was really remarkable. We are still pushing on it, but that's another story. And then we did every kind of, embryo production, monoparental embryos, androgenetic embryos, parthenogenetic embryos. We made even fetuses by pronuclear exchange, just technically speaking. You have to spin them down because otherwise lipids don't allow you to see the pronuclei. You do pronuclear fusion, and that's about androgenetic blastocyst. We did also embryo transfer and recover the fetus afterwards. And and then again, experimental chimeras. That's another kind of experiment that is still ongoing. So just to tell you, what can you do with embryos? Before entering a little bit into the details, why I'm doing this? So the problem, I'm a vet, and I'm very much interested in biodiversity loss, which is taking place over the planet. The extinction rate of animals is increasing. It's not longer under control. And actually, that's an issue, and that's the most endangered animals on the world. We have only 2 northern white rhino left in Olpayeta reserve. So this is the most endangered animal. So 2015, we gathered in Vienna, and then we reproductive biologists, myself, Cesare Galli, the guy, the Avantea guy. This is Thomas Hildebrand. He's a top veterinary expert of assisted reproduction in rhino and elephants. So he started to think, what can we do? Can we really apply reproductive technology to save these animals from extinction? And we started like a game without any funding. Now we have quite a lot of funding for sourcing from the web. Billionaires are providing us some money to play with these animals. Yes, of course we can do anything. Cloning, artificial insemination. We have stocks of somatic cells. We have stocks of spermatozoa from these animals, and we have started to do so. This is Thomas Hildebrand and Suzanne, just getting ovum pickup. Let me tell you, ovum pickup in a rhino is much more complicated than in a woman, because the echography has to belong 2.5 meters. It has been developed by Thomas. It's very, very challenging, but nevertheless, you can still get oocytes, and then you fertilize them. We've been very lucky, okay, because we do ICSI, and these embryos, they make these beautiful embryos. So without any, that was very, very bizarre. And then you continue to be lucky because, these, from 2 blastocysts, Giovanna Lazzari, Cesare's wife, has developed 2 embryonic stem lines, which are really, really important because, nowadays you can turn embryonic stem cells into oocytes or spermatozoa, okay? And the champion of this experiment, we published the paper of embryonic stem cells from the white rhino, and the guy, Hayashi, is a top scientist in Japan. He's been the first one to make spermatozoa, but also oocytes from embryonic stem cells, even from inducible pluripotent cells, okay? But the question is, even if you are able to make countless number of rhino embryos, where are you going to transfer them? We need a foster mother, possibly a kind of universal foster mother that can actually carry all the pregnancies for us. And my task within this biorescue project is just, to see whether, I can take embryos from a horse. Horse is genetically related to the rhino, okay? And then I take out, I cut off and discard the innocent mass. I end up with a trophoblastic vesicle. And then I take the rhino embryo made from artificial gametes, whatever. And then I take the innocent mass and I do kind of precision chimera. So I will have a chimeric embryo with a trophoblast from the horse embryo and the innocent mass from the rhino. And the horse will be the foster mother. Horse and rhino, they have the same pregnancy length, they have the same placentation, okay? But of course, before going to the rhino, much better to exploit, to see, to establish things using, easy available animals. Sheep and raw deers, actually, they really fit for the purposes. And so we started to do so. So of course, we need, first of all, it's a very invasive technology. We really wanted to know whether we can be so aggressive with the embryos and still hoping to get an offspring after that, after embryo transfer. So we have dissect them innocent mass by manipulation. I have a short movie. We did it first between sheep into sheep, just to see what happens. These are successful manipulations, see? These are reconstructed embryos, okay, embryo. We do the embryo transfer, you have something like 45% of these reconstructed embryos will make it into lambs. So we are very, very happy. So that we raise the stake, we move into the raw deers. These are, of course, we went back to in vivo produced embryos to make these experiments. Okay, these are sheep, they use blood, they are synchronized. These are raw deer blastocysts, beautiful ones. And okay, that's the raw deer embryos in all its beauty. They are really fascinating embryos. They undergo diapause, but that's another story. And now there's a short movie to show you, okay, how we really, the blastocyst there is immobilized. It doesn't move because actor don't move. And then he chop out the innocent mass. That's very, very, one as this goes to that kind of time lapse, you can be much more, fast. Okay. That's it. So you have here the innocent mass, the trophoblast. After 6-7 hours, you put the trophoblast back and it will respond nicely. And then you have to do the injection. That's the trickiest part of the work, because you have to take the innocent mass, which is very, very big and thick, and then the trophoblastic vesicle. You must use very large bore pipettes, and then we start to apply laser pulses from inside to outside, and then that's a very, very crucial. You need to be very concentrated, and then once you get the opening through, you just release, you enter the pipette, and you release the innocent mass, okay? You have the chimeric embryo. That's it. As you can see, it's quite, big load, okay? So, yeah, and then, going back to the original, so how to select the best embryo. When you are a skilled experimental embryologist, the pipettes, your holding pipette, your injection pipette becomes an extension of your finger. You can actually say which embryo will develop, which embryo will not. So really, that's what you get with experience. Of course, we are very well aware we can do time lapse. You are the top, in this doing this. Epigenetic profiling, genetic profiling, the next speaker is going to talk to you. Pluripotency marker, but I still, select based on my experience, the best size, the best embryos to work with. Again, assessing oocyte quality, that was another work done, because, the competence of these prepubertal lambs was quite low. So was it before of the nucleoplasmic maturation? The nucleus maturation, I wanted to say, sorry, in the cytoplasm, we do prenuclear shopping from sheep oocytes into lamb oocytes and vice versa. We did XC, so just biologically say, to test, the nuclear and cytoplasmic functionality in embryos. Just again, experimental embryology. Few slides, because we are never seeing. I've been working with all the embryos: mouse, rabbit, horse, sheep, goat, pigs, all those, but even human. We've done quite a lot of work with ICSI, the very heydays of ICSI a long time ago. Human oocytes are the best, the most really easy to work with. But so you select, you can see oocytes from these are sheep oocytes, they are much different from human. You cannot see anything through, because there are a lot of lipids inside the cytoplasm, so we need to evaluate carefully, the best ones. Normally we select those with a very clearly extruded polar body, so there are many, many morphological elements. You're all embryologists, you know what I'm talking about. And these are, again, sheep oocytes. You see, we evaluate the degree of expansion, and then beautiful polar body. These are the ones I do select to do nuclear transfer or whatever, or one genetic in reproduction. These are of average poor quality blastocysts. So that's, yes, again, we select embryos and oocytes on the basis of our experience, okay? Top quality. These are the blastocysts I'm very, keen to transfer, and hopefully they will get into lambs. I'm not going to show you time lapse because we are champion on this. And yes, we do, or just, again, going back to the embryo quality, we do some, staining to count the number of cells, or differential staining. These are inesema cell, and the pink one are the trophecto there. This is a neuro. Well, let's see if I'm able to get a movie. You are doing this now in my lab because I want to know. I cannot see pronuclei. So they only see to study cytoskeleton nuclear dynamics in sheep oocytes or bovine oocytes, just to inject messenger RNA for tubulin and messenger RNA for histone H2. But the movie doesn't go. Oh, yes. That's beautiful. So you can actually study, So you can see chromosome lagging behind, you can see. For us, doing nuclear transfer, doing X with dry spermatozoa, you really need to know this. So I'm working hard to get it established in my lab. So what can I say just to conclude? Embryo quality under the current, I'm talking about farm animals, procedure is very, very low. So it is really required to really reestablish, to rewrite completely all the protocols for in vitro embryo production. Yes, so far, if I really want to make a chimera, or if I really want to use oocytes for cloning, or doing X with dry spermatozoa, as I said, back to the future, I still resort, I go back to induced superovulation and get in vivo oocytes, or in vivo embryos, okay? So these are my conclusions. So yeah, we are still using a protocol established something like 25 and more years ago. Okay, so the quality of the gametes under this condition is no longer acceptable. We need somebody, and actually some embryologists are really working on that. And of course, as I told you, I go back using in vivo oocytes and embryos for my experiments. This is my team, the embryological team back in Teramo, in the veterinary faculty. And this is the biorescue team, which is dealing with the rhino preservation, if we will be able to do anything. Thank you very much for your attention.
Thank you, Professor, for such an interesting talk. I have just one question. What happened to the embryos of the white rhino?
What happened, sorry?
You were saying that you created embryos from the white rhino, the endangered species, so what ultimately happened?
We made some embryos. Some of the early embryos, they've been used to get embryonic stem cells. But now we are getting embryos. That's very complicated because you go to Kenya. After they pick up, the oocytes will go into a portable incubator. A helicopter is there, and then it goes to the airport. And the oocytes will mature on the way to Cremona in Italy. And then you got embryos, something like 15 so far. they are frozen, and they are going to, from time to time, when there are some female, all the rhino females available in some zoos, we do embryo transfer. So far, we don't have any pregnancy.
Okay, thank you.
I have one comment, sir. It was an eye-popping talk. And just one comment, I don't know how you take it. Are the animal gametes super good, or are human embryologists behind times? The flexibility that we saw with the animal gametes, do we have the same kind of flexibility with human gametes also?
Artificial gametes?
Yeah.
But yes, it has been done in mouse. You can make oocytes and spermatozoa that are fully fertile with offspring. They published a paper on Science Advances. Apparently, they are getting oocytes. Apparently, yes. You asked me about artificial gametes.
No, I'm saying, it's a comment, sir. Are the animal gametes super good, or are human embryologists super bad?
I'm so sorry. Sorry, I didn't sleep enough, last night. I'm not very concentrated. Oh, that's it. I think the more the gametes, as experimental embryology from human, they are the toughest ones. They are very, very resistant. You can dare a lot with human oocytes. You cannot do the same with mouse oocytes or sheep oocytes and cow. So human oocytes are the best and the toughest ones. Sorry.
Thank you, sir.
Yeah, there is another question over there.
Embryos and make blastocysts. Did you try with human embryos also?
No.
On day 2, day 3?
No, I never tried.
And
I don't think I can.
I have another question. How's the implantation rate with animals when you transfer embryos? Is it similar to human beings, or is it better?
I think it is better because, we are dealing with very normal and fertile animals. Fertility is not an issue in sheep, in cattle reproduction at all, pig reproduction. You don't have any problem. So normally you have a higher, percentage of, pregnancies. Yeah. These are fully fertile. You are luckier than you in this case.
Thank you, sir.
You're welcome.
Thank you, sir. For the third and the final talk in the inaugural session, thank you, sir. We invite Dr. Mina Popovic, PhD, Group Scientific Director for the Eugene Group in Spain. She is a geneticist and a clinical embryologist, currently the Scientific Director of the Eugene Group in Barcelona, Spain. Throughout her career, she gained extensive experience in embryogenetics in PGT, as well as modeling early human development in human stem cell biology. And she's here to talk on PGTA and mosaicism. The floor is yours, madam.
Thank you very much. Thank you for the kind introduction, and I would sincerely like to thank the organizers for this invitation. It is truly a pleasure to be here and also talk about one of my favorite topics, pre-implantation genetic testing and mosaicism. And these topics are really some of the most controversial ones within the field of assisted reproduction. I often refer to mosaicism as the ultimate diagnostic dilemma because there's still really no clinical consensus on whether we should diagnose it, how we should diagnose it, and what we should do with mosaic embryos. So chromosomal abnormalities or aneuploidies are highly prevalent in human embryos. They affect cellular homeostasis, and they lead to issues with cellular proliferation, and they impair embryo development. And for this reason, embryo aneuploidy is really a major factor that influences human reproductive success. We know that the percent of aneuploid embryos increases steadily with advancing maternal age, and this increase is mirrored by a decrease in fertility. And this is also why reproductive success in women over the age of 35 is reduced, even in assisted reproduction. But it has been suggested that ongoing pregnancy rates remain stable across all maternal age groups if a euploid embryo is transferred. So the selection of embryos free of abnormalities should theoretically improve clinical outcomes. And this is really the premise for pre-implantation genetic testing for aneuploidies. How is PGTA performed? Well, you may know, we take a trophectoderm biopsy from the embryo. We take about 5 to 10 cells. We extract the DNA from these cells, and then this DNA can be sequenced. Now we're using next generation sequencing. And the use of PGTA is really steadily increasing. These are just some statistics from the United States, and we can see that in 2018 already, up to 40% of all ART cycles actually included PGTA. And I think these numbers are much higher now, and some clinics are even performing PGTA on all of their cycles. But what complicates PGTA? Well, actually, chromosomal abnormalities in human embryos, their origin is varied. They can originate during meiosis, so during the formation of gametes, largely oocytes, and because they are present from the very beginning, they will affect the zygote and in fact affect all the cells within the embryo. And this is what we refer to as uniformly abnormal. So here are just some profiles following next generation sequencing. Sorry. Can I go back, please? Okay. So these are some profiles following next generation sequencing. On the bottom, you can see the different chromosome numbers. And what we are looking for is this baseline. So if there is no deviation from the baseline, we can conclude that there is no abnormality, so euploidy. But if we see a deviation, depending on where the values are plotting, for instance, here we see that there is a gain of a chromosome, chromosome 16, and it is reaching the threshold of what we would consider a uniform abnormality. So this embryo would be diagnosed with the trisomy 16 and, of course, would not be recommended for transfer. In this case, we see the opposite, so a loss of a chromosome, a monosomy. It's reaching the threshold of what we would consider a uniform abnormality, and again, we would not consider transferring this embryo. However, chromosomal abnormalities can also originate during the mitotic divisions that underlie embryogenesis. And in this case, only some of the cells will be affected. So the embryo actually ends up being a mix of normal and abnormal cells. It can also be a mix of all abnormal cells. But of course, the ones that are most clinically relevant are the ones that are a mix of normal and abnormal cells. And what do profiles look like in this case? Well, here, again, we have the chromosome number, and we can see an indication of an abnormality, in this case, chromosome loss of chromosome 3, but it is not quite reaching the threshold of what we would consider a uniform abnormality. So in this case, we can see that the values are reaching around minus 0.5, and we assume that around 50% of the cells within this biopsy actually carry the abnormality. Based on where these values are plotting, we can actually determine the level of mosaicism, so the percent of abnormal cells within the biopsy, which then maybe can be translated to the embryo. And mosaicism, in fact, is less pervasive as development progresses. We see it quite a lot during the pre-implantation stages, but it is actually only diagnosed in less than 2% of prenatal samples, and true fetal mosaicism is actually identified in only around 0.4% of cases and 0.2% of live births. So it is not a really common phenomenon. So why then all this controversy surrounding mosaicism? Well, when we used previous technologies for PGTA, such as RACGH, we didn't detect much mosaicism at the blastocyst stage. But with the introduction of next-generation sequencing, we're really seeing an increase in reports of mosaicism. And this is why it has really become a diagnostic dilemma. And following some papers that actually transferred embryos that were diagnosed as mosaic, and these embryos resulted in live births, even more controversy came around. And in fact, after several studies showing that these embryos do have developmental potential, mosaic diagnoses have emerged as a third category of possible ploidy outcomes following PGTA. But there are many challenges with diagnosing mosaicism. Of course, the biological challenges, but also technical challenges. And reservations regarding the clinical value of actually diagnosing mosaicism have led to a lot of complicated embryo transfer policies. We also know that if we diagnose mosaicism and we consider transferring a mosaic embryo, we have to counsel patients. But we are still really unaware of all the risks of transferring mosaic embryos as well, and this remains a concern. So as I mentioned, there are some technical challenges with next-generation sequencing, and it is important to be mindful of this. Of course, mosaicism is a biological phenomenon to some extent. We know this and we've seen this from experiments that actually divide blastocysts and compare different parts of blastocysts to look for mosaicism. But there are also some technical challenges. And with PGTA, we have to remember, as I mentioned, we're only starting from a few cells. So the DNA that we get from these cells is very low amounts. So once we extract the DNA, it actually has to undergo this step of whole genome amplification to get millions of copies of the DNA. These copies are then aligned to the genome, and then we can look for deviations from that baseline, as I showed you before. But what we hope for, of course, is an even amplification across the entire genome. But what often happens is actually an over or underrepresentation of certain parts. And this actually leads to biased amplification, and it can lead to technical noise on those profiles that I showed you. And these technical noise or the artifacts from sequencing may actually be indistinguishable from mosaic results. So it's very difficult to know if the embryo is in fact truly mosaic, or if we're just seeing a technical artifact and the embryo is in fact euploid. So all of these differences and problems with diagnosing mosaicism may actually impact the number of euploid embryos that are available for transfer. And I will get into that very soon. So during my PhD, I did a lot of research on mosaicism and on PGTA, and we are continuing this research. And today I will present some of this work. We approached studying the impact of diagnosing mosaicism in two ways. So firstly, we actually used an extended in vitro culture model, but then we also made use of the fact that our center has many different clinics and uses different providers for PGTA, and we actually compared all the results that we get from these different providers. And we wanted to look at how this may affect PGTA outcomes, including the number of embryos that are available for transfer. So first, some of our more fundamental research. For this study, as I said, we use this extended in vitro culture model. And what this model allows us to do is actually culture embryos up to day 12 in vitro. So we can plate the embryos on day 6 of development. They actually attach to the dish. They form this outgrowth, and then this outgrowth expands up to day 12. And when we stain these embryos, we can actually see structures that are associated with post-implantation development. So they express markers that are associated with these structures, such as in green, we have the epiblast, the hypoblast, and then we can also see the trophectoderm cells as well. So we cultured a total of around 200 blastocysts using this system. And these were PGTA embryos that were previously diagnosed either with uniform abnormalities, so as I mentioned, monosomies or trisomies, so gains and losses of chromosomes. Also, we had a number of mosaic embryos, and here we had two different groups. So the first group actually involved embryos that had an aneuploidy already, but also one of the chromosomes had a mosaic aberration. And then also a number of embryos that just had a single mosaic abnormality. And as controls, we had some euploid embryos as well. So the first thing we looked at is developmental outcomes. So as I said, we cultured all these embryos to day 12. And what we observed is that around half of them remained attached and viable throughout the extended culture, whereas the other half actually degenerated and detached somewhere after day 8. Whatever embryos made it to day 12, we actually then collected again for next generation sequencing so that we could compare the results at day 12 to the blastocyst biopsy. We also then compared the developmental outcomes to the trophectoderm biopsies, so this was the first step. And what we observed is that embryos that were diagnosed as euploid, those with trisomies or chromosomal gains, were significantly more likely to remain attached throughout the extended culture, whereas embryos that had monosomies or multiple abnormalities were significantly more likely to detach. And these results actually validated our model. They echo prenatal data. In miscarriage material, we never see monosomies, so it means that monosomies actually affect the embryo before implantation. We then looked at how these uniform abnormalities behaved throughout development, and what we actually see in all cases is that they persisted. So they remained within the embryo, which makes sense because these embryos, these abnormalities are meiotic in origin, and they persisted throughout development. We confirmed them in 100% of cases. What we also saw is that uniform abnormalities, so monosomies and trisomies, they do impact development of the embryos. We see this in our extended in vitro culture model. As you can see, here is a euploid embryo. We can see all of these structures quite nicely and distinctly. As I said, the epiblast in red, in yellow we see the hypoblast, and in the green we see the trophoblast cells. And as you can see, these embryos with abnormalities look quite different. The monosomies are in fact much smaller. We don't see any evidence of the epiblast. And here we had just one embryo with the trisomy 21 that also doesn't seem to have much trophoblast cells and has, doesn't really look like the euploid embryo. And we are looking into this a bit further at the moment. We also looked at the surface area of these outgrowths, especially in the cases of trisomies. As I said, these were predominantly attaching more. So if we look at the size of the trisomies, we can see that with viable trisomies, so 13, 18, and 21, they had a similar surface area compared to the euploid embryos, but with rare autosomal trisomies, we see that these outgrowths are much smaller, so they are impairing development. However, with the mosaic abnormalities, what we actually saw is that the majority of these remained attached throughout the extended culture. And when we look at the phenotypes of these embryos, we can see that they actually look quite similar to the euploid embryos. And when we compared the original diagnosis of mosaicism to the results on day 12, what we actually see is that they were largely not detected or confirmed later in development. So here we have, for instance, a mosaic monosomy 18, and we see that the outgrowth was euploid. In fact, for all of these single mosaic abnormalities, we never detected them at day 12. And here we have the aneuploid and mosaics. So here we have an aneuploidy in addition to several mosaic trisomies, for instance, and we can always detect the uniform abnormality, but we don't see any evidence of the mosaicism. And these are just some profiles to convince you further. Here actually we looked at both low and high-grade mosaics, so originally diagnosed in the blastocyst biopsy, and we don't see any evidence of them. So in the top row, it's actually embryos that were diagnosed with low-grade mosaicism, so 30 to 40% abnormal cells. And this embryo in particular was diagnosed with a mosaic monosomy 9, and as you can see, we see no evidence of this abnormality, so no deviation from the baseline. And another embryo with a mosaic monosomy 8, again, no evidence of this abnormality at day 12. And here are, in fact, two other examples of embryos that were diagnosed with high-grade mosaicism, so 40 to 70%. And even with high-grade mosaicism, we did not confirm this at day 12. And just finally, some examples of embryos that were diagnosed with a uniform abnormality in addition to mosaicism. So these were the aneuploid mosaics. And as you can see, in both of these cases, we actually can confirm the uniform abnormality, so in this case a trisomy 8, in this case a monosomy 16, but we do not detect the mosaic aberration in either of these embryos. So what these results tell us is actually that, well, we see 100% concordance for whole chromosome uniform abnormalities. So this is quite reassuring for PGTA. It means that it is quite accurate in diagnosing meiotic abnormalities, and we see that these affect development. So we should not transfer, of course, aneuploid embryos. But we also see that positive predictive value is actually considerably reduced when diagnosing mosaicism. So these mosaic diagnoses are actually largely associated with false positives. And this, of course, raises significant concerns regarding the accuracy and more so even the relevance of these mosaic predictions. So given these problems with accuracy, we, as I mentioned, wanted to evaluate these disparities across different PGTA providers and look at if there were differences in diagnosis across different genetic laboratories. So to do so, we reviewed 36,395 consecutive PGTA cycles in a retrospective international multi-center study. Our PGTA results were obtained from around 10,000 patients and across around 11,000 cycles, close to 12,000 cycles. And the cycles were performed between 2015 and 2021. And in our study, actually 17 IVF centers participated across 8 different genetic testing providers and 5 countries. So as I mentioned, 8 different PGTA providers. We labeled this from provider A to provider H. Provider H had the most PGTA results, so this provider served as our reference. And as you can see, some providers only served 1 clinic, but other providers actually served several clinics. So for instance, provider C served 2 clinics, or provider F served 4 clinics. And in provider H, we actually had several clinics. So we used multi-level mixed linear regression, and the main thing is we actually compared associations between PGTA providers and outcomes. In doing so, we adjusted for several confounders, and our analysis included both autologous as well as oocyte donation cycles using next-generation sequencing. We also evaluated embryo transfer rates across 15 clinics. So there were some clinics that transferred mosaic embryos, so we wanted to look at the outcomes following these transfers, and this included 245 mosaic blastocyst transfers. So first, looking at just some patient characteristics across our providers. So as I mentioned, our study included around 10,000 patients. The mean maternal age was 36.2 years, and mean paternal age 40 years. And as I mentioned, some of the cycles were oocyte donation cycles, around 10% across the entire cohort. But as you can see, in some providers, we had 0% oocyte donation, and in some up to 30%. So when we looked at the results across the different providers, we can actually see that provider A only diagnosed embryos as euploid or aneuploid, so they did not report mosaicism, whereas providers B to H all diagnosed mosaicism. And when we look at the overall ploidy rates, we can see that 49.4% of embryos were diagnosed as aneuploid, 44.9% as euploid, and 5.7% mosaic across the entire cohort. But as you can see, there's quite some variability in the diagnosis of mosaicism across the different providers. Our adjusted analysis then revealed certain predictors of euploidy and mosaicism. So as expected, the odds of diagnosing euploidy were significantly lower with advancing maternal age, but we didn't see an effect of maternal age on diagnosis of mosaicism. And we also observed that embryos that were biopsied on day 6 and 7 actually had lower odds of euploidy compared to those biopsied on day 5. And we confirmed that paternal age and the number of embryos had no effect on diagnosis of euploidy or mosaicism. And also the day of biopsy had no effect on mosaicism. We then looked at the different results across the clinics. We wanted to look and see if there is actually an effect of the clinic as well. And for this, we looked at the providers that were serving several clinics. And if we look at provider F, we actually see that there was no effect of the clinic on diagnosis of euploidy or mosaicism. And when we look at the clinics within provider H, well, here clinic A1 had higher odds of diagnosing euploidy, but there was no difference amongst the other clinics. So there could be some other effects or patient characteristics that affect diagnosis, well, that affect actually aneuploidy more so than euploidy. We saw that actually the clinics had no effect on the diagnosis of mosaicism. So at least in our study, we don't see that technical factors influence the predictions of mosaicism. Our adjusted analysis showed that the provider was the strongest predictor of PGTA results. And what we actually observed is quite some variation in the diagnosis of mosaicism. As you can see, this diagnosis varied from 3% up to 25%. And we also observed that 5 providers had significantly higher odds of diagnosing euploidy, whereas the odds of diagnosing mosaicism was significantly lower for provider B and provider C, and significantly higher for provider E. We then also looked at the chance of having at least one euploid embryo available for transfer. And here, chances were highest for those providers that had the lowest, significantly lowest rates of mosaicism, and also for the provider that did not report mosaicism. And in fact, overall, the chance of having at least one euploid blastocyst available for transfer increased significantly when mosaicism was not reported. So when we compared provider A to all the other providers that reported mosaicism. We also looked at the rates of single uniform aneuploidies and single mosaic aberrations across the different providers. And as you can see, for the single uniform aneuploidies, we see quite similar rates across all the providers, which really reflects biology. Whereas with the single mosaic aberrations, we did see a lot of variation. And this really points to a technical bias. We then also looked at diagnoses per chromosome. So when we look at the single uniform abnormalities, we confirmed that abnormalities that are associated with chromosome 15, 16, 21, and 22 were the most common. This has already been characterized, and these results were very consistent across all the providers. So again, reflecting true biology. When we look at the single mosaic aberrations, we saw no real trend for the chromosomes, but what we did observe, and it was very interesting, was this significantly higher rate of mosaicism associated with chromosome 19, particularly mosaic trisomies 19. And this is very interesting because chromosome 19 is very difficult to sequence, in fact. So this result also points to technical bias. Finally, we looked at clinical outcomes following the transfer of mosaic embryo. As I mentioned, a total of 245 embryos were transferred. But when we look at blastocyst transfer rates, we observed quite some differences. And only, in fact, up to 13% of embryos that were diagnosed as mosaic were actually transferred. And we can see that some providers actually did not transfer mosaic embryos at all, with some clinics, and some transferred up to 36.5%. When we look at outcomes, we observed that the clinical pregnancy rate following the transfer of these mosaic embryos was 41.1% and around 35% of live births. When we compare these results to those following the transfer of a euploid embryo, we actually see that they're identical. So clinical pregnancy rate of 42%, and again, live birth rate of 35%. So our results really reveal a strong association between the genetic testing provider and PGTA results, which is in fact quite striking. And we show that classifying embryos as mosaic may actually come at the expense of euploid diagnosis. So despite their normal developmental potential, as we show both in our in vitro studies and has been shown following the transfer of mosaic embryos, actually close to 90% of these embryos are not used clinically. And differences in mosaic diagnosis across these different providers actually point more to a technical bias than really reflect true biological variability. So we have to be very careful, and we highlight really the need for a strong standardization and quality assurance in the industry. These false positive diagnoses may actually play a role in the failure of PGTA to demonstrate improved outcomes. As you can see, PGTA is very good in diagnosing uniform abnormalities. Current practices limit the utility of PGTA as we are excluding potentially viable embryos, and this really represents a problem, especially for patients that only have a few embryos available for biopsy. So until we can be sure that the diagnosis of mosaicism really accurately reflects biological variability, reporting it remains very difficult to justify, as it really can determine the difference between success or failure for our patients. So thank you very much for your attention, and I would like to thank our collaborators that helped with these studies.
Hello. Thank you, Dr. Meena, for such an interesting session. And of course, we need to relook into our mosaic embryos, I think. If there is any question, yeah. Can you please provide the mic? We'll provide the mic.
Excuse me. Can you just highlight on the type of fertilization for the PGT cycles?
Sorry?
Can you please highlight on the type of fertilization in the PGT cycles? Was it IVF or ICSI?
For the
like
PGTA
into your studies,
cycles?
yes.
Largely ICSI cycles, yes.
Into your experience, have you found any difference with an IVF fertilization and the outcomes versus an ICSI fertilization?
No, we didn't look at that, but the majority of the cycles that were in our study were actually ICSI cycles, so that would be very difficult to compare.
Thank you.
Hi. So, thank you for your talk. The live births that you reported in the last table, do you know if they're healthy live births, and are there any plans to follow up these children?
Yeah, unfortunately, this is really quite difficult. For some, they did some testing and they saw no, they were healthy live births. We didn't do it, we couldn't do it across all the different providers and clinics. It's very difficult to follow up. But that would be great if we could. And in many cases, actually, there hasn't been much follow-up, but there have been a few studies that have actually confirmed mosaicism. There's only a handful of cases that have actually confirmed the original mosaicism in the live birth, but it's very rare. Most of the testing that's been done has shown that these embryos and the fetuses and babies are completely euploid and healthy.
Dr. Meena, may I comment on the first question? Meena? May I comment on the first question?
Sure.
Yes, so regarding the question of the insemination method, we have published a paper a couple of years ago comparing in sibling oocytes, IVF versus ICSI, and we found out no significant difference between the PGTA outcomes. And also, in order to validate the effect of IVF in case there is spermal contamination, what we've done is we sampled on purpose sperm cells, like 2, 3, 4, 5, 1 to 5 sperm cells, because if by mistake you will take a sperm cell, it will not be 100 sperm cells, right? So up to 5 cells, and we've done the amplification, and it was not affecting the PGTA results. So we can say that it's safe. However, we still need to be, very careful when we do the biopsy for inseminated embryos by IVF, but we can do it.
Yes.
Thank you for that question. That's a beautiful example of not following a dogma. Because you see, we tend to follow a dogma. Everyone said you have to do ICSI for PGTA. And we had this discussion in-house. I remember when I said, let's do a study, IVF versus ICSI, all the embryologists were telling me, no, you cannot do that, it has to be ICSI. I said, no, who says so? They say so. I said, who are they? Who are they? So then we started doing that study, and at the end we published it in Human Reproduction. There is no difference. So this is exactly the point. You always have to put a question mark behind what you know, and maybe sometimes unlearn and relearn.
Hi, I do have a question. So the diagnostic tool that we used, in the paper that you showed, there was biopsy being used for sampling. So is it possible to have a more accurate result using non-invasive chromosomal screening using spent culture media?
So is it more accurate to use non-invasive testing? Well, I think we already have challenges with the invasive. So I think the non-invasive will in fact be more inaccurate because we are dealing with fragmented DNA that is being released from the embryo. So there are two issues there. Firstly, this idea that the embryo may in fact be undergoing some kind of self-correction process, at least in some cases. So then the cells that may be released in this medium may actually not be reflective at all of the status of the embryo. So that's one consideration. The other thing is actually, as I mentioned, the technical sampling of this DNA. A lot of this DNA is fragmented, it's quite difficult to amplify, so it can also lead to a lot of bias. But the positive of non-invasive PGTA is the way it's currently used is that it actually ranks embryos. So unlike invasive PGTA in which we have a binary outcome, so we either transfer or not transfer the embryo, with non-invasive PGTA it's a ranking system. So with this system we would not be excluding any embryos for transfer, and this may be more beneficial in the sense that with PGTA we are seeing that we are in fact excluding quite some embryos.
Thank you. Also, the clinical pregnancy results that were displayed, were all the transfers single embryo transfers, or there were a few double embryo transfers as well?
No, yeah, there were some double embryo transfers. So the results that we showed were per embryo transferred, not per embryo transfer. So that's why they could be a bit lower in some cases, especially the implantation rates.
Thank you.
I have one question. So just because the different providers had different mosaicism rates. So is there an acceptable rate of mosaicism by which we can quantify or we can say that this provider is doing a good job with PGTA? And if there is something like that, or if a provider has a high rate of mosaicism, so this means they are not doing good work with PGTA or
Well,
analysis?
we from all the studies so far, we assume that mosaicism is present biologically in about 2 to 3% of cases. So we would expect that diagnosis should be around 2 to 3% of all the embryos, so all the PGTA results. So this is a measure. It is a conversation to have with genetic providers, also to ask them how they validated the diagnosis of mosaicism. Did they use cell mixes? Can they accurately detect the levels? What type of mosaicism they're actually diagnosing? So some providers are also diagnosing mosaicism for smaller subchromosomal abnormalities, so segmental aberrations, and these are actually being shown to have equivalent outcomes to euploid embryos. So there is not much maybe relevance in diagnosing these, but if they are diagnosing them, of course, then their rates of mosaicism will be much higher compared to a provider that's only diagnosing mosaicism of whole chromosomes. So it's something to keep in mind and something to evaluate with your genetic testing laboratory.
Thank you. So now we will close this session. Thank you all the speakers for such enlightening talks today. We will move on to the next session.
Thank you so much to the chair for chairing the session. An announcement for the next SIG session will start in the adjacent hall at 12:30. It is on PGTA by Dr. Meena Popovich, Dr. Parul Khatyar, and Ibrahim El Khatib. Moving on to our next session, the panel discussion on art of ovarian stimulation. May I please invite our moderator, Dr. Barbara Lawrence, on stage. Dr. Barbara obtained her medical degree from Germany in 1989 and completed her specialization in gynecology and obstetrics in 1995. In 2004, she also gained expertise in obstetrics and perinatal medicine, followed by gynecological endocrinology and reproductive medicine. She has authored and co-authored 65 PubMed-reviewed articles in international journals and additional articles in various prestigious German journals. Dr. Lawrence is the head of IVF Department of Women's University Hospital in Germany and is an esteemed member of ESHRE. Hi. May I please invite the panelists for the session. Professor Dr. Human Fatemi, sir. Group Medical Director, ART Fertility Clinics. Dr. Meenakshi Dua, Clinical Director, ART Fertility Clinics, Gurgaon. She's a renowned infertility specialist with a career spanning of 18 years in obstetrics and gynecology. Her areas of interest are poor responders, recurrent implantation failure, and male infertility. Our next panelist, Dr. Sonu Balara, Senior Consultant, ART Fertility Clinics, Gurgaon. She has over 25 years of extensive knowledge in reproductive medicine, and her core areas include reproductive medicine, IVF, and IUI. No, she's moderating. Moderating. May I please invite our next panelist, Dr. Alia Reddy, Clinical Director, ART Fertility Clinics, Hyderabad. Dr. Alia is an esteemed fertility specialist with over 3 decades of experience in this field. She has extensive experience in handling all kinds of infertility cases. She follows an evidence-based treatment for all her patients. The next panelist, Dr. Azadi Patel, Clinical Director, ART Fertility Clinics, Ahmedabad. Dr. Azadi Patel holds a gold medal in MS Obstetrics and Gynecology and has completed her fellowship in reproductive endocrinology and infertility as a part of Master of Human Reproduction program. Dr. Azadi. Next panelist, Dr. Hema Vaidyanathan, Consultant, ART Fertility Clinics, Chennai. Dr. Hema holds an extensive experience in the field of reproductive medicine. She has published a few theses and has given various poster and paper presentations as an author in conferences held by ESHRE, ASRM, and other esteemed organizations. Yeah. Dr. Shrestha Sagar, Consultant, ART Fertility Clinics, Delhi. Fatemi sir has a question. Do I ask a specific question? Can do turn on, but if we do specific, it will be easier. So, yeah. May I please invite Professor Fatemi for the panel?
So, good morning from my side also. I'm very happy to join you here in India. So for me, it's the 3rd time in India. It's always amazing to be here. So the topic what we are talking about is the art. So I mean, we are ART clinic, but here it's the art of ovarian stimulation. And please, if someone could throw up the questions for the panelists, because I think then it's also easier to follow for our attendees. The questions, please. We need to have the presentation, please. Okay, good. So to move to the first slide. So we are, thank you. Okay.
Can you reduce the lights, please? They are blinding us.
So we are talking about the ART. How do we do stimulation best? And of course, my first question to the panelists is, should we stimulate in a way that we retrieve the highest possible number of oocytes? Because of course there had been also questions and doubts. If we do a very high dosage stimulation, maybe we are impacting the quality of the oocytes, impacting the quality of the embryos. We are putting our patients at risk. So what should we do? Please. Dr. Alia.
Dr. Alia Reddy. The ultimate aim for us is to get optimal number of oocytes. So the individualized stimulation should be to get the best mature for oocytes when we do our ovarian stimulation. So first we have to identify the patients. If they are poor responders, they are normal responders or hyper responders. Depending on them, we take the markers, which are the basal markers like AMH, AFC, and basal FSH. And these days, I think we have to even add BMI for that, so that to have a proper ovarian stimulation. If we do very little stimulation also, we might land up in a poor IVF, poor response, or too high, we might land up in a OHSS, which is bad for the patient, and it might even affect if you have more number of oocytes, it might affect the patient and the implantation and the quality of the oocytes also. So we have to have a very much accurate, depending on these parameters, to get the optimal number of matured oocytes.
Okay, thank you very much for this answer. Of course, we all know that numbers matter, and I just would highlight regarding what means numbers matter. So the ideal approach, of course, is that when we have a couple who wants to have a family, we do one treatment, we freeze embryos, and the patient does not have to undergo any other stimulation again. However, there was a publication which was called like the one and done approach. And even in patients who had more than 15 oocytes and are trying to achieve a family of 2 kids, so of course only 20% of those patients who were stimulated who had more than 15 oocytes were able to reach this goal. And we all know that the idea of family size depends on the cultural background. For example, in UAE, it's like 5-6 kids. Europe, it's more than 2 kids. I'm not sure about India. But of course, we have to know that number matters, and we have to try to achieve as many oocytes as possible. Then let me move to the next question in the context. Of course, when we stimulate a patient with a high dosage, we are at risk of ovarian hyperstimulation. So do we have to be afraid about hyperstimulation nowadays?
I didn't get the question.
So do we have to be afraid that we are sending our patient into ovarian hyperstimulation when we treat them with a high dosage, let's say in a high responder patient, or can we anticipate and manage this accordingly?
No, nowadays we have strategies to minimize the risk of ovarian hyperstimulation. Like we individualize the dose for stimulation, the gonadotrophins. Then as we are doing most of the antagonist cycles, so we have the agonist trigger, which minimizes, and we do a freeze-all cycle so that the risk of ovarian hyperstimulation that is minimized.
Yes, that's perfect. So I mean, this is what was formulated by Devroy quite a couple of years ago, the dream of the OHSS-free clinic. And usually, I think like in more than 99% we can achieve this. We still have a couple of patients who might not, are still for risk for developing OHSS. So in our clinic, what we are doing when we see a patient who has a really high number of oocytes, even after oocyte retrieval, we try to reduce the hormonal levels. We give antagonists, we give Femara, we'll give additional Dostinex to reduce the risk. And it's hardly, Dr. Fatemi, just tell me in case I'm wrong, but it's hardly that we see any case of ovarian hyperstimulation. And the right answer is what we'll have to do. We'll have to anticipate, we'll have to stimulate in a GnRH antagonist protocol and use a GnRH agonist.
Can I ask a question? does the agonist work with all patients for final oocyte maturation?
Dr. Meenakshi, you want to take over?
No, it does not, and it also affects the oocyte quality, and HCG is actually a better trigger, but we have to weigh benefit and pros and cons for in patients where we can add little HCG or where we should actually just negate it.
But can we anticipate if a patient is going to fail to have a final maturation with an agonist triggering? Are there any tools to anticipate that?
Serum LH levels on the day of trigger, and even the starting basal LH levels can tell us in which patients we should use decapeptyl trigger or in which we have to add HCG trigger as well to get final maturity.
So technically, so like you correctly mentioned, Dr. Dua, day 2, 3 basal LH levels are extremely important. But technically, what value should we have to anticipate that this patient is going to respond to the triggering or not?
Basal 1.5 LH at least it should be before we start. If it's less than that, then definitely she will need HCG trigger.
Exactly. So there was a publication by Biljana Popovic in Human Reproduction 3-4 years ago. If your LH levels, day 2 or 3 of the cycle, are less than 1.5, there is a high probability that the agonist triggering will not do its job.
And I think also in this sense, we will have to individualize the trigger. We can use a dual trigger. And then, for example, if we have a slim patient, we do not have to take 5,000 or 10,000 units of ACG. We can reduce. We can take 2,500 or even a lower dosage. But it's important to have an effect of the ACG. So coming to the next question. So we triggered a patient with an agonist. So what is about the luteal phase? I mean, we are talking often about freeze-all, but maybe this is not desired by the patient. Maybe the clinic setting is not in the sense that we are having good results with the freezing. So what do we know about the luteal phase after a GnRH agonist trigger?
We can do an ultrasound on the day 4 and 5. We can check the corpus luteum. If they are big and there's little fluid, we can avoid transferring, but yes, in case they have regressed and there's no fluid, we can go for a fresh transfer. Then the chance of OHSS will be less. But late OHSS can definitely happen in those patients.
No, I wanted to point towards the luteal phase. What do we have to expect regarding the luteal phase when we use an agonist trigger? What will happen?
It will be affected because GnRH agonist is going to kill the corpus luteum, so serum progesterone will drop immediately, and the window of implantation will be affected. Implantation rates will be affected if we do a fresh transfer in those cases.
So we'll have to be aware that we have to expect a severe luteal lysis when we use a GnRH agonist trigger. So you can see here on the screen the luteal phase during a normal cycle and what will happen in a hyperstimulated cycle. What is the reason behind it? Of course, because we are manipulating the system, we have supraphysiological hormonal levels, and our agonist trigger also has a lower duration of an LH peak, so we'll have to expect and anticipate a severe luteal phase defect when we use an agonist trigger. There had been some publications from Engman that they do a very intensified luteal phase support using estrogen, using progesterone vaginally, and IM, which might counterbalance, but I think nowadays when we have a good lab, we should use a freeze-all approach, especially as also data have shown that the outcomes are better with a frozen embryo transfer compared to fresh embryo transfers. So let's move to the next question. Ovarian reserve parameters, I think we all acknowledge how important they are, but the question is, how reliable are our AMH results?
AMH is having intracycle and the intercycle variation. So AMH will be high in the follicular phase and it is lower in luteal phase because it is secreted by the granulosa cells of early antral follicles and small follicles up to 2 to 6 millimeter. So it is not so, so we should keep this in mind that AMH has intercycle and intracycle variation.
Yes, and for this, I fully agree, and for this, I would like to point to the graph or study which was done by my colleague, Dr. Laura Melado, among fertile volunteers, and they followed the AMH throughout the cycle. And you can see in some patients or in some volunteers, in these cases, it's quite stable. But in some, we have huge fluctuations. So we'll have to be aware when, in which part of the cycle, AMH was taken.
May I please comment?
Yes.
Not only which part of the cycles, but which part of India. Because my impression is, looking to various patients in India, that also the quality of the labs are not always very reliable. I elaborated previously with progesterone, but also AMH is the same. Quality control of the blood lab is extremely important. And we need to have a correlation between the antral follicle count and AMH. And very often I see in India that this correlation is not there. So we should also be critical if we receive an AMH value, if this is really reflected with the antral follicle count. I think that's also very important.
Okay, so I mean, you mentioned AFC, and this is just perfect because it's moving on to my next slide. So sometimes, I mean, usually we expect to have a good correlation between AMH and AFC, but sometimes we are really afraid, and I just brought you an overview of one of our patients. So have a look at this. This patient had an AMH of 0.08. So looking only at the AMH, we might have wondered whether we should treat this patient at all. But then we did a scan, and what was seen, I mean, the ovaries looked like PCO syndrome. So can you comment on this, what we should do in those cases?
Yes. Usually AMH and AFC are having a very good predictive accuracy for us to predict ovarian response. But very often we see this discrepancy between AMH and AFC in our clinical practice. But this difference could be explained by factors like AMH having a high inter-laboratory variation, as well as the laboratories detect different isoforms of AMH, and that also give a varying results. And I think if I have to decide between AMH or AFC for my putting an individualized ovarian stimulation, I would go with the antral follicular count. If there is a discrepancy.
So this was also what we did here, because looking at the AMH, most probably you would have had to choose like a dosage of 450 units. This patient would have ended up with a high risk of cancellation because of pain, of risk for OHSS. So here we stimulated according to the AFC with a gonadotropin dosage of 150 units. And also we looked again with Dr. Laura Melado into different isoforms of AMH. And also this is something which we'll have to keep in mind. Maybe the assay what we are using is not measuring all the isoforms which are present in our patient, so which might impact our result. So always we'll have to take care that we are looking at both of the ovarian reserve markers, AMH and AFC, to treat our patient accordingly.
Can I comment on that? So this patient is a patient I have seen. She did an AMH testing in 3 different labs in the UAE, in Dubai, Abu Dhabi, and in Sharjah. All the labs, also using different assays, they all came with an AMH of 0.01, 0.02, and they all told her, you are in a menopause. So we did a scan with her. She had an antral follicle count of 10 to 12 on each side, and she had a regular cycle. So the first question to ask ourselves is, how does it come that this patient has an AMH of 0, but has so many follicles? The answer is very simple. These assays are looking to a certain protein, and this patient was not expressing that protein. So we did a whole exome sequencing, and we also identified the gene which is responsible of creating that. So this patient had a kind of defective AMH. Now, this lack of AMH is also explaining why she is such a high responder. Do you know why she is such a high responder? Because AMH has a function. The function of AMH is to prevent very, very small follicles to be recruited. But this is not there because her AMH is not working properly. This is why she's a high responder. So she's recruiting constantly a lot of follicles, but that also means that most probably at some point she's going to go earlier to menopause because all these follicles are recruited rapidly. So this case, we are currently busy of writing it down as a case report, and then we send some samples to Texas in the US to do a couple of specific analyses with different assays, but it's a very interesting case to be published, and hopefully it's going to be published soon.
Okay, so let's move on to the question of progesterone elevation. I mean, when we are freezing oocytes or embryos, we are not that concerned because we do not want to do a fresh embryo transfer. But still, what are the factors which are important when we think about progesterone elevation? Where is the progesterone coming from? And this is what I just would like to point to before I come to my question. So we know that especially high responder patients who are stimulated with a high amount of gonadotropins are at a risk for having progesterone elevation on the day of trigger. So of course my question now is, how do we avoid it?
Yeah, so when we stimulate the patient for IVF, we should focus on having an optimal stimulation and not overstimulating, as you just showed. The source of progesterone in an IVF stimulation is through the steroids, mainly estrogen. So we have to prevent high level of estrogen to have, not to have a high level of progesterone. That is one. So that is optimum stimulation. Second, to avoid a very prolonged stimulation in cases where we might need to trigger a little early. And yeah, so mainly these two.
Yes, right. So what I brought with you is a typical type of stimulation, how it's going when we are giving daily injections. So we need a few days to reach the threshold, the critical threshold. We have this long-acting substance where we have like a good amount of FSH activity and then it's declining, which is much more related to also how ovarian growth follicular growth is going in a natural cycle. And the reason also why we do not need that much FSH towards the end of stimulation is because we are seeing a shift of receptors from FSH, from a predominance of FSH receptors in smaller follicles to a shift to mainly predominance of LH receptors. So which means in the end we do not need that much FSH at all. And also this was a publication coming from our group where we compared the daily recombinant FSH application to the long-acting, and when we see that we have a shorter time of duration, for sure the incidence of progesterone elevation was a lot lower when we were using the medication which had a decline of the FSH activity. So how do we do it technically, practically? And that's why I brought you an overview from our clinic. So in this patient, she is a good responder. So we started with 300 units. But then maybe it's a bit difficult now to see. But if you look here at the lower part, so in this area on day stimulation, day 8, we have seen that we are having a progesterone of 0.5. We had a nice follicle growth. We had adequate estradiol levels. So what we started to reduce, because we were anticipating that progesterone might go up, we started to reduce the gonadotropin dosage. And what you can see, despite we are having still a nice follicle growth and we are having an increase of the estradiol level, progesterone stayed nicely in a low range. So, coming to the next question, moving forward. We are doing a nice stimulation, now we think about the trigger. I'm happy with using the word dogma, which we are hearing a lot in Abu Dhabi. So usually the dogma is we should trigger at a follicle size of 17 millimeters. So, however, does this apply for everyone? And how do we treat, how do we deal in poor response patients? I think we are starting again at the beginning. Dr. Alia.
As women ages, there is a release of premature luteinization on the follicles, matured follicles. So one doesn't fit everybody. So we, as the age advances, like you take 16, 17 for a 30, 35-year-old person, but as because this premature luteinization creates an atmosphere which could be toxic to the major oocyte. So we have to think about the age of the patient and then decide when to trigger, what size we have to take when we have to trigger. Like for if you take a case of 35 to 40, you can trigger it at 15 or 14 also. And above 40, even 14 and 12 size also, we'll get a matured oocyte. And after 45, even 12 size of follicle also we will get a matured oocyte.
Yes, exactly. And so I brought you another overview. I hope you still can see it. So we have a patient with a low AMH, an advanced maternal age. And yes, you can see here Also, we have just a very poor response, so there's no major follicle development on her left side. On her right ovary, she had a follicle of 13, 12, 9, 7, and 6, and she was triggered the day after. So we collected a total of 3 oocytes, and all of 3 them had been mature. So we should not be too afraid of triggering too early in patients with an advanced maternal age with a low AMH. So because usually we find mature oocytes even from a follicle size of 12, 13 onwards. And I think this is also reflected in the cycle length of a patient, because when you ask them, usually they do not have like 28-day cycles, they have shorter cycles, 24, 25 days, which also gives an indication for early triggering. So another question, this is again related to the way how we stimulate, can be reduced. Do we have the same FSH levels in all patients on the day of the trigger?
So depending on the FSH level, then we start the stimulation. So
No, on the day of trigger, so when we think about the end of the stimulation.
So on the day of trigger, like we do the FSH level. So if it is, I didn't get your...
Well, in the end, I think what I want to point to is that we'll have to take into account
we have to reduce the
characteristics. And even when we have a similar FSH dosage what we stimulate, so what do we expect on the day of trigger when we are looking into the FSH levels?
So most of the FSH receptors, like they are occupied.
Yes, and what we see, I mean, we see that we can have huge ranges of FSH levels on the day of trigger. And what I want to point to is that we'll do the step down as described previously to avoid progesterone elevation, but we do not have to be afraid of having lower FSH levels on the day of trigger, because we still get a good result even when we do this careful step down. So what's about different isoforms of FSH? Do we have different isoforms? Do we have to take them into account somehow in our cycle planning and when we use different medications?
Yeah, sometimes we have patients who have different isoform. FSH receptor polymorphism is there, and with that they need higher doses of FSH and maybe more of recombinant. Sometimes urinary doesn't work, or basic and acidic, those forms we have to check and decide which one is working better on them, and correlate the FSH levels with the follicular growth.
Yes, right. So because what I want to point your awareness is that even in vivo, so FSH is produced in different isoforms. It has different electrical charging, and this is the one which is in the end reflecting the biological activity. So when we look into a natural cycle, we know that the longer active isoforms of FSH are more prevalent when we are recruiting follicles. The shorter, the more basic ones, which are more biological activity, are around ovulation. However, we also have to be aware that the different isoforms what we are using, the medications, the preparations, are having different activities. So at the last point, so when we do have a patient who had a previous C-section, what do we have to take care of when we are doing stimulation or embryo transfer?
In previous cesarean patients, we should look for isthmocele. That is the collection at the site of scar. It may be there in some cases in which there was no proper stitching during the previous cesarean section. Because this has an impact in this cycle, if that fluid comes in the cavity, it impairs, decrease the result of IVF.
Yes, right. So I think it's two things. So first we'll have to be aware that we might see more and more patients who are having an isthmocele because more and more C-section deliveries are done. Secondly, we'll have to be careful. We'll have to watch them closely when we do ovarian stimulation, because we might see fluid accumulation in the cavity. And we know that when we have fluid in the cavity, we would reduce the chance of a pregnancy when we do the embryo transfer. However, also what we have seen in our group is that when we exclude intracavitary fluid, when we return an euploid embryo, then we have a same chance of a pregnancy. So I think we are almost done with our session here. Thank you very much for your participation. Any questions from the audience?
So 2 questions. One is when you're doing the oocyte pickup for women of advanced maternal age at 12 mm and 13 mm size of follicle, do you also correlate it with the estradiol levels, or it's just done by the size of the follicle?
I didn't get the question.
Yeah, the estradiol levels are of course important. And you know, the most important thing with this early triggering is the cycle length of that patient. Because if the patient has a short cycle, the short cycle is a reflection of an accelerated nuclear and cytoplasmic maturation of this patient. Now, how does it happen? You see, a patient who is a poor responder, she already has elevated systemic FSH levels. So FSH levels are not 5 or 4, they are maybe 12, 13, or 11. We know that FSH increases the number of LH receptors. It means that patient is exposed already to high levels of FSH naturally, because that follicle is being recruited already in the luteal phase of the previous cycle. So you have the selection and exposure to high FSH for a long time from the previous cycle. These patients, first of all, day 2 or 3 of the cycle, they don't have follicles of 3, 4, 5 millimeters. Their follicles are already maybe 8, 9, maybe 7 millimeters, and the estradiol levels are already elevated. Now, when this follicle is growing, sometimes in a natural cycle, maybe already at day 9 or day 8, this follicle might be 14, 15 millimeters, but that follicle, because it has a lot of LH receptors, because it was exposed to a lot of FSH, it will mature faster. So this is why this new concept of individualized triggering and egg retrieval with these patients should be linked to various factors. The first factor is the cycle length of the patient. That's very important. You might have a very low AMH, but you still have a normal cycle of 28 days. If the cycle is not shortened, even though if she has low AMH, then it's not good maybe to trigger very early. The second, as you correctly mentioned, is the steroid production of that follicle. So these granulosa cells, they have a certain activity. So if you wait and you trigger, for example, at 13 millimeters, but your estradiol levels are very low, still that's not a good sign. So you need to put a couple of variables into equation. One is the cycle length. The second one is the FSH on day 2 or 3 of the cycle, so it needs to be elevated. What is elevated? It's being debated, but at least 10 or above, and then the steroid production of that follicle. So if the follicle is, let's say, 12 millimeters, she has high FSH, but estradiol is low, progesterone is very low. You see, progesterone, it's always a reflection of the number of LH receptors. So if your progesterone is 0.1, for example, on day 8 or 9, the follicle is 12, that means that follicle did not generate enough LH receptors. So the progesterone that you measure is a direct reflection of the number of LH receptors. And if you don't have enough LH receptors, you will not have enough progesterone. It means that might be too early for that follicle to be triggered. And also that is not one size fits all. So it's a very important question you have asked. Yes, the endocrine profile is extremely important to put in the equation here.
So that's actually the point I wanted to bring, because we can't just go primarily by the follicle size, because in the older women, you invariably find when you see them on day 2 or 3, the follicles is already sometimes 10, sometimes even 11 millimeters. So we'll need to correlate both the things before we actually do a pickup.
Absolutely, yes.
Can I ask one question?
Please.
Thank you. When we are talking of AMH, have you had the correlation of AMH in endometriotic patient? What I feel that the AMH is very high and AFCs are very low in those cases because so much of endometrioma has engulfed that.
Very important question. Thank you for that. You know, currently, actually yesterday before we left the airport, we had a meeting because we are submitting the ESHRA abstracts. One of the issues we are currently looking at is the amount of AMH per antral follicle present, and link that to the quality of the oocyte and to the euploidy rate of that oocyte. In fact, you see, you have sometimes a patient, not only endometriotic, any given patient, they might have an antral follicle count of 8 or 9, but they have an AMH of 1.5, 1.6. You can have the same number of antral follicles, but an AMH of maybe 2.8 or 3. So the question is this AMH per follicle a reflection of the quality of that oocyte? And you see the same cells which are producing AMH do also produce inhibin B. So one of the studies we're currently working on to measure inhibin B, AMH, estradiol, FSH on day 2 or 3 of the cycle, follow up the cycle, and then see what is the quality per follicle, per inhibin B, and per AMH. And most probably, something meaningful is going to come out. You see, this is exactly what we call individualization, because it's not only AMH, it's AMH per follicle. Last but not least, do you know when we measure AMH, we say this is coming from the very small preantral follicles and so on. But if I would ask you, all of your colleagues here, what percentage of systemic AMH that we measure, let's say on day 2 or 3 of the cycle, is coming from the antral follicles that we can see, and what percentage is coming from the follicles we cannot see? What would you say? What percentage is from what we see, antral follicles? What percentage from what we do not see?
I don't think it is very well correlated. This is my experience, because I look more for the AFCs than the AMH, what I feel myself.
Yeah, but the question is, and maybe Dr. Laura Melado can elaborate on that, what percentage of AMH is coming from the follicles we see, and what percentage from follicles we don't see, Dr. Laura?
The biggest amount of the AMH is produced by the follicles from 2 millimeters to 10 millimeters. But average of higher production is between 5, 6, 7 millimeters to 8 millimeters. These are the follicles that they produce higher percentage of AMH. So sometimes follicles of this size are not very well seen as well during the scan. It's difficult in a patient with endometriosis as well to be that accurate with the scan. So I think that the combination of both markers can give us maybe a better idea of what we are going to see at the end of the stimulation.
Yes, thank you for that.
So
just to
my
answer,
question is
60 to 70% of AMH that we measure is coming from the follicles we see and not from the follicles we don't see. I think that's very important.
So those antral follicles that we don't see, is that recruitable follicles after we stimulate with FSH?
Those follicles, they are gonadotropin independent. So that will happen in the next few cycles, but those are independent. So basically, the follicles that you can visualize are gonadotropin dependent.
I just wanted to add, if I may, that the follicles with the bigger machines, the ones which have very high sensitivity, you can see even the follicles which are about 2 millimeters. But what you actually can see is 4 and beyond is what you can actually identify on ultrasound. But even those 2 millimeter follicles, which sometimes you can see or sometimes you can't see depending on your probe sensitivity, are secreting AMH. When we do intraovarian PRP, it is actually those follicles which get recruited, and nothing actually new is coming up, even though the theory suggests that maybe you're activating stem cells. But I don't think you're activating stem cells. You're actually activating those dormant follicles which you were not able to see on the ultrasound.
Absolutely, you're right about that, Dr. Nalini.
Good morning, everyone. Just wanted to have a note, like if we have cases of isthmocele with cavity fluid, is surgical correction the only way we can tackle it? Or else can we modulate the, like if we are doing a frozen embryo transfer cycle, then can we modulate the treatment protocol to reduce the amount of fluid in the cavity? And the other question that I had was, is aspiration always that fruitful?
You see, I have to translate English from India to English from Germany, and that has to be done by an Iranian guy. So it's a very important question you asked. You know, isthmocele is Basically, the reason of ismosel, as Dr. Barbara published and elaborated, it's linked to various factors. One is the number of cesarean, the location of incision, and also how you close it. If you lock, for example, your stitches, you have a higher risk. If you close in one layer, you have higher risk. Now, the liquid presence is based on how significant is the ismosel. A mistake that we usually do, you see, when you stimulate, because you have high levels of steroids, all these glands produce a high amount of liquid. So you see the uterine cavity is like a swimming pool, and the uterus is very sensitive. So in fact, what will happen, at the end, the receptivity of the uterus goes down. Now, what many colleagues do, they say, look, if I have liquid, I'm going to aspirate it, I'm going to put it back. There is a meta-analysis looking into patients who have had cesarean. Basically, if you do that, the pregnancy rates are less because the harm is there. You see? I always use the example for the patients. Imagine you have a room, the room is clean. You start injecting dirt into that room, and then you aspirate the liquid of the dirt, but the dirt will still be there. So it leaves an impact behind. And if you aspirate it, you don't see it, but it has been there and it had an impact on the implantation. Another thing which is maybe utmost important to know is that in the luteal phase, this liquid disappears by itself. And a lot of people, they do a scan in the follicular phase, there is liquid, they go to the luteal phase, the liquid is gone, they say TK, we go for the transfer. But that's not there, because that is gone due to secretory transformation. So due to proliferation, the liquid is coming, due to secretory transformation, it's going. So that doesn't mean it's not there, it didn't harm. So I think aspirating it, it's like you have a car, you make an accident, you cover it, so you don't see the accident. But the problem is still there. So you need to tackle that problem from its base. It means you need to fix the ismosel. And you're going to ask me, how do you fix it? That's going to be your next question. So in order to fix an ismosel, there are various ways to fix it. Yeah. There are different approaches. One approach, which is the easiest but not always the best, is a hysteroscopic approach. Okay. So what is being done, and this is Professor Arnaud Vattier who is promoting this technique, is hysteroscopically to just cut the surface in order to reduce the liquid production. The only problem is you have to be cautious for the thickness of your myometrium. If your myometrium is less than 2 to 3 millimeters, there is a risk of rupture. Furthermore, these patients still continue producing the liquid. So to solve the problem hysteroscopically is limited, but possible. The next, and a beautiful approach, was published by Massimo Candiani from Milan. It's a vaginal correction, like you do a vaginal hysterectomy, but there you should not have a lot of adhesions, right? If you don't have a lot of adhesions and the incision is low in the lower uterine segment, you can have a vaginal approach. And by the way, this video you can watch on Fertility Facility for free. It's a beautiful operation, 5 minutes. You just go vaginal, like you go for a vaginal hysterectomy. You open the anterior parts of the cervix, you go in, you do a little bit of adhesolysis, you open the ismosel vaginally, you resect the bad tissue, you stitch it, close it, done. It's a very beautiful operation and easy to do. Last option is a laparoscopic correction. So you do adhesolysis, you open the scar tissue. Important, you have to remove the scar tissue. You know, just open, close doesn't solve the problem. You have to remove the bad tissue, and you have to close it in 2 different layers and no locked stitches. And normally after 3 to 6 months, basically if it's done correctly, after 6 months you can go for another pregnancy. But you see, just aspirating the liquid, it's just covering the car with a tissue not to see the accident.
Thank you, sir.
Yeah. Can I just add to that?
I think, I think we'll have to move onward because we are running behind. So I would ask you to postpone those questions to the coffee break. I think all of us, we will be happy to answer the questions. But I think this interesting discussion has shown that there's a need of individualization, that we can individualize. We'll just have to know how to do it and have to take the patient's characteristics into account. Thank you very much.
Thank you very much.
Thank you so much, Dr. Thank you so much, Dr. Barbara, and all the panelists for this wonderful discussion. Moving on to the next session, may I please invite the chairpersons, Dr. Nalini Mahajan, Scientific Director at Ferticity Fertility Clinics, with over 20 years of clinical and academic experience in the field of infertility and assisted reproduction. Dr. Nalini Mahajan is a pioneer in infertility management and advanced ART techniques. She has been the former president of the Indian Fertility Society and is on the executive board of the Indian Society of Assisted Reproduction. She is the first to perform ovarian tissue activation in India, pioneering ovarian tissue vitrification. Please welcome her. And our next chairperson, Dr. Richa Jagtap, Co-Medical Director, ART Fertility Clinics, India. Dr. Richa Jagtap is an established and renowned infertility specialist. She is trained and certified in reproductive medicine and endocrinology and has the vision to introduce international standards, transparency, and holistic management to reproductive medicine practice in India. May I please request Dr. Nalini Mahajan to introduce our next speaker, Dr. Laura Milado.
It's a great pleasure and honor to be here, and I want to congratulate Dr. Fatemi for such an excellent meeting. And I would go on to introduce Dr. Laura Milado Vidalis to present the next lecture. She's a specialist in reproductive medicine, certified by ESHRE and embryology and the European Board and College of Obstetrics and Gynecology. She completed her PhD in 2015 from the University of Madrid, and her main research is focused on reduced ovarian reserve and ovarian reserve markers. She has authored and co-authored more than 35 internationally peer-reviewed article and book chapters. Now, this is an extremely relevant and important topic, because what we are seeing is that in today, it's not only the older women who are coming with the reduced reserve, we are seeing more and more young women coming to us with a very reduced ovarian reserve, and they are desperate, and we are desperate to give them a baby. So Laura, welcome, and let's hear from you.
Thank you, Doctor. Good morning. Thank you, all of you, for being here today with us. As you can see, my topic is about how to deal with very poor responders. And this is a very recurrent topic that we have in different conferences. And sometimes we see that the presentations include a lot of new research techniques, difficult to apply on a daily basis for us, and that only can be included as well under a research environment. And I would like to give a different aspect to this topic. I would like to discuss with you today what can we do in our center on a daily basis. And this is why I bring this picture here. I don't know if you had the possibility to see this very famous video in YouTube. This is Admiral William McRaven. He is here presenting, doing the commencement speech to young men and women about to finish the university and facing the real world. So he gives them some tips for the next phase in their life. And the first tip is this one. Make your bed every morning to perfection. It will give you a small sense of pride and will encourage you to complete another task and another task and another. And by the end of the day, you will have completed several tasks. Making your bed every morning will give you the idea, will reinforce the fact that small things in life matter. And if by any chance you have a miserable day and you come back home to your bed that is made, that you made, and that will reinforce the fact that tomorrow will be better. So if you want to change the world, start making your bed. And this is exactly what I want to talk to you today. check the small things in life, in your clinic, in your daily approach to these poor responders patients, because small things matter and matter a lot. You can change the possibilities of those patients. And we really know that these patients have very low chances. We know that age is the most important factor. Everybody knows. The patients know. The patients can see everywhere that age is something that will not help them at all. It's in all the media. And age and ovarian reserve is the most important factors to have a possibility to have a baby. But the age, we cannot change it. We cannot go back in time. We need to check in detail other things. And ovarian reserve, of course, is the next factor. And I bring here this paper, this controversial paper, published by Dr. Antonio Lamarca, and that was discussed in this last ESRE in Milan in July 2022. He presented different factors that will impact on your chances to have an euploid embryo. And as you can see here in the graph, here, first one is AMH, which is a representative of an ovarian reserve marker. And the second one is age. However, we just said that age is the most important factor. So this is why this is a little bit contradictory. But the thing is that AMH, as an ovarian reserve marker, represents the chances that I have at least one egg, and one embryo, and one euploid embryo. The problem is that, of course, I'm not going to have any chance to have an euploid embryo if I don't have an egg. So the first thing I have to do is to get this egg, because if not, for sure, there's nothing else that I can do. So, and why is very important to predict if I can have this egg? Because each egg matters at any given age. This is a very important paper presented by the group of Dr. Venetis, and they show that at any given age, the more the eggs I get, the better the chances to have a live birth. This is a very young group of patients below 30 years old, 30 to 34, above 35 to 39, and above 40. Each group, the more the eggs I get, the better the chances to have a live birth. So every single egg matters. And why? Because if I get more eggs, I get more euploid embryos, and I will have higher chances to have a baby born, higher cumulative live birth rates. The thing is that all of us, we come from different places. These papers are from Western countries, the States, Europe, but we work in the Middle East, here in India. It's very well known that our patients are not the same around the world. And I'm going to bring here some information that we got from our patients in the Middle East. This is a very important question that we have to make ourselves when we see a patient. We got a new consultation, we have a patient that comes and she tells to us, my period is a little bit irregular for the last 2 years. Sometimes it comes every 24, 25 days. Sometimes I miss my period for a couple of months. What's going on? And because from the university, when we were to college, we were studying irregular periods might be related with anovulatory cycle and PCO. Polycystic ovarian syndrome, since that is the most frequent reason for that, but actually, we don't think on the other main reason, that is premature ovarian failure. This patient might have a premature ovarian failure, and we have to be very sharp to diagnose. Look, in the Middle East, from our patients that we see every single day, we publish a paper including more than 2,500 new consultations. We measured the antral follicle count and the AMH the same day that they came to our center. And we saw this from the total group, all of the patients, 40% of them, they have a poor ovarian reserve. And less than 10%, they have polycystic ovarian syndrome. So in the Middle East, we have 4 times more prevalence of poor responders than polycystic ovarian syndrome. So the first thing that we have to think when a patient tells me, I have a shorter cycle and sometimes I miss my period, is maybe is a poor responder, and this is a premature ovarian insufficiency. And these are publications that we did in our centers in the Middle East. And what is the most important thing that we saw? That we have a big drop in the ovarian reserve, mainly in patients from 36 to 40 years old. It's true that the ovarian reserve markers, both AMH and antral follicle count, they drop significantly through all the fertile life of the patient. But there is a significant drop from 36 to 40. So it's very important to focus on this group of patients. Actually, my friend Carlos Iglesias, which is a doctor from IBI Madrid, he published a few years ago as well a group of patients from India compared from ovarian reserve the patients from Spain and from Europe. And they saw as well that there was an important difference on the ovarian reserve markers between Indian patients and European patients. So it's not only in the Middle East, you have to be aware, you have to make an evaluation of the patients based on the culture as well. So actually, in the Middle East, we have seen that we have as well other factors that are very important to drop this ovarian reserve. Not only in the group of patients of 36 to 40, also in the group of patients that are younger. If the patients have parents that are related, that means that the parents are cousins, these women have higher chances to have a drop on the ovarian reserve when they are very young. So even earlier than 35 years old is this group of patients that we see here, very young patients. If the parents are consanguine, they have a high risk of having premature ovarian insufficiency. So it's very important to identify which are the risk factors in your population that can give you a poor ovarian reserve. So first thing is to be aware and make a diagnosis. So now the patient, she knows that she is a case of poor response. And we told them so, but the patient goes home and she wants to know, now what? What is my prognosis? This is what our patients really want to know. And they Google it. And I promise, this is a Google search I made in Abu Dhabi, where I live and where I work. And we cannot do egg donation in UAE. But the first answer I got from Google is this one, donor eggs. So my patient will think, I have nothing to do. I will never do an egg donation. This is the only possibility. Now I have nothing else I can do. It's true that in other countries we can go for egg donation, but is it true that we cannot fight for these patients to give them some chances to have offspring of their own eggs? Let's see what we can do for them. As Dr. Barbara Lawrence and Dr. Fatemi presented before, to have an evaluation of AMH is very important to be accurate. Sometimes we have our doubts about if AMH is an accurate ovarian reserve markers. We have different assays, different places where we can do the analysis. Sometimes it doesn't match with what we see in the scan. And we have seen that because of the antibodies that we have in the AMH, they bind some different areas of the molecule of the AMH, we can have some different results. So focusing on poor responders, how can I apply which is the best assay to evaluate which patient with poor ovarian reserve will give me a very bad outcome. We define the bad outcome with 3 or less eggs. So what I want to identify is which patient out of my poor responders is the one that is going to have the worst outcome. And there are different assays that we can use. So this is a publication that we have presented, just submitted for ESRE. We evaluate serum samples with different AMH assays. And they are very specific AMH assays that give us a better area under the curve, that they are more accurate to identify those patients. So we can keep on improving on our assays. However, we have as well antral follicle count, which is easy. The patient comes to us, we do an antral follicle count, and we can evaluate how many small follicles we can see to stimulate them. There is something very important that we can do for them, and this is the first thing that we can do. This patient is going to start a treatment, and my question to you is this month, this period, the best month I can stimulate her? Because a poor responder sometimes have this, and sometimes have this. And we have intercycle variation that we can see with AMH, as we published 2 years ago, 28% intercycle variation of AMH that is reflected as well in antral follicle count. It has been published by different groups. So this is an example of what this means. I see different antral follicles from one cycle to the other. This group published a group of patients that they did exactly the same stimulation, exactly the same doses of gonadotropins during 3 cycles on a row. And they compare the results. Look, only 75%, and I say only because I'm surprised, is me that I do the same cycle, same medication, 3 months in a row. Only 75% of the cases, they have the same, similar number of eggs in a same category. That means that 12% move to another category, or to poor responder or to high responder, and another 12% move to another category. So we have a high variability from one cycle to the other. And it's true, it's very difficult to predict which cycle will give me the more eggs that I can collect. But let's come back to Admiral McRaven. Maybe if this month I don't have a lot of eggs, maybe next month might be better. So we cannot lose the hope. We have to tell the patients that they can try again. And this is something that is really discussed in all the meetings, and seems that is like the most important thing that we can do for our patients, but I really don't agree. These are the add-ons. If we can give to the patient something to become not a poor responder, a better responder. And these medications have not demonstrated, any effectivity. This is the ESRE guidelines in 2020, and the recommendations is that the use of add-ons is not recommended because we don't have evidence. Metformin, growth hormone, aspirin, indomethacin, sildenafil. I will not say these 2 ones, testosterone and DHEA, because, every day we improve our research. We keep on working, we keep on looking to things. And January 2023, few days ago, it was published a meta-analysis including 8 randomized controlled trials with testosterone gel. Randomized controlled trials, top quality evidence, and seems that patients that have been using testosterone gel as priming will have a benefit. So slowly, we are looking for things that can benefit our patients, but in general, several add-ons have not demonstrated things. For testosterone gel, seems that we can improve the number of eggs, and what does this mean? Higher live birth rate and better outcome. What about PRP? So PRP in this guideline in 2020, I'm going to move to the other side now, they recognized PRP is an experimental procedure, but seems that the data is promising, so we need further research. And this is the further research. November 2022, the group of Dr. Norbert Glaser from New York, they published a group of patients with low ovarian response, not premature ovarian failure, not in menopause, poor ovarian response. That means that they have AMH below 1.1, FSH above 12, and the previous cycle we did a stimulation and we got 3 or less eggs. So a patient that we see on a daily basis. So for those patients, PRP is not improving the results. So of course, we have some tools that we want to implement in our daily basis, but they are not demonstrating any benefit. What can we do? We can try to get more eggs, and another stimulation will give me more eggs. So for those patients, I can try duostim. Duostim is a stimulation that if the patient has the period, I stimulated her, I do an egg collection, and immediately after the egg collection, I give again gonadotropins and I do another egg retrieval. Same cycle, 2 egg retrievals, more eggs, better chances. So this is an option that we can do. As well, to stimulate any time of the cycle. So luteal phase stimulation also can give me a benefit. What is the problem of luteal or stimulations during the luteal phase? It's true that the quality of the eggs is similar. It's true that the euploidy rate of those eggs is the same, but we need to have more days of stimulation and then more gonadotropins. So this is something that you can say, then the patient is not very comfortable, what can I do? What we can do is to start the stimulation earlier. This is a publication November 2022. The earlier, the better. So if I start the stimulation in a very earlier luteal phase, as soon as the patient becomes the luteal phase, I don't need so many days of stimulation, and I don't need that much gonadotropins. So if I wait to mid-late luteal phase, I increase the chances to have these longer stimulations. So yes, we can do luteal phase stimulation or duostim, but we can make it easier for our patients if we do it the sooner the better. So we are trying to get more eggs, and we are trying to make it more comfortable for the patient. The next step is those patients that we give medication and there's no response. So we start with the medication, 2, 3, 4, 5, 6 days. We do a scan, nothing happened. Thin lining, no follicle seen. The estradiol, we do blood tests, estradiol is very low, FSH is very high, nothing is growing. And then we cancel. We tell them, there's nothing we can do. I gave you hormones, nothing happens. Just we have to wait a little bit more. Not with medication, we can stop the medication. This is a beautiful publication in 2021, and it says that when we have for 5 to 6 days medication, and we stop the medication, give the patient the chance to come back after 4, 5, 6 days and do a scan. Because sometimes we see one follicle that is growing, and this rebound of follicle growth, we can get the egg. So don't lose the hope, wait a few days, no need for medication, just on a modified natural cycle, we can get the egg. And this is something that we do in our daily basis. What's next? What can I give for trigger? I have 1, 2 follicles, and now I want to trigger her with the best options. So for those patients, dual trigger seems to be the best option, or at least ACG. Agonist trigger for those patients that they are not in risk of having a hyperstimulation is not the best option. We should combine both triggers, agonist with ACG. And let's come back to what our colleagues were discussing in this round table before. This is a publication from the group of Norval Glacier as well that they presented in our book that Dr. Fatemi and Dr. Lawrence edited a couple of years ago. They explain very clearly that the follicles in very extremely poor responders and patients that they have above 40 years old, 42, 43, they have a speed up maturation and they have a very high risk of premature ovulation. So sometimes these patients, we see one follicle growing, we give them the trigger shot, and the moment that we are going to do the egg collection, the egg is gone, and we don't have anything. So we need to avoid this premature ovulation. And it's not only giving to them antagonists or making shorter the hours of the egg collection, it's triggering them earlier. Look, he says that the standard egg retrieval 19 to 22 millimeters. But if I have a poor ovarian reserve patient, 16, 18. But if it's severe, 14 to 16. But what happens if the patient is above 40 years old? The older the patient, the smaller the follicle size for the trigger shot. And it's difficult to believe, really. 44 years old to trigger with a follicle of 14 is difficult to believe. But I'm giving you some examples that we see on our daily clinical practice. Patient, 42 years old, AMH 0.2, BMI almost 28. This patient, we start the stimulation, high doses, is a very extremely poor responder. We saw 3 antral follicles. And the follicles were growing. We were tracking, as we were mentioning before, the estradiol and the gonadotropins. And we trigger with 13, 12, 9 millimeters. We got 3 eggs and 3 mature eggs. Next example, 41 years old, 0.5, BMI 21. A patient with a very poor response. We trigger with 14, 12, 12, and 9, and we got 4 mature eggs. It's real. These patients, they don't have a premature ovulation, and we get mature eggs because the maturity of the follicle is speeded up. So now I have the patient in the theater. I'm going to collect the follicle. I'm going to puncture the follicle to collect the egg. What can I do? I have to pay attention to the technicalities. Sometimes as doctors, we don't check very well, like if the pump, the pressure, what can I do with that? Try to do it smoothly with lower pressure. These boosters that we have in our pumps are not beneficial for the eggs. Look, this is a very irregular oocyte with some cytoplasm leakage here. And this one, again, can you see, is a little bit broken and there is leakage of the cytoplasm. These eggs will degenerate if we do an ICSI injection. This is not what we want. We have to pay attention to the pressure of the pump. And also, should we flash or not? To flash or not to flash? So that's difficult because if you go to the literature, there is very controversial papers. There are papers that say yes, papers that say no. But we are talking about extremely poor responders patients. And I think that this patient of the group of Dr. von Wolf is what we want to see. This is a group of patients with monofollicular development, 1 follicle. Extremely poor responders, only 1 follicle. And I cannot miss this egg. So they did different flushing of the follicle. First flushing, first aspiration, 21% of chances to get the egg. This is the normal aspiration. First flushing, another 23% chances to get that egg. Second flushing, the 3rd time, 9% extra, and so on until flush number 5. Maybe we don't need to wait until flush number 5, but we can do 2 or 3 flushing, give the liquid to the embryologist, and wait until they give us the feedback for the egg. So monofollicular growth, flushing is effective. The next step, now we have the egg, we fertilize, we got an embryo. The embryo develops very slowly. It's not a good quality embryo. The cell division pattern is very slow. Should we wait for day 7? It's an effort for the lab because usually not all the labs, they go to day 7, blastocyst. They say that the embryo is not growing and they discard the embryo. Let's wait for day 7. Look, better late than never. And it's true that these embryos, blastocysts on day 7, they have lower euploid rate. We have to tell the patient, we have to give them a proper information, but still they have euploid embryos on day 7. And if we transfer, this is our data submitted and it's under review, that of course we have less live birth rate, but still we have live births with a day 7 embryo euploid blastocyst. And this booklet that we have here, I was checking. Yesterday in Dubai, in our conference, the booklet was having some pictures of our patients and patients that give the feedback. One of those babies in those pictures was one of our day 7 embryos. And it's amazing because our patients that they don't have any chance, it looks like they have only one follicle. It's so tough from the very beginning, and only one day 7 embryo, and the baby was there in our pictures. Then, another option. We get the egg, but it's not mature. We have done our best. Not premature ovulation, we collect the egg, we gave the best trigger, but it's not mature. We got a GB or we got an M1. We can wait in the lab for the next day. This is a paper published by Dr. Ibrahim El-Khatib in Human Reproduction. It's going to be out in a few days. Look, I wait for the egg in the lab, and the next day I do the ICSI. The fertilization rate is low. The blastulation is also low. But if I get a blastocyst with this egg, the euploid rate is similar. We didn't find differences. So it's true that will not fertilize as good as the other mature eggs, but still I have chances. And we have embryos and good quality embryos from that. From the very beginning, I have been mentioning that one of the most important things is to have more eggs. So sometimes what we do is to stimulate the patient several times, and we accumulate the eggs or the embryos. That's the question. So we published in 2020 a study showing that if the patient is extremely poor responder, if I freeze eggs, if I accumulate the eggs with vitrification, vitrification is a process that will not be amicable for weak eggs. Patients that have very low ovarian reserve, those eggs didn't like the vitrification. And I have higher chances that the most of those eggs will not survive to the vitrification. All of us, we have read papers from the group of Anna Cobo that they show that the survival post-vitrification is above 95%, but is in a general group of patients. For poor responder patients, if the patient has an AMH below 1.1, the ROC curve shows that I have a high risk that 70%, to have a survival rate below 70%. And if I do several stimulations, I collect 5 eggs for a patient, and I lose 2, that's not a good result. So it's better for those patients, try to freeze the embryos. Okay, so the camera is saying that my time's up, so I'm going to finalize. What's next? What's the future? So there are some small things that I want to bring here because it's in line with what we have been discussing. It's about AMH and LH. So Dr. Hyatt, in 2016, published a review about new research with AMH. AMH, we can synthesize AMH in the lab. We can do recombinant AMH. So he presented several publications that you can give AMH as priming to the patient. And that makes the follicles, the antral follicle count, to be higher. So we create a pseudo-PCO-like condition. And this is mediated by LH. So the receptors in the hypothalamus have the hypothalamus have receptors to the AMH. And AMH was generating a pulsatility of the GnRH, increasing LH levels. And this LH was creating a pseudo-PCO-like environment, and they saw more antral follicles. Also, in our papers, we saw that there is a very important link between the AMH and the LH at the moment of the ovulation. So what happened that when I do a priming with AMH or when I do a priming with LH, I increase the number of primordial follicles moving to small antral follicles. This is a very recent paper, October 2022, from Dr. Antonio Lamarca. He gave a long period of priming with LH to patients, extremely poor responders, and he saw higher number of antral follicles than we can stimulate in a better cycle. And this is something as well related, how to use the AMH, the recombinant AMH. And that's my conclusion. We can do it better with a small step in the labs, with things that we have every day in our hands. We don't need very fancy techniques that we cannot implement in our daily clinical basis. We can do small efforts every day. And this is something that is seen here. If I do exactly the same during the 365 days that 1 year has, I get the same results. I'm not improving. But if I do a tiny, small, consistent effort, this is the big difference. And this is what I wanted to bring here today. Thank you.
Thank you, Dr. Laura, for your excellent presentation. I missed some part of it, but I'll discuss with you later. And we'll have the question-answer sessions at the end of the 3 presentations, if that is okay with everyone. Thank you. We would like to call Professor Kazim Nouri now. Professor has studied medicine at the Medical School of Vienna. He has published more than 100 scientific papers, and he has been a president of Austrian Society of Sterility, Fertility, and Endocrinology. He is also the scientific secretary and scientific board member of the Austrian IVF Society. Since April 2019, he is the medical director of TFP Austria, which has currently 3 IVF centers in Vienna, Wales, and Frankfurt. Professor, to you. Thank you.
Madam Chairwoman, many, many thanks for your very kind introduction. Dear colleagues, it is an honor, it's a great pleasure for me to be here. This is my first time in India. I'm really excited. But I see right now a difference between the congresses in Europe, as we have it in Austria and other parts of Europe, and in India. And that is, as a matter of fact, you are listening, you are asking questions. The same Congress in Vienna, I would say 80% of the attendees would look at the iPhones or writing some emails with computers. So it's an honor for me to be here, and that's the reason I want to thank the organization committee, in special Professor Fatemi, for inviting me here. For this lecture, I have no potential conflict of interest to report. Another difference, we came here last night at 2 o'clock or 4 o'clock in the morning. So I don't know what's the situation in New Delhi regarding parking spots, but it's a problem in Vienna. So if you have a car, you have a big car you want to park, you see something like that, you don't have any spot, so you're sad, you have to drive away. Of course, if this is the situation, you have enough place, you can park your car, and you're very happy. So what has it to do with implantation of embryos? First of all, we have the natural conception. That means the sperms that fertilize the egg in vivo, the embryo which goes back the whole way and implant in the embryo, or the way we do it, namely after IVF ICSI therapy, we have the fertilized embryo on day 5, we give it back to the uterus. We should keep in mind that there's a difference between two kinds of embryos. The one embryo hasn't seen the light of the world at all. It is in vivo for 5 days, 6 days. The other one is in vitro, it's outside. After 22 years reproductive medicine, I still think, how can it happen? But these embryos implant and they get pregnant. It doesn't matter in vivo or in vitro, this is the same situation. Embryo needs a place to park. Embryo needs to park, needs to implant in the uterus. And what's not the parking place, this is the crosstalk between the endometrium and the embryo, about which we don't know anything, believe me. So we think we know much, but as a matter of fact, still the implantation is the black hole in the reproductive medicine. Many factors have been seen, but many we don't know. We know there's an implantation window, as we heard from Professor Fatemi today, 30 to 36 hours. In a natural cycle, it is between LH day 6 and 8, and when we use progesterone, mostly P+5. So, the other thing, if you look at the papers in the last 4 decades, the first thing, in the first 10 and 20 years, we talk about biochemical pregnancy. So the most important thing was if the patient got pregnant. And then it was ongoing pregnancy, clinical pregnancy, in which we had a positive heartbeat. Now, after the papers 2015, 16, we are talking about the pregnancy, and of course, the most important thing, we are talking about the live birth. That means whatever we are going to talk is not only about the implantation and positive heartbeat anymore, it's also about the pregnancy, and it's also about the babies. So, and my task today for the next 20 minutes is to talk about the teen endometrium and the fact, what should we do in the clinical routine if we have a teen endometrium? Should we transfer or we shouldn't transfer? Before that, in order to see if we are on the same page, look at these 6 pictures. In which one you would love to transfer the embryo? From my side or from your side? Okay, that's correct. We agree on this. During the next 90 minutes, I'm going to answer 6 questions. First of all, how to measure EMT, endometrium thickness, what teen endometrium and ART outcome, is there any absolute threshold in which we should consider to cancel the embryo transfer with EMT? How does etiology of poor response, we have heard a lot about poor responder today, how does it affect the EMT? And of course, as I mentioned before, not only ongoing pregnancy, if we have a teen endometrium, what does it mean for the pregnancy and for the newborn? And last but not least, okay, we have a diagnosis. What is it from a benefit if we have a diagnosis and we don't have any treatment for that? To measure EMT, it's very easy. I tell it always my residents and my fellows. You should try to have a 90-degree angle between the probe It doesn't matter it's transabdominal or transvaginal with the endometrium. And there are, of course, some tricks. For example, endometrium should be measured when it appears as the thickest. So you have in your routine daily practice somewhere in endometrium which is thin, somewhere is thick, take the thickest part. And if you have fluid, we have heard about it too, you should measure the both sides above and under the fluid and add them together. And please keep in mind, this is very important. We are not only talking about the measurement of endometrium, I think what is coming in the future and is going to be very important is the quality of endometrium. And the quality of the endometrium and architecture of the endometrium, how can we see it? As we mentioned before, the three-line pattern is always good. And if we have the possibility, hyperestrogenic, hypo, and isogenic, this one is, of course, naturally the better one. Second question, teen endometrium and ART. Let's start with IUI. There's a lots of publication. I choose this one for you. This is from year 2017. And what they did, retrospectively, of course, they went for the studies and they found 1,563 studies in this regard. But they took only 23 of them, 17 RCTs and 6 cohort studies, which included 3,846 patients, all with unexplained subfertility. So actually we know that what they find out with clomiphene is the endometrium very thin, better with letrozole, better with gonadotropins. But interestingly, the combination of clomiphene and gonadotropins was the thinnest. Did it matter? Not at all. So the meta-analysis, IUIs, endometrium thickness, implantation, no difference. The next study is also same population of the patient and comparison between patients with clomiphene stimulation and gonadotropins, and basically they find the same thing. The non-linear association between EMT and the estimated ongoing pregnancy rate. What does it mean? That means if you are doing IUI, it doesn't matter for the ongoing pregnancy how thick endometrium is. And I told you we are not going to talk only about the implantation and ongoing pregnancy, but we are talking also about the whole pregnancy. And it was exactly the same thing. That means teen endometrium didn't matter at all for the health of newborn. So this was the second question, IUI and endometrium thickness. Let's go to teen endometrium and IVF ICSI therapy. A whole different world according to the existing data till today. First of all, how often does it happen? Well, 0.5 to 2.5% of the cycles, we see thin endometrium. And the problem is, in many studies, you don't know when they measure it, on the day of triggering, on the day of embryo transfer. So this is a problem that we see in many studies. I chose this study for you, though again a retrospective study, but what was interesting for me personally is the number of 96,000 transfer. This study was published 2022, just 1 year ago in Fertility Sterility, and it is from the registry, Canadian Registry of IVF and ICSI therapy. So, the interesting thing about this study was, when comparing the fresh embryo transfer and live birth rate, they saw that the live birth rate increased significantly as the endometrium thickened until the thickness reached 10 to 12 millimeter. I don't know about you, but I can remember that in the old studies, it was always like it goes up, the thicker the endometrium is, and as a point, like after 14 millimeter, it comes down again. So it's not the case. They didn't see a drop in live birth rate, rather a plateau with 10 and 12 millimeter. Another comparison they did was the number of retrieved eggs and embryos in endometrium thickness, and they saw EMT, increasing EMT, was associated with significantly higher number of oocyte, peak estradiol levels, and mean number of embryos. That means it gets better. So how about it was the fresh embryo transfer, but how about the frozen embryo transfer? The same thing, but you see a difference here. It was between 8 and 10, and here you could transfer with an endometrium thickness of 7 millimeter, and you would have the same results. So the live birth rates reached a plateau, and which is very important to know. So IUI, it doesn't play a role. IVF ICSI therapy, it plays a role. Why? Who knows the answer? Actually, nobody does. But there are three hypotheses. The first of all, high oxygen tension. That means if you have a thin endometrium, it means you have a lot of vascular structure here, which means that the embryo is very close to high concentrations of O2. And now remind in mind what I told you at the beginning of my lecture. We should differentiate between the embryos produced in vitro and embryos produced in vivo. Obviously, for some reasons we don't know, the embryos produced by IUI, by natural conception, it doesn't play a role. They can implant. But embryos produced in vitro, they react to this high oxygen tension. Hypothesis number 2. Are we talking about premature luteinization in this case? That means maybe thin endometrium, sometimes, not always, is an early manifestation of premature luteinization. That means, and the reason that the endometrium is thin is because of the compaction suppression of endometrium growth. Hypothesis number 3, displacements of window of implantation. Actually, I found this Indian publication which showed that when comparing patients with endometrium, with thin endometrium, with their own eggs or with donor eggs, 50% of them, they have a displacement of window of implantation measured by error test. So, is there an absolute threshold about which pregnancy is not possible? According to the existing data, it's 6 millimeters. So, on purpose, I made a failure here. I mean, it's not actually something we shouldn't say or do as clinicians who are in the field of reproductive medicine. Who knows that? Never say never in reproductive medicine. I'm sorry, but I have to tell you this story of my life from which I learned a lot, and I'm going to share it with you. 2006 was the time of the beginning of AMH, and I was among the first persons who went after measuring AMH in Austria, and it was very difficult and very expensive. Somehow we managed it in the university hospital, and I had a young patient with AMH of 0.1. And I was young, and I told this patient, look, with this AMH, it is not possible that you get pregnant. So better, instead of giving money for IVF for your own eggs, let's start and go to a foreign country. At that time, egg donation was not allowed in Austria. Invest your money in which you can get pregnant. This patient cried and went out of my door. 1 year later, somebody knocked at the door. I opened the door, and you know, as doctors, you don't forget some faces. I saw the patients with a baby in the hand, and she told me, Dr. Nouri, you told me I won't get pregnant. This is my baby with my own eggs. So, never say impossible in reproductive medicine. Everything is possible. Husband has azoospermia, it's possible that the woman gets pregnant. Everything is possible. Number 4, how does the etiology of poor response affect EMT? This is a study from POSE 1. I liked it because of this part. That means with an AMT of under 7 millimeter, it doesn't matter if you're poor responder, medium responder, high responder, they had the same ongoing pregnancy rate. But then it diverges the better the AMT gets. Again, go back to the pregnancies. As I said before, the aim of reproductive medicine today is not having a labor pregnancy or ongoing pregnancy. We should have women with a healthy pregnancy and healthy child. So, I think everybody knows this publication from 2012. It has nothing to do with endometrium thickness. This is just a fact. And the fact which says that IVF-ICSI pregnancies are associated with higher risk of obstetrics and perinatal complications. Further research is needed to determine why. And we heard a lot today about this why. We heard that it's very important to have a corpus luteum. We heard that we are going back to the nature, and we have to perform more natural cycles. But what it means, again, a thin endometrium for pregnancy, according to this study, you have much significantly higher rate of hypertension. According to this study, you have problems with the kids. You have preterm deliveries, very preterm deliveries, and you have also small for gestation babies. Again, the question is actually why? And maybe the reason, maybe the answer is according to this publication, thin endometrium characterized by high blood flow impedance, poor epithelial growth factor, decreased vascular endothelial growth factor. So a lots of factor with thin endometrium are there. So now we are my last question, to answer the last question. We see thin endometrium, what should we do? Extend the course, add new routes, increase the dose, you know, all of them. Sometimes think about new attempt. I was talking to my colleagues, and I was saying, in Austria, in Vienna, I'm searching for a reason to perform freeze-all. It's not easy to say, I want to have 100% freeze-all. But if I have, on the day of triggering, an endometrium under 8, it's for me freeze-all, a reason to freeze-all. The protocol, if it's the frozen one, if you cannot achieve the endometrium with estrogens, think about low-dose stimulation. And again, we are 3 different parts of the world, Dubai, Austria, India. I don't know the possibility of hysteroscopy in India, but in Austria it's actually very easy, and the patient doesn't have to pay for it. So for me, it's always also to consider to perform a hysteroscopy. And there's also, again, an Indian publication that since hysteroscopy can help in this kind of patient. Last but not least, adds on. So if we start with that, PRP, GSCF, sildenafil, it will take the whole day. I have to say, in the era of evidence-based medicine, sometimes if you're desperate, you should use them, but of course, they are not evidence-based medicine. So I come to my conclusion, and conclusion number one is EMT does not play a role in IUI. I think it's clear. We can take it today with us. It doesn't matter. You don't have to cancel IUI if endometrium is 6-5 millimeter. It could affect IVF ICSI cycles negatively. Reduced EMT in fresh and frozen technique has been associated with less ongoing pregnancy rate, increased risk of spontaneous abortion, ectopic pregnancy risk increase, placental previa, and low birth weight. And regarding the therapy, fourth column, think about what we discussed before. So, actually, I was done now with my lecture, but I had to add a conclusion number 2 yesterday in the aeroplane on the way here at 10 o'clock. And the reason of that was because I heard that Professor Atta published a paper the day before yesterday in which the conclusion is just the opposite what I told you. So before he attacks me with my lecture, I defend. So first of all, from the philosophical point of view, is it possible that something 180-degree different, both are correct? I don't know if you remember the film Federer on the Roof. Do you remember the film? I was a child as I saw this film, and it reminded in my memory a very beautiful scene of this film. Two people were discussing, and the actor came to the discussion, and the first person said something, and he said, actually, you're right. The second person said just the opposite. He thought a lot bit, said, actually, you're also right. And the third person came in and said, wait, it's not possible. He is right, it cannot be correct that both of them are right. He thought a little bit, said, you know what, you are right too. So I had to think on the way here. I haven't seen this publication, but since the publications of ART are always high standard, I had to think about something, why it be. And again, I want to give you an analogy for that, for the last 40 seconds of my talk. What you see is a road from Tamale to Tumo in Ghana. I'm a group of doctors that we go every year for 1 week to some parts of Africa in order to help people and perform surgery. I've been doing that for the last 12 years. And the road is always like this. And here you see the vehicles that we have. That means we have to have really very good cars. And it's like 6-7 hours drive. With this car, you cannot drive this way. So many factors came to my mind, but I think one important thing is the quality of embryo. So if you produce super embryos in your lab, and you check them for PGT, and they are euploid, they can implant everywhere. As a matter of fact, the extrauterine gravity, the embryos, they don't implant in the uterus. They are top embryos that it doesn't matter where they are, they can implant. So one of them would be answered, but to be honest with you, I'm looking forward to have the discussion with Professor Fatemi and Professor Atta and learn more about teen endometrium and this new publication. Thank you very much.
Thank you, Professor. And I know there's one talk standing between you and lunch, and we'll probably have to push panel a little bit ahead. We'll get some time for questions after this, but in meanwhile, we'd like to call Professor Luca on stage.
So he's a, he's a specialist in reproductive medicine since the end of the 70s, and we've had the privilege of seeing him in all the ESHRE meetings, a very familiar face. He's the scientific director of SIS-MER, the Italian Society for the Study of Reproductive Medicine, and he holds the position of scientific director at IIARG and IIRM-SA in Lugano, Switzerland. He's also an honorary professor of the School of Biosciences of the University of Kent, and he's the author of 290 papers in international scientific journals and a publisher or co-publisher of 9 books. Thank you very much, and we look forward to your talk.
Thank you, and thank for the kind invitation. So I think that this is a topic of the whole meeting, the personalization of the treatment, with one aim, with at least one aim, is to prevent a dropout. I'm saying this because if you look at this data, and I choose this data deliberately, thinking that they are at least 10 or 12 years old, you see that despite of 10-year-old technique, if you look at the live birth rate from these 3 different authors, you end up that 70%, 75% of the patients' delivery as far as they are treated for 6 cycles. And when I say 6 cycles, I also include 6 embryo transfers. So the point is to avoid our patients to drop out during the treatment. Too many of us are still believing that when we talk with our patients, we just say you get 20, 30, 40% per cycle. It doesn't mean anything, because in fact, what we should think is an agreement with the couples for which they have to be exposed to a certain number of treatments. So which are the causes of dropout? I think that all of us know that could be financial reasons, psychological factors, including the distress, the depression, anxiety, and sometimes also loss of trust with the clinicians. How many times, talking with our patients, you really understand that they don't completely trust you, that after 1 or 2 failures, they would like to have different explanation. Then you have unrealistic expectation, and this is what I was telling to you before. So we are not able to communicate properly to our patients that 1 cycle doesn't mean anything. When they come to you and say, this is my last chance, that's wrong. It's wrong. It's the concept of the treatment. And probably even more important, the repeated IVF failure. So forget for one moment financial and psychological, because that will not be part of my talk. Just concentrate on unrealistic expectation and repeated IVF failure. Unrealistic expectation is the concept that, for instance, in oncology, does not happen. You have a problem, you are exposed, you have been told to have 6 cycles of chemotherapy. And this is what you do. You don't stop your treatment after 1 or 2 cycles just because you have some side effect, vomiting or loss of hair. You keep going because you know that is the only chance to have 80, 90, 70% of chance to get out from the problem, to get rid of your cancer. So here is the same thing. We should start to think about convincing our patients that they need a certain amount of treatment to get what they want. When we talk about repeated IVF failure, I think that one of our major problems is that we keep going to do treatment without making a proper diagnosis, not only on the patient itself, but also on the gametes or on the embryos. Just let me give you an example. If you do a monk embryo transfer and you transfer instead of an embryo, just 10 microliters, a drop of 10 microliters of methylene blue, and then you immediately do an hysteroscopy, you learn a lot. I will show you a small video that will tell you how personalized medicine and precision medicine could play a role. So here, the transfer with 10 microliters of methylene blue is done. You do hysteroscopy. It was an easy transfer, nothing to say. You enter the uterine cavity, and what you see, nothing, no methylene blue at all. So despite the transfer was easy, there was no methylene blue. When you go back with your hysteroscope, what you see is that you have discharged your embryo, potential embryo, in a 2-millimeter polyps, taking into consideration that since in reality the uterine cavity is virtual, that small polyps actually occupy the entire area in which you are doing the transfer. So I'm not advocating hysteroscopy as the first tool. I'm just saying that if we don't look to small details, as it was said before, most of the time you take a risk that you are missing the point. So personalized medicine, we can define as a tailoring investigation and therapies to each patient that is based on evidence. But personalized medicine is different from precision medicine. I would like to define with you the concept that precision medicine is based on a unique genetic and physiologic characteristics. And nowadays, we can emphasize on genomics, proteomics, and other biological omics. So if we look at the current evidence-based medicine, most of the therapies that we consider are evidence-based medicine strong, in fact, they just treat a small amount of our patients. So even if we have done a lot of advancement, still, we should take into consideration the combination of personalized medicine and precision medicine. I would like to go back to this concept. When I'm talking about personalized medicine, it doesn't really specifically mean that you have to be very sophisticated. It's only a matter of choosing the right program or the right protocol. So let's take, for instance, this protocol, and the agreement is to complete in 12 months either 3 embryo transfer, either to have a full-term pregnancy. Very simple induction of ovulation protocol, only clomiphene citrate, FSH, very small amount, 450, 600 international unit, only 1 monitoring, and off you go. The concept is pregnancy to term or 3 embryo transfer. Of course, this protocol has to be assigned to specific patients. Patients that have some categories like, as you can see here, young patient, naive patients, no azoospermia or extremely severe male factor, no severe endometriosis, normal ovarian response. So what we can say, the easy couples. So if you assign to these patients this protocol, but you ask them or you involve them in a project for which they have to have at least 3 embryo transfer done. So first of all, if you look at the data, you see quite clearly that among these 511 eligible consecutive infertile couples, you have a certain amount, 21%, 1 out of 5, that despite of the screenings that you have done earlier, they actually don't meet the criteria, so they are not eligible because they do not respond properly, for instance, to the protocol. And when you focus on the patients that have completed the program, so 369 couples in this case, and you look at the results, it's quite clear that for this couple, you have done the proper job with a very simple protocol, because you see there are young patients, as you can see, and when you go down to the cumulative live birth rate, 3 patients out of 4, or they delivered. And we are talking about, of course, delivery. And when you look at the results, taking into consideration that 132 patients just needed 1 transfer because then they got pregnant and delivered, and 70 just had 2 embryo transfer because then they delivered after the second transfer, and the other patients, they had to do 3 transfer, and of course, not all of them delivered. And you look at the data, what is interesting to see is that if you look at the heartbeat for embryo transferred, you see that despite they look all eligible and all equal, these patients, once that they get pregnant, the chance of having a high implantation rate dramatically decrease with the number of attempts. And in the meantime, the miscarriage rate dramatically increased, bringing to the 3rd embryo transfer with only 22% of these patients that have been left over, they really deliver. And when you look at the potential chance to delivery, you easily see that the implantation rate dropped from 29% to 17%, and the live birth rate dropped from 36% to 22%. Again, showing that the best patients inside the group are those that get early pregnancy. What is interesting is that if you lock the patient in a system because you have an agreement, or because, for instance, if they are in a private center, they pay in advance for the 3 embryo transfer, you can see that the age of the patients, when you look at the 3 embryo transfer, the cumulative live birth rate, in fact, doesn't change. That means that, of course, young patients have less embryo transfer to do. They get pregnant and deliver earlier, after the first or the second. But if you keep going, even the older patients, 35 to 39, actually they have the same chance of delivery rate after the cumulative expectation. So what does this mean? That all in all, for some categories of patients, when we are talking about personalized medicine, we also could think about simple protocol that in fact lead to the success that they are looking for. Not only that, but if you look at those patients in these groups that didn't get pregnant and you do PGTA on the remaining blastocyst after the program has been completed, what you have is a large increase of abnormal chromosome complement being this patient young, as I was mentioning to you before. Not only this, but if you look at the complex abnormalities, you see that the chance of these embryos to have complex abnormalities, so to be definitely non-viable, is very high, again, compared to the fact that they are young patients with no severe malfactor and so on. And of course, if you remove them from the circuit, you can still get pregnancies. So the point I want to make is that you have, from one side, personalized medicine and precision, but taking into consideration that in our field, reproductive medicine is also imply reproductive biology, we should start to think about the concept that we can have medicine that is personalized for our patients, but also that the precision medicine should also involve embryology and biology. Just to give you an example of what I'm trying to say you, if you look, for instance, at the data that each lab can have, each clinic can have, and you construct, according to the maternal age of your patients, the number of ovocytes that you need to have for to produce a euploid embryos, you see that when you pass the age of 40, you need to have only one euploid embryo, at least 16, 17 eggs. And that's also brings to the conclusion that if you want to discuss with your patients aged over 40 to have 50, 60% of chance to have a live birth rate, then you have to explain to her that she needs around 100 eggs. Of course, these numbers can vary according to the quality of your lab. But the thing is different, of course, if they are much younger. So the point is that we need to have in advance an agreement with the couple to involve them not to drop out. When you look at the number of 2PN, 1 to 5, 6 to 10, more than 10, and again you stratify your patient by age, and you look at the percentage of euploid blastocysts that you can have, you see it quite clearly that, for instance, in this group of age, if you have only 1 to 5 2 pronuclei, the chance to have one normal blastocyst is only 1 out of 5. And the things are going even worse, of course, when you go up to the age of 40, 41, or whatever. What does this mean? It means that you need a large amount of ovocytes and 2PN to get a chance to have one blastocyst out of 5 that is euploid. By the way, I want to draw your attention to the fact that while in the yellow and red column, all of us are aware, all of us agree on this, when you look at the young patient, you see that there is not an increase of chance of having euploid blastocysts when you increase the number of 2PN. The reason is quite clear. Among this group are also included those patients that produce a lot of ovocytes, let's say PCO patients, PCO-like patients, but they have a lower quality of each individual ovocyte. We can expect to personalize the treatment also in the lab. I think that in the next 10 years, our lab, as they are now, are completely disappearing. They will be all robotics. I just want to show you quickly the naive concept of robotics. So the beginning of robotics, this is an incubator in which actually what you do, you choose the room for your patients, the room for the embryos. You allocate a specific room. We call it the hotel. A robotic arm is picking up the dish and putting it back, allocating to the rooms that has been decided. So the incubator never opens the door. It just goes through a tiny, small compensation chamber here. And what is even more important is that you can ask to this robotic system also to move your embryos or to tilt the embryos, mimicking according to the need the movement or the contraction of the fallopian tube. And of course, this is all under control, both mechanic and the environment. But what is interesting is that this is just the beginning of a new era. And I believe that you see here the tilting of some of the rooms. This is only to give you an idea that this is only the beginning of what we could expect. So, all in all, if you want to personalize the treatment, we need to go back to make some proper diagnosis. When I say the proper diagnosis, for instance, how many of us do karyotype or chromosomal analysis to our patients? I don't think that many of us does. But we should remember that at least 2, 3, 4, and for severe manufacture, even 5% of our patients, they have chromosomal abnormalities in their karyotype. That means almost zero chance to produce a viable embryo. And mainly they are translocated. So my question to you is why we shouldn't do a simple test at the beginning of the treatment, like karyotyping our patients. Once that we have made the diagnosis, we should agree with the patient for different programs. So we should say, well, if you want 60% of pregnancy, at least, you need to have 3, 4, 5 embryo transfer, whatever, according to the age, according to the pathology. And if we do so, we must have a delivery rate that should exceed 60%. That implies that at less than 40% of our patients don't deliver after the treatments that have been chosen and agreed with them. If they enter in this less than 40% failure, then we have to look either to the gametes, to the embryos, or to the uterus, as it has been said before. And if you look at the gametes and the embryo, we should look at the culture, for instance, culture to blastocyst, or PGTA, or gamete donation. If we identify the problem in the uterus, maybe freeze all, or looking at the endometrial receptivity, or what it has been said from the previous speaker. So anyway, we should identify the reason why the minority of the patients failed to conceive. In doing so, again, the program should have at least a delivery rate of more than 60%. That means that, again, there is a certain group of patients that even after this second group of treatment, they don't get pregnant, they don't deliver. But in fact, if you start with 100 patients, then you are left with 40 patients that are not pregnant. And after the second round, you are left with 14 patients that didn't get pregnant. So what do you do with this? The most important thing that you should do is to avoid to personalize wrongly the treatment. Let me give you the example of this couple, easy couple, apparently 37-year-old, normal zoospermia, probably 2 birth factor, no miscarriage, no previous cycles, so naive patients, hysteroscopy normal, everything was okay. So it's a long story, so that's the reason why I summarized for you the dates. Few ovocyte standard retrieval, biochemical pregnancy, negative, an ectopic with subinjectomy, negative, 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 negative again. We started to investigate at that time if the problem was on the eggs. So we did the PGT for aneuploidy in the polar bodies. She had a nervous breakdown, and she needed psychological support. Then we looked for chromosomal abnormality in the sperm, just in case that was the case, despite of normal zoospermia, normal. And then she started again. You see, negative, negative, negative pregnancy test. Again, decided not to make further cycles, but then she came back asking for oocyte donation. So for many reasons, we suggest to go to our colleagues in Crete, where she also had some relatives. They were transferring 2 blastocysts at the time, negative, negative, negative again. So again, another nervous breakdown, another time for psychological support. And then she started again. Before she asked for receptivity test. It was receptive. Everything was looking normal. Okay, 4th attempt, 2 blastocysts, negative. 5th blastocyst, negative. Third blastocyst, negative. So on October 18, the patient informed us that she decided to enter a program of surrogacy, and she has twins. We personalized the treatment, doing mistake after mistake, and keeping her going in the wrong track. So careful on the fact that personalization doesn't really imply necessarily that you are doing the right thing. Just to give you an example of what an agreement could be is taking just a group of patients with endometriosis. Of course, you have to discriminate between pelvic endometriosis and ovarian endometriosis, because what you need to know if is the patient is a normal responder or a poor responder, and you base your protocol of induction of ovulation based on this topic. Of course, if the ovarian endometriosis is there, then you need to think about the removal of the cyst, or just doing oocyte retrieval, an embryo cryopreservation, maybe then treat the patient with GnRH analogs or other, and then go for a frozen embryo transfer. Or if the patient had previous ovarian surgery, most of the times they are poor responders. So what you do with these patients? Once that you have assessed the ovarian reserve and hysteroscopy is done, proving that everything is normal, then you split your patient according to normal or low ORT. And then you go for a standard protocol or for a spatial protocol. And you also have 2 other instruments that are PGTA and oocyte donation. Again, it's a matter of explaining to the patient in advance, she's pregnant, delivery is fine, she has miscarriage, so she should go probably for PGTA. If she's pregnant and delivery, it's fine. If she has a miscarriage, most probably she should go back to PGTA or immediately shift to oocyte donation. If she is not pregnant, well, if no embryo transfer is done, it means there are no embryos available. Maybe oocyte donation is an option. If she's not pregnant but a transfer is done, she can repeat PGTA. With the standard protocol, if no embryo transfer is done, it has to be rescheduled the whole program. If the transfer is done, we can give her another chance or going straight to PGTA. The problem is different if they have a low ORT. After delivery is fine, but if there is a miscarriage, then these are the 2 programs that she should indicate it to. If there is no pregnancy, again, transfer is done, and then IVF could also be proposed with a simple protocol. If there is no embryo transfer, you can do one of those protocols that have been indicated by the previous speaker, like the priming protocol. Again, delivery is fine. If there is a miscarriage, and again, oocyte donation should be done. So this is only to give an example how each individual patient should enter a program that is established in advance with the aim to avoid or to diminish the dropout. Thank you very much.
Thank you, Professor, for a very enlightening talk and very detailed discussion on a very difficult topic. The floor is open now for a few questions from all the 3 speakers. If you want anything that you want to ask, you can ask now. After that, we'll break for lunch, and the panel discussion will be after the lunch. Can we give her a mic, please? Please let us know your question and who you are asking it to.
That was
Really an incredible session. My question is for the first speaker.
Dr. Laura.
Hi, Dr. Laura. Thank you, that was indeed wonderful. I would like to touch upon one aspect. You gave us a lot of clues, new strategies. What would you do? You have that one egg. Would you do an IVF or would you do an ICSI, irrespective of the male factor? So there's a lot of debate. We talked of many do's and don'ts. I think this is another thing, and I think more so in India, where often the thought is just do an ICSI because you will get a fertilization. And I wanted to know your thoughts on that.
Yeah, that's a very, very interesting question and difficult to answer, yes, because it's something that we discuss together every day. And actually, in these kind of cases, we sit together, we put on the table all the information from the couple. The sperm is not a problem, so we can choose one or the other. And actually, we just mentioned before that we can choose both options, even though we are going for a PGTA analysis, for an embryo biopsy and genetic analysis. So we sit together and we evaluate the egg quality. So the embryologists, they give us a feedback, immediate feedback about what is the aspect of the egg. And we evaluate if the patient has previous spontaneous pregnancy, so spontaneous fertilization. And then we take the risk. I will say maybe 50% of the times we will decide ICSI or IVF, but based on the aspect of the egg quality and if the patient has previous spontaneous pregnancies. This is something very important that we sit together and we evaluate case by case. I mean, this is, again, individualization.
So if I can just ask, you said egg quality. So you've just done the pickup and you've got to decide within the next few hours whether you want to do IVF or an ICSI.
Yes.
So what are those key parameters you're looking at? Because
I think
would that be a granulation? Would that be, did you trigger for a 14 millimeter? Did you take it out at 18? What would be your specific criteria? So let's say this is a woman who's 39 and she's never been pregnant and it's the first cycle that you've done and you've got that one oocyte which looks okay, little bit dark.
I was looking for here. I think that in that case, no previous pregnancies and a good aspect egg, we will go for denudation and ICSI. Is that correct? But it's true that we will ask them, what is your opinion about it?
So it's very important to consider the previous history. And the first thing we need to ask is, what is the infertility factor? Because if this patient, for example, she had recurrent miscarriages after natural conception, it means that there is no problem with fertilization, right? So even if she was, I mean, for 10 years she didn't get pregnant or something, we know that somehow we can do IVF. Now, our policy, especially if we will do PGTA, we try to split, you know, instead of doing all ICSI or all IVF, we split. Now, the percentage, how many of them we will utilize for IVF, this is dependent on history. Now, assuming that the sperm is good, this patient has been trying to conceive for 3, 4, 5 years and she never got pregnant. To be honest, I will either do all ICSI or I will do 80% ICSI, 20% IVF in order to help us understand what was the reason for this infertility. Now, always, although not always we will have patient previous history in our clinic, but it's helpful to ask the patient, right? If she did other trials, which procedure they did. And we've seen and we published that some patients eventually will favor one of this insemination method over the other. Why? It's different between patients. So there is not 100%, way to decide to do for IVF or ICSI always, but these are the factors that we look at before we decide.
Thank you.
Thank you so much. And any other questions, you can definitely find the speakers at lunch and catch them and ask your question. Thank you so much for this session. And thanks a lot to all the speakers and my co-chair, Dr. Mahajan.
Excellency Ibrahim El Khatib. He has finished his bachelor's in genetic engineering and biotechnology in healthcare management, MBA in data science, and MSc in IVF, biotechnology, and human-based research. He has done his thesis on time-lapse monitoring systems and pre-implantation embryo development and kinetics. Ibrahim has more than 10 years of experience in the field of embryology and was a part of the team that started the first ART Fertility Clinics in Middle East. He has contributed to several scientific publications in the field of reproductive medicine in time-lapse monitoring, mosaicism, and embryo morphokinetics. May I please invite our panelist, Dr. Professor Colonel Pankaj Talwar, Director Medical Services, Birla Fertility and IVF. Dr. Talwar is a renowned fertility specialist in India. He has performed over 15,000 IVF cycles with a consistent 50% clinical pregnancy rate over the past 3 decades. Welcome, sir. Our next panelist, Bhagyashree Jhala, embryologist, ART Fertility Clinics, Ahmedabad. Dr. Merlin, lab manager, embryologist at ART Fertility Clinics, Chennai. Nandita Relkar, lab manager, embryologist, ART Fertility Clinics, Hyderabad. Dr. Surleen Kaur, lab manager at ART Fertility Clinics in Delhi. May I please request the delegates to be seated for the panel discussion?
Hello, good afternoon. So I thought, no, it's okay. So I thought the session to be after lunch would be better, but clearly people are hyperglycemic now. So the topic of this session or this panel discussion is about quality control. The reason we like to talk about quality control, not because of how an exciting topic it is, but because of the importance of quality control. Maybe we wait until they close the door. Just close the main door. Yeah. They can continue eating, but close because it's noisy. No, now I want to have a second lunch. Control, it's a very, let's say, dry topic, but more and more we're realizing the importance of quality control in the clinic in general, and this was represented in the regulations of scientific societies. We know that in the past few years, scientific societies such as ISHRE, Human Reproduction, they started to mandate implementing total quality management systems in our clinics. And the interesting part about the quality control in clinics is that it doesn't only involve the IVF lab. It actually involves everyone inside the clinic, from the receptionist who welcomes the patient until the accountant who takes the bill from the patient, right? Because what we care about is the whole process, the whole journey of the treatment. You can have, a couple who will get pregnant and yet they didn't have an overall good experience because of the attitude of the receptionist, let's say. And on the other hand, you can have a patient who never had embryo transfer, managed to have an embryo transfer, she didn't get pregnant, but she felt this relationship with the physician, with the team, still that will be considered a successful relationship. Now, quality also implies the results inside the IVF lab, because we know that oocytes, embryos are very sensitive, so we need to be very strict in the lab. So because of the time constraint, we will focus only on what we do inside the IVF lab. And we have here, we will utilize the experience of our panelists, starting with the first question, because obviously the title of this panel discussion is quality assurance and quality control. So the question is, what is the difference between quality control and quality assurance? Bhageshri, do you want to take this one?
Good afternoon, everyone.
Assurance is a bigger term where we look at the errors in the system and we are able to correct it before the things start going wrong. That's called quality assurance. And the bigger term is called TQM, that's a total quality management. That's the way I'll put it across.
So can we say that an example of quality control is the process of measuring temperature to check the station, and the quality assurance is in the morning checklist, for example, that checking the value of the temperature needs to be done?
Having constant watch, whatever is happening, quality control steps being watched as a third person. Everything is being watched every time. And before things start going wrong, rolling down, we just stop it. That's called quality assurance.
Implement now with this new term, the quality management system. What do you think are the elements, the main elements of a quality management system?
Quality management system, I think the most important elements are education, first of all. What I feel as gray hairs, making the processes, making the SOPs is very easy thing to do. But managing the mind, telling the people, teaching them, and they're adapting with conviction that whatever we are telling them is the correct. This is the most important thing where I feel we all fail. That's number one. And then we have to break whatever we do by making some standardized operating procedures. We have to make some SOPs with complete clarification and responsibility fixation. Because a lot of people work in the laboratory. We should know who's doing what step. In case we don't know that, we'll be making errors. And then we should be having sort of a witnessing system where somebody is watching you all the time and doing your hand-holding or doing course correction. And then most important thing, end of the day or whenever time comes, we have to do the auditing. During the auditing, we are able to see where things go wrong. But here, Ibrahim, the auditing should not be done at the month end. The auditing should be a real-time process because in case you miss a step of in embryo quality check. See, when we look at an embryo, we look at say, we follow any consensus. We say it's a mature blastocyst, 117 hours. but that blast may not implant in case we are using a wrong type of media or using a small step wrong in case we have a new team member joining. Before we realize that something has gone wrong, our results will start falling down. So it should be done at a constant real-time basis. This is the way I will put across the control of quality assurance.
So excellent, and I mean, just to summarize, because I agree 100% with what you said, even, a very detailed answer. So the elements of any total quality management system will include first the personnel, right? It's all the embryologists, all the admin, the nurses, they are involved in this quality management system. And also the equipment that are involved, because each one of them requires a specific calibration, a specific record. Very important is the training. I mean, training, we take it as what's written on the CV, but each clinic should have their own training system, right? Because you want to be able to reduce this inter-operator variabilities, right? Number 4, which is very important, that you need to apply the quality control measures. You need to have a protocol for that. And what you ended up talking about is the audits, which is a measure of the success, how successful is our system, right? Because you want to improve. And the best way to improve is to identify, every single step, what was the outcome. So this is done through external audits, internal audits, and also KPIs. So let's move to the next question. And of course, this is, a question for even the audience, if they want. Every one of us fancy a different type of lab or fancy something. So if we can briefly, just in a few words, describe how you would like to have your lab in relation to design, equipment, and furniture. Dr. Merlin.
Hello, everyone. Well, first of all, the location of the lab is very important. Although we are in a very busy city, we cannot have lab situated in the main road. So there's a lot of traffic and there's a lot of vibrations that can happen. Also, when we design the lab, we have to design in such a way that, again, there is nothing overhead, so there is no disturbance when there is a procedure going on. And when we design our lab, we have to make sure that we have an andrology unit, our storeroom, our cryo lab, and our airlocks are all within ISO systems, Indian standard systems. And equipments, yes, we have our own protocol. We design our own protocol of equipments that we need and how we calibrate. Also, to have an in-house management for calibration would be essential. So all these should be well thought of. And the furnitures that we use, yes, it should be stainless steel, SS furnitures, and non-fabric ones are mainly used in our labs so that we avoid VOCs. So considering all that, we'll fine-tune how we design our lab according to our inputs.
Thank you. Dr. Sorlin?
Yeah, I would like to add one point here that for the equipment part, it is better to have a replica. A second backup as equipment, like 2 ICSI stations, 2 incubators. If one shuts down, then there should be one backup in the lab so that the cycles should not suffer.
Yeah, so that's a very good point. And of course, I wanted you to dream a little bit. That's why I used the word dream. So for me, for example, you're excited about the question. So, okay.
Okay, so we already have quite a dream lab ourselves. So that is.
This is someone who will get a salary raise. Huh? This is the answer. This is a very political answer. Okay.
But we do have a really nice lab. So starting, this is what I feel that when we design a lab, we generally estimate the number of cases that are being done and plan accordingly, and have some room for expansion later. We would have stainless steel furniture, as she mentioned, HEPA. False ceilings with ducts for HEPA. So everything is sealed and there are no wires hanging or any of the construction materials. Epoxy flooring covered with epoxy so that, they are chemical or mechanical abrasions free. I would like to add hermetically sealed doors that avoid cross-contamination. That helps a lot with OT and lab being in the same place. Yes.
Would you like to have a lab, for example, in the center of the clinic where all the walls are glass and, for example, physicians, patients, they can see what you're doing in the lab?
Not.
No. So, and this is something very important because I believe it will be very interesting for patients to see what we are doing, right? Because then they start to know what we do, because now we do all the work and then the doctors take the credit. They don't see us, we're hiding. So maybe they can see what we do, they can see the long hours, they can see these procedures. But at the same time, it might be provide some distraction for the embryologist. So, but still, hopefully one day we'll be able to do that. All right, so one of the debatable or the questions that we don't have an answer, what type of incubators do you prefer? What type of culture conditions do you prefer? Do you prefer the humidified or you prefer the dry incubator? So, Dr. Pankaj, what's your preference when it comes to
yeah, any day. That's what we spoke in the morning, that we are very fond of, first of all, we have moved from the box incubators to the flatbed incubators. That's very, very clear. We don't use box incubators for any culturing. So we have two options. Either we go in for a triple gas incubator or an N2CO2 incubator, which takes in O2 from the air. Now, these incubators can be humidified or non-humidified. Humidified means that we'll pass the gases through a bubbling jar, which will make it humidified to around 95% or more. Then the embryos get humidified cultured conditions. It's a lovely system which we used around 3-4 years back. But now I personally feel, I can be quite adamant over that we should be only be using dry incubators. Advantage here is that a dry incubator, with a humidified incubator, the silicone tubings, they can get sometimes choked. They form bubbles, they can get infected. And then we have to change that flask every month or every 2 months. It's a big effort. We have to shut down the incubator for some more time. But I think the dry incubators are the future. That's what I feel, though debates will continue. But a flatbed incubator with around 10 chambers, one chamber per patient, is the future. They're maintenance free, and they work pretty well for me.
Yeah, just to add on what you said, there is not a proper study, for example, comparing what does the embryo itself prefers, the humidified conditions or the dry conditions. Of course, this is a very wide question because it depends on how you prepare the dish, what volume of oil. So I was very interested in this, and of course, in order to answer the question, you need to invest a lot because then you need to buy an incubator and do that. So we thought in a different way, and actually we're submitting our results to ISRI this year. So I can now, if you ask me maybe 1 week ago, I will tell you still I don't know the answer, but now I'm confident that dry incubators are as good as humidified incubators when it comes to embryo's preference with development, only if you have already good culture conditions to start with.
Exactly.
If you have, then, so now I believe that I can trust when I say dry incubators are okay. So the next question will be a case scenario. Maybe we can share it with everyone. So let's assume that you have been using a specific type of culture dishes for culturing the embryos for the past, let's say, 3-4 years. You're very happy with the outcome. Okay. However, your provider told you, listen, next month I can only supply 50% of what you requested. So what would be your action plan? Depending on, of course, your policies, how to order, when to order, what are the quantities you order, what would be your approach? Would you continue? Why? And would you switch to another type? Why? How would you choose? If we can briefly, because of time constraints, just give an answer.
So it depends on whether it's a long-term or a short-term supply deficit. So if it's a long-term, we would generally get it as we always have stock that's backed up. So we would continue that and do a sibling culture in the new dishes that are available. After calibrating those dishes with our QC, if it is comfortable and the results are comparable, then probably we'll shift. If not, then we'll continue.
And let's say that it was only a shortage for 1 or 2 months.
We would still run with the backup and sibling.
So your policy would be always to have a backup for every consumable that you use. And this backup is IVF grade and it's already
IVF
calibrated.
and MEA tested, yes.
Okay, so you can switch immediately because you know how you need to change your parameters in order to apply this, right? Dr. Pankaj, you agree?
Yeah, I'd like to make a comment here. We commonly face this problem in government where I was working before. Actually, all the plates which we use, they're all MEA, LAL and SAL tested. See, they've got all tests have been done for them. The only difference is that, the material is always polystyrene. They are low VOC plate coatings have been done on the plates. So it doesn't make a difference which plate do we use. We can use any plate. The only difference is that the droplets have to be made away from the wall. That's number one. Number two, the oil overlay. Oil consumption will go very high when I move from a 35 mm or a single well dish. I'll take around half ml of oil. In case I move to now 35 mm, that's going to take 2 to 3 ml of oil. And 60 mm will take around 12 ml of oil. The oil consumption will go high, number one. Number two is the incubators. I can't, every incubator has got a fixed capacity to work on. In case we take a flat bed incubator, box incubators we are not using anymore. So the flat bed incubator, they've got small platforms or chambers. Those chambers can take limited number of plates. So normally we say 1 chamber per patient. Probably going to put 2 plates here. So in case our plates go up from a 35 mm to 60 mm or say single well dish, then the number of cultures which we'll do is going to come down. So that's the main problem I face at my end.
Okay, thank you.
Yeah, but I want to say something here.
I have a better question for you. You will enjoy it more. So this is for Serline. You have 10% lower embryo utilization rate, whether you go to blastocyst stage or cleavage stage. Good? Now I will tell you some factors regarding the situation in the clinic. 2 months ago, you have installed a new microinjectors. Microinjectors are what we use to do the ICSI. You have a new physician that joined the clinic 3 months ago. And you had one senior embryologist that was on sick leave for 10 days. Good? Now, some information are 3 months ago, like joining of the physician, senior embryologist took a leave for 10 days. The installation of microinjectors, is it related to utilization rate? So my question is, what tools first will help you, you should implement in your lab in order to identify this change of 10%? And number two, what would be your action? What is your policy towards such an incident in the lab?
All right, so KPI will help me to figure it out if there is any drop deviation from the benchmark. So if I'll see 10% decrease in the utilization rate, definitely I'll go through A to Z things in the lab, but to start with, to find out the cause, I will do stepwise. First, I will see the direct factors which are directly affecting the embryo utilization rate, which is the media and the culture conditions, to go with first. So in media, I can look for the batch also, and also the media preparation. How is it, is there any deviation in the media preparation technique, or is it taken longer or something? Okay, and so for media, I'll go for the batch change or media preparation. And the culture conditions, I'll check everything like temperature and gas supply and the humidity factor also. But for these 3 factors, I will go later, not at the first go, because installation of a new ICSI station will affect directly the fertilization rate, not the utilization rate directly. Indirectly, it can if there is, there is some vibration in the anti-vibration table, which can later on affect the development, but it will has a direct impact on the fertilization rate rather than utilization rate. So I will not take that factor at the first go. And the second factor that you mentioned is that the senior embryologist was not there for 10 days, but it's just a 10 days factor, and it's not going to affect the utilization rate. But I will definitely check for whether the other embryologists, they are doing the they are selecting the sperm in a similar manner, which is the standard of the lab, especially the sperm selection I will look for. And for the physician joining, I will definitely look for the stimulation protocols at least once, that there is some factor which is going to affect the oocyte quality that can later on have an impact on the utilization.
Yeah, I mean, the first thing you will do is in this month, you will split the cases for the new physician and old physician, and you will see if they have the same rate, right? If they have the same utilization rate, which is lower, 10% lower, it means that most likely it's not stimulation related. But if you see that it's very specific to this physician towards the other physician, then maybe we need to look at the stimulation. Now, very detailed answer, thank you very much. Of course, all of these factors somehow can be related to the outcome, could be and could not. Normally, I like to always start with the things that are not normal. I always. Now, why I put this micro-manipulator in the question? Because, you know, we assume that utilization rate should be number of blastocysts frozen, transferred, divided by 2pn, right? But this is up to you to decide. And that's why when we started to talk, we said it depends on our experience. There is no right or wrong. I mean, you can also define utilization rate per M2, right? Per metaphase 2 or per COC. It's up to you. So at that stage, if your definition is per M2, then maybe degeneration is the reason. So I will check at degeneration. But in general, thank you very much. Thank you very much for, yes,
One comment here.
Of course.
So we are checking ourselves. That's called internal quality control. We look at our equipment, look at our team members, right? Embryologists, clinicians. I think I'll also go in for an EQC at this point of time. I like to look at the batch testing of the drugs, batch testing of my media, the simple protocols which we follow, and try to compare other people who are using a similar product. So that it's not only that every time we are wrong. Sometimes, the high days or ICSI media can be bad, or sometimes the drugs may be giving a similar outcome in some other country. So I think that's also very important.
Thank you very much for all of you, and thank you very much for attending this discussion. If you have any further questions for the panelists, we can ask them in between the presentations. Thank you.
Hello. Yeah, thank you, Ibrahim, and all the dear panelists for such an interesting panel discussion. Now it's time to move on to the next session. So may I now invite Dr. Meenakshi Dua, who's a clinical director at ART Fertility Clinics, Gurgaon. She's a well-known infertility specialist with a career spanning over 18 years in obstetrics and gynecology. She's a member of many associations like AICOG, IFS, FOXY, IMS, ISAR, RCOG, AOGD, and IMA. And over the years, she has treated hundreds of patients with male and female factor infertility, as well as those looking for donor cycles and surrogacy. Her areas of interest are poor responders, recurrent implantation failure, and male infertility. Welcome, Dr. Meenakshi. May I now welcome our second chairperson for this session, Dr. Nitin Lad. Dr. Nitin Lad is a scientific director and consultant at Assisted Reproduction at Dr. Lad's Navjeevan Hospital. Dr. Nitin Lad has around 20 years of experience in the field of infertility. He has great expertise and competence in embryology laboratory, example ICSI, IMSI, and blastocyst transfer, and has an extensive experience in clinical embryology, managing critical infertility cases and repeated IVF failed cases. To date, he has managed more than 10,000 cases of infertility, including patients from across the country and abroad. He has received accreditation from various national conferences like ISAR, IFS, Vertivision. Welcome, Dr. Nitin.
Thank you. Thank you very much. At the onset, I take this opportunity to thank Professor Fatemi and Art Center for your kind invitation. And also, I want to congratulate for arranging such a wonderful conference. To start with, in today's afternoon session, the first lecture will be delivered by Professor Sarah Brooker. She is the Executive Medical Director in the Department of Women's Health and Women's Hospital at Tübingen University. Professor is an active member of ESGE and Executive Board AGE. She is also a founding member of International Society of Uterus Transplantation, and she is president of German Society of Sinology. She is also an effective member of St. Gallen panel, a member of working group of the German Breast Cancer and Uterine Carcinoma Guidelines, and of the working group of the European Union Guidelines Breast Cancer. Her research is majority in the field of genital malformation and their therapies, gynec oncology, molecular-based surgical therapies, and breast cancer. With this kind introduction, I invite Professor Sarah to deliver her most awaited lecture.
Thank you very much, dear Chairman, dear Mr. Fatemi, dear colleagues. It's a great pleasure for me to travel the way from Germany over Dubai and to be here now in New Delhi. Thank you very much for your attention here, and thank you very much that you're interested in a topic which is not really dedicated to your daily work. Because what you are doing daily is that you help patients to get their baby, but they have a uterus, and normally they have also their own ovaries. But I'm talking today to you to a different topic, how could we help patients who are born without an uterus to get their own biological child, which is quite new. And if you talk about infertility, we heard the whole morning about endometrium and what is very, very important, that the endometrium fits to the embryo and the timing. But if you have no uterus, you have no endometrium. So you have to think a bit bigger, not only in the endometrium. But what makes uterus transplantation really exceptional are three things. First, it's an organ transplantation. And we as gynecologists normally never ever think about an organ transplantation despite ovarian tissue transplantation. So this is quite new, and therefore we need the general surgeon. And the general surgeon, they say, why should I transplant a uterus? It's not to save the life of a patient. So the second thing, what it makes very interesting is that we as gynecologists needed to convince our general surgeon and our transplant surgeon and the immunologist that a uterus, of course, does not save the life of the patient, but it gives life. And this is why you are all here. You want to give life and hope to your patient. And the third thing which makes uterus transplantation very interesting is from an immunological point of view. Imagine you transfer an embryo which already has two persons in it, the mother and the father, in an environment which consists of a third person, the donor. So this is immunologically very, very interesting. I have no clue how it functions, but it really functions. And if you then think about you transplant and transfer an embryo in a uterus from a third person under immunosuppression, this is again something which could maybe help in the future you as infertility specialist also to understand the immunological process behind artificial reproductive therapy. So if we talk about uterine transplantation, we started to help patients who are born without a uterus. In the future, maybe there will be included patients who suffer from fibroids, and the uterus is so damaged by fibroids that they will never ever get pregnant, so that you think about to remove this uterus and implant a new one. We don't know if these patients will be eligible in the future, or cervical cancer patient, for example, who lost their uterus due to the cancer in very early age. But the MKH syndrome is rare, but it exists, and Germany is a very small population. We have about 60 million inhabitants, but 8,000 women with MKH syndrome are living already in Germany. They have no vagina, but they also have no uterus. They only have their own normal ovaries, and they have a normal genotype. And due to a normal ovaries, a normal hormonal cycle, they develop totally normal female phenotype. Which is also important for later is that they have associated malformation. And if you think about a pregnancy and you have only one kidney, this is more likely, the patient is more likely to develop a preeclampsia, for example, which was the case in the first uterine transplantation patient in Sweden, in Gothenburg, where Mats Brönstem, the inaugurator, the father of uterine transplantation, is living. If we talk about MKH syndrome, I told you that girls, the woman, the patient, have no vagina. So they come to us in the age of 16, 17, and they are asking, why do I not have my period? And then we have to tell them, you can't have your period because you have no uterus, and you can't have really good sexual intercourse because there is no vagina. Of course, those girls don't think about fertility and become a mother. They think, how can I become a woman, create a partnership, have sexual intercourse. So the first step is always that we do and create the neovagina, which is done via laparoscopic assisted neovagina. We developed this method laparoscopically. We invented instruments for it, and we create, by stretching the vaginal dimple to 10 centimeters in about 5 days, a normal functional neovagina, which has good sexual satisfaction. We have a normal female sexual function index, aged, match controlled. So they are living, they are happy, they have a good relationship, but then they get older, and then they are at the age of 25, 30, and then they think about, oh my God, I just want to have a baby. And they really, really suffer. And they are young. And the advantage is that those patients already know at the age of 17, 18 years that they will be not able to carry a child. That's totally different to the population you normally have, because they are coming to you when they tried several years to get pregnant. And this is the advantage in those patients because they are young, and we can, for example, save their eggs in an early age. Surrogacy in Germany and in many other countries is unfortunately not allowed, and adoption in Germany is very, very hard. So for those, uterus transplantation is the only option to have their own child. So far we have done only 4 transplantations. I say only because we have a waiting list, but we needed to stop due to the COVID pandemic, because it's not a good idea to put a normal woman under immunosuppression if you have a virus. So therefore we needed to stop, and also worldwide the uterine transplantation programs. And additionally, we don't have space in the OR during the pandemic, but we will restart this year, and the programs worldwide will restart again. So why Germany? Why Tübingen? We are the only center in Germany who perform uterine transplantation, and this is why we have nowadays performed more than 600 neovaginas. So we have a really big cohort of MKH patients suffering from not having a uterus. And we have a close cooperation with our psychosomatic and general surgeon, because the general surgeon are the transplant surgeon, and you need them because you have to prepare tiny, tiny little vessels, the uterine artery and the veins, and therefore you need the transplant surgeon, and of course you need them also for the immunosuppression regime, because we are not experienced to deal with immunosuppression. Besides this, we did a lot of translational research, also not only in uterine transplantation, but also on the course of MKH syndrome. And along with the development in Gothenburg, I get the experience about 15 years ago now, 12 years ago. I met Mats Brännström. He talked to me at the conference like this and said, wow, can't you come to Gothenburg and teach me the neovagina procedure? And I went there, and at the same time he brought me to his animal lab and showed me his dream of uterine transplantation. So we were both in the same range and in the same contact, so that after he succeeded to do a uterine transplantation, at the same time we started the program. Starting the program means that we have built a huge team of experts in Tübingen. And these are not only the surgeons, these are the genetic people, the IVF people, these are the people for the lab, and people from the ethics. Because also in Germany, I really, really had to fight to go through all the ethics committee for the general Ministry of Health and Science, for the Living Donor Committee, and of course for the Standing Organ Transplantation Committee. It was very hard because they were all surgeons, and they thought, why is a gynecologist now in our room here, and what the hell is she talking about? But afterwards, I really did, I think, a good job, and I convinced them, and they said, okay, you can go for the first 4 transplantation, and we will really, really keep an eye on you, what you are doing. And therefore, we prepared very rough and very strict inclusion criteria. Because, think about, we do an organ transplantation on a healthy recipient, and we do it as live donor. That means we operate on someone 8 to 10 to 11 hours to take out the uterus and give it to a recipient. And the only thing which you always have to keep in mind, do not harm the donor. Because the donor is the mother of the recipient or the sister. Somebody, in Germany there is a law that you only can give organs to your own family or to your very, very close friend. So you do a surgery on somebody who is 55, 60 years old, and which woman in this age does not have any fibroids, for example, did not take any blood pressure medication, has not vessels with sclerosis. So these were all exclusion criteria. Of course, the exclusion or the inclusion for the recipients were not that hard. The only thing was that we said we stop and do not take recipients older than 38 years. Because from the start, when they come until they really have their baby in their hand, it could take up to 2 years. And you know from your own work that at the age above 40, even a normal pregnancy has a higher risk of preeclampsia, diabetes, and so on. And of course, we are aware of risks. Not only risk for donor and recipient, but also aware of the risk for the potential child. Malformation, for example, is not an issue. We know that we have over 25,000 children in the registry born after organ transplantation. So patients who did get a kidney, women who did get a heart, a liver transplantation, and they did get pregnant under immunosuppression, and we know that it's functioning. But you don't know if it's functional if you take the uterus from somebody else, the home of the future baby. So we had at the beginning more than 200 recipients who asked for a uterus donation. But at the end, you can see there were only 16, so less than 10%. And this is still the case. So we screen and screen and screen, and at the end, there are only 5 to 10%. We can really go through whole process of uterine transplantation. That means that 80–90% of them, they still suffer, but we can't give them an option. But this means that we need to have a close contact to our psychosomatic department because they need help as well, and they need other help. And this was the major point that I did, that I could go forward with the transplantation system and with the transplantation therapy, that I convinced everybody that we don't leave them alone, those 90% which we can't help with this method. So we take care of them as well. We did a thorough screening and postoperative surveillance, and this is what I told you. You need around 2 years until they have a baby in their arms, because what you know, we need to go for ovarian stimulation. There I don't talk about, you know it much better than I do. But what we are doing before we do a uterine transplantation, we take the oocytes of the recipient. Why? Because we don't take the fallopian tube with the uterus. Because you touch the uterus for 8 hours of surgery. You put it in, you flush it. So the fallopian tube could be damaged. There could be the risk of extrauterine gravity, for example, or sacrosalping. So we don't take the fallopian tube, so therefore we need to go for IVF. And the second thing is that with IVF, we prove that they really are fertile. Because what we know is that MRCH patients go and have an ovarian failure very early. So their AMH is the anti-Miller hormone level are much lower than in normal or women at the same age. So therefore we have the proof that they really can be pregnant. So this is the second reason why we do oocyte retrieval before uterine transplantation. But in 2 of our 4 recipients, we didn't have any eggs anymore after uterine transplantation, and we were suffering. We said, oh my God, what should we do? And we were the first who published that you can do an oocyte retrieval and a stimulation under immunosuppression as well. And although we put the ovaries a bit higher because we have to anastomose the uterine vessel to the iliac external vessels, and therefore we have to PEX the ovary higher, we could also do a transvaginal retrieval of the oocyte after uterine transplantation. So this was good. The transplantation is the same as in other organs from the main steps. You do an explantation, you perfuse the arteries and the veins to get rid of any blood so that you do not risk any thrombosis, and you implant. The problem are the veins. I don't want to go through it, but those little veins, some people have 1 uterine vein, some have 2, some have 3, 1 on one side, 3 on the other side. The ureter goes beneath, below, and above. So this is very, very hard. So we think about taking other veins, but this is type of research. So this was one of our uterus, which we explanted. Here you can see. And this is a video how it looks when it is implanted. This is just before the hysterectomy, the graft hysterectomy. But you can see, and this is a very good thing about immunosuppression, after major surgery, we do a laparotomy, we put in the uterus, we suture the vessels and everything. You see no adhesions. Immunosuppression helped to have no adhesions. So this is a good thing about immunosuppression. We did the first transplantation in October 2016, and as we saw here, the anastomosis between the uterine artery and the iliac artery, this was a very, very good sign, and we heard the vessel flow because we put tiny, tiny little probes to measure the Doppler sound around the uterine artery. So for the first 5 days, we had a really good thing. But is the uterus really functioning? The first sign of really functioning is when the patient gets her bleeding. And this is very exciting. Imagine they are 30 years old, 25 years old, never ever had their menstrual bleeding, and now they have their bleeding, and they say, wow, it could really function that I get pregnant, that I can have my own child. So this was a really good moment for them. But the proof of fertility, of course, is when we have a successful pregnancy resulting in a healthy child. So these are results, and you can see the first uterine transplantation patient needed 4 embryo transfer until she delivered a baby. She is now pregnant the 2nd time in her 70th week of gestation. And all the other 3 only needed 1 embryo transfer until they delivered their child. This is a huge table, but I only want to point your attention to this point. We had 1 donor who was a mother who was postmenopausal for 3 years. And this postmenopausal uterus, we could transplant in a recipient, in a young person, and it started again to develop a regular endometrium. I think this is so fascinating. The children were born in the 36th week of gestation, 37 weeks of gestation, and 34th week of gestation. They are really healthy. The oldest is now 6 years old, so we have already a quite long-term follow-up of them, and they are very healthy. They develop totally normal. But we have still many, many questions to answer. And this is not a routine thing, uterine transplantation. This is just the start of something very, very new. And of course, we have not a lot of data currently. Deceased donor is also something what is thinking about not in Germany, in other countries, but the problem is we have multi-organ donors, and which organ you take first. Normally you take the life-saving organs, and then you have 6 to 8 hours until you take the uterus out in an already not functioning blood flow. So this is the question how we deal with deceased donor. And this is my nearly last slide. After at least 2 children, you remove the uterus again, and we were the first to publish that we did it minimal invasively, so we do not reopen again, but we did a graft hysterectomy minimal invasively. And this is because we need to stop the immunosuppression somehow at some point, and this is why we do graft hysterectomy. And this is what we published. Here you can see the external arteries, and this is just a little stump from the anastomosis. And worldwide, there are around 90 uterine transplantations performed, 50 in living donors, 16 in deceased donors, and already nearly 50 healthy children born. And with this video, I would like to thank you for your attention.
Thank you very much, ma'am, for your lucid presentation. Just since we are running short of time, we'll switch over to the next presentation.
We'll take questions at the end of the session.
Pardon?
We will take questions at the end of the session.
Yeah.
Thank you so much. I invite our second speaker, Dr. K.D. Nair, President IFS. Dr. K.D. Nair has been actively dedicating his career to the cause of infertility and has trained several leading IVF specialists across India. He commands a lot of respect in medical community. Dr. K. Nair has been the course director at Foxy Certified Infertility Training since 2014. In addition, he has made 18 international presentations at ASRM annual meeting since 2006 and another 19 presentations at ESHRE annual meetings since 2017. While Dr. K.D. Nair spends a lot of time in updating himself and contributing to his rich experience in the cause of infertility management, he has presented at several international and national conferences and workshops on infertility and reproductive medicine. Over to you, Dr. Nair. Thank you.
Good afternoon. Good afternoon, ladies and gentlemen. From uterine transplantation, we are coming to fibroid uterus. Like the speaker before me mentioned, for a donor uterus should be free of fibroid. Now, what happens when a woman is having fibroid? Whether we should remove it or not to remove. I have no financial disclosure. The contents of my talk is classification of fibroid, uterine fibroid and infertility. What are the current management strategies? What is the algorithm and clinical evidence to remove or not to remove? And what do the guidance says? The uterine fibroid are hormone-responsive benign monoclonal tumors, and 77% of all women will develop fibroid in their lifetime. So 23% of women are capable of donating the uterus. 77% will have fibroid, and 15 to 30% of these women have substantial symptoms, which can be pelvic discomfort, dysmenorrhea, menorrhagia, urinary incontinency, recurrent pregnancy losses. So basically, fibroids are a major cause of morbidity in women of reproductive age group, and sometimes even after menopause. These are the various types of fibroid. All of us know it can be submucous, intramural, subserous, it can be pedunculated, it can be pedunculated submucous, which can be coming in the vagina. So these are the various types of fibroid. This is the classification, the FIGO classification of fibroid. It's a very old classification. All of us know that submucosal can be type 0, 1, and 2, depending on what the growth of the fibroid, whether it is less than 50% intramural or more than 50% intramural. And the other classification, other sites are type 3, 4, 5, 6, 7. It will depend upon the intramural, how it is in the muscle and how far it is away from the serosa. And the hybrid leiomyoma, they can impact both endometrium and serosa. We are going to talk about the submucosal, intramural, and subserosal, whether they are to be removed or not to be removed. The optimal evaluation of fibroid is transvaginal ultrasound, histoscopy, sonosonography, histography, MRI. Only thing is histoscopic assessment can underrepresent submucosal lesion because the intrauterine pressure can cause a temporary regression of the fibroid. So you have to be very careful when you are doing histoscopy. Uterine fibroid and infertility. Why uterine fibroid is causing infertility? It is causing a distortion of the cavity. It is causing endometrial and myometrial impaired blood supply. It is causing increase in uterine contractility. There is hormonal, paracrine, and molecular changes. There is impaired endometrial receptivity and gene expression. So impaired endometrial receptivity is one of the factors of fibroid causing infertility. When you look at the fibroid infertility, the presence of uterine fibroid is impacting endometrial gene expression, and it contributes to failure in endometrial receptivity. So this is a factor you have to remember, that fibroid can cause a change in the endometrial receptivity. And submucosal uterine fibroid can distort the uterine cavity, which interfere with the embryo implantation and placentation. Now the debate, whether to remove the fibroid or not to remove. We go back to this algorithm which was published by our federation, the Indian Federation of Gynecologists. It was published, and they say it depends upon whether the fibroid is asymptomatic or symptomatic. If it is asymptomatic, if uterus is less than 14-week size, you can do expectant management. If uterus is more than 14 weeks, you can discuss the option with the woman and probably give a surgical management, hysterectomy or myomectomy. If the patient is symptomatic, it depends upon you can give medical management, or if the patient is having infertility, if it is submucosal fibroid, remove it. If it is other type of fibroid, you can do expectant management. This algorithm was given by our Federation of Indian Gynecologists. Now we come to the issue whether to new novel approaches and algorithm with a special emphasis on infertility. It was published in ASHRAE, the uterine fibroid management from present to the future, landmark paper by Dones. To address the question which therapy to adopt, it depends upon the patient age, the severity of symptom, wish to preserve the uterus and fertility, and localization of fibroid according to FIGO classification. The grade 0 myoma, submucosal, if they are present, you have to simply cut it with a histoscopy. That is all what is needed. You have to remove the fibroid. Histoscopic myomectomy. When you have type 1 myoma, in the majority of the cases, histoscopic myomectomy can still be done. It is relatively straightforward for experienced surgeon. If the fibroid is of type 1 but larger than 3 centimeter, or patient present with anemia, you can give a pre-histoscopic medical therapy or selective progesterone receptor modulator. That can be given. So type 1 myoma, if it is less than 3 centimeter, you can do straightforward histoscopic myomectomy. If more than 3 centimeter, you can give medical therapy to improve the anemia, specific progesterone receptor modulator, and if thereafter you can go for histoscopic myomectomy. Type 2 or type 2 to 5 myomas, whether it is single or multiple, distorting the uterine cavity. If it is a young infertile patient of reproductive age group and wishing to conceive, in such cases you give medical therapy, selective progesterone receptor modulator. It can be given 2 courses for 3 months each. If the young woman of reproductive age group with symptomatic myoma and wishing to conserve their fertility but having no immediate desire of pregnancy, here too medical therapy can be given, and this can be given for 4 courses or 3 months. So when they have no desire to have immediate pregnancy. Type 2 to type 5 myoma in a perimenopausal age group with symptomatic myoma and no desire for pregnancy, but they want to keep the uterus, you can give them, in such a perimenopausal woman, you can still give them medical therapy. Medical therapy can be for 4 courses for 3 months. If there is a good response, you can stop the treatment. If there is insufficient response, you can go for hysterectomy or myomectomy. Now we come to intramural fibroid. That is whether to operate or not to operate. Whether removing the laparoscopic myomectomy improves the pregnancy rate over the non-surgical myoma, It paper published by Ability in 1999. He did a study on 212 patients who were investigated for fertility, and 106 underwent laparoscopic myoma, 106 who didn't operate, and both the groups were compared for unexplained infertility with myoma. Out of the result, the total number of women who became pregnant and delivered live birth was 83. That is 26% out of 318 patients, and delivery rate was almost 42% who underwent surgical removal of myoma. So when you have intramural myoma, it's better to remove. But there are different opinions. It is not advisable to perform myomectomy or intramural fibroid that are less than 5 centimeters, and definitely not for those less than 3 centimeters. It was mentioned by Raphael in 2013. And the Society of OB-GYN of Canada in 2015 came out that there is fair evidence to recommend against myomectomy in women with intramural fibroid, confirmed intact endometrium, but otherwise unexplained infertility, regardless of the size of fibroid. They say don't remove fibroid, don't do myomectomy. But there were other opinions. Lewis in 2017 said that the intramural fibroid, it is recommended the removal of intramural fibroid when they are more than 4 centimeters in the setting of infertility or failed ART cycle. And it might not be unreasonable to remove intramural fibroid more than 2.85 centimeters in a setting of patient with recurrent pregnancy loss or multiple failed cycles. That was again in 2017. Important thing is that the reproductive age is still the most important determinant of live birth rate. And myomectomy may be performed sooner rather than later in women with intramural fibroid more than 4 centimeters with a decreased ovarian reserve or advanced maternal age. So you have to always consider the age of the woman. The proposed algorithm for intramural fibroid, less than 3 centimeters, you can give expectant management. More than 3 centimeters, you can give medical treatment for 3 to 6 months, depending on the response. And then you can proceed either to IVF or natural conception. If there is no reduction in the size, you can correct the information, and you have to discuss about whether there is possibility of surgery or not surgery. And if the size remains more than 4 to 5 centimeters, go for surgery. The submucosal fibroid, whether to remove or not to remove submucosal fibroid and infertility, the effect of cystoscopic myomectomy and factors influencing outcome. It was a Indian publication published in 2013 that cystoscopic myomectomy is safest procedure to enhance fertility, especially in case of unexplained infertility. And the result of the study, that 29% conceived after the cystoscopic myomectomy. Uterine fibroid, to remove or not to remove, there are other studies which are published by Ubaldi, Goldenberg, Vercellini. They say cystoscopic myomectomy is a safe and effective procedure which enhances the fertility. So if you have some mucosal fibroid, it's better to do a cystoscopic myomectomy. We at our center in Delhi, during the COVID period 2020 to 21, we had 18 patients with submucosal fibroid type 0 and 7 patients with type 1 and 2. We did a myomectomy for such patient, and out of the grade 0, 6 patients conceived, 33%. Out of type 1 and 2, only 2 patients conceived, 28.5%. The miscarriage rate was 16.6% in the type 0, and in the type 1 and type 2, the miscarriage rate was 1, that was almost 50%. But this was a small study, we did it during the COVID time. Now, to remove or not to remove, what do the guidelines say? The ASRM, they say in asymptomatic women with cavity distorting myoma, whether it is intramural with a submucosal component or a submucosal, myomectomy, open or laparoscopic or cystoscopic may be considered to improve the pregnancy rate. And myomectomy is generally not advised to improve pregnancy outcome in an asymptomatic infertile woman with non-cavity distorting myoma. However, myomectomy might be reasonable in some circumstances, including but not limited to severe distortion of the pelvic architecture. This is ASRM guidelines published in 2017. Our Federation of OB-GYN of India, FOXI, the myomectomy is an option for women who wish to preserve their uterus. It may enhance fertility and benefit heavy menstrual bleeding. Cystoscopic myomectomy should be considered as the first-line conservative surgical therapy. Laparoscopic myomectomy should be preferred over abdominal myomectomy as it is associated with faster recovery, less blood loss, diminished postoperative pain, and fewer overall complications. And pregnancy can be planned 3 months after myomectomy. According to the recent meta-analysis, the surgery lead to a high pregnancy rate, almost 75.6% among 1,575 women suffering from fibroid, which was published by CAW in 2020. The operation can be a source of severe obstetrical issue. When you do myomectomy, you are exposing this patient to abnormal placentation in future, possibility of uterine rupture, ectopic pregnancy on the myomectomy scar. So uterine rupture is particularly feared because of a poor obstetrical outcome, even though it is rare. After myomectomy, practitioners should advise a minimum delay before trying to conceive in order to avoid such complication. So you should not conceive immediately after myomectomy, at least give 3 to 6 months. Intramural fibroid more than 3 to 4 centimeters should be removed before IVF. The debate continues. The pro in favor of removing the myoma, there are all published studies say the meta-analysis reviewed by donors and Dolman concur that non-cavity distorting intramural myoma do indeed have a deleterious impact on IVF outcome. Two factors have emerged. What is the size of fibroid? The larger is the fibroid, more is the production of transforming growth factor, beta-3 secretion, and how proximal it is to the uterine cavity, to the endometrium. A type 3 myoma of 2 centimeter more will have a detrimental effect close to the endometrial lining. If fibroid is intramural but not in contact with underlying endometrium like type 4 and type 5, 3 centimeters is usually considered the cutoff. If it is less than 3 centimeters, don't remove it. More than 3 centimeters, you remove it. Again, the several data are reporting the negative impact of myoma on reproduction and obstetric outcome. And decision for a laparoscopic approach must be balanced between uterine pathology and experience of the surgeon. It is important. What is the experience of the surgeon? There is much more to gain for patient and surgeon by a well-performed myomectomy through laparotomy rather than a difficult laparoscopy and inappropriate suture. This is important for my colleagues that until you have experience, don't undertake laparoscopic, you can go for an open laparotomy. There are opposite views about doing the myomectomy for intramural more than 3 to 4 centimeter. Because the preliminary data, it was published in 2021 in Fertility Sterility by McClung, that the preliminary data are consistent with the hypothesis that type 3 leiomyomas are indeed the intramural tumor with the most significant impact on endometrial receptivity, which are not confirmatory. I mentioned the effect of fibroid on endometrial receptivity, but they say the effect on endometrial receptivity are still not confirmatory. And it seemed necessary to produce more studies to evaluate the effect of type 3 tumors on relevant endometrial molecular expression compared with those other type and further areas, further to assess the leioma impact on the spectrum of fertility and pregnancy. So you have to still assess what can be the effect of leiomyoma on fertility and pregnancy outcome. What are the non-surgical treatment management available for future, in women desiring future fertility? You have uterine artery embolization, you have magnetic resonance, guided focus ultrasound, you have myolysis and radio frequency ablation, but they have their own limitation. And the role of medical management desiring future fertility, short-term use of GNR analog can be used for imperative correction of anemia or short-term reduction of fibroid volume. And the use of unipristol, 5 to 10 milligram, has been recommended in the past, then it went out of favor, but now it is again come back as a drug of choice. The low-dose mifepristone is a new thing we are having with us, 10 milligram or 25 milligram. It is affecting both on decreasing the size of fibroid, it induces amenorrhea, inhibit ovulation, and it stops bleeding. So it is a very good drug in a poor country like India. This mifepristone, very cheap drug, give it 10 milligram, and you have all the benefits. Removal of myoma in asymptomatic patient to improve fertility, how to reduce miscarriage rate, published in Fertility Sterility. In asymptomatic women with cavity distorting myoma, intramural with a submucosal component or submucosal myomectomy, or either open or laparoscopy can be considered. And myomectomy is generally not advised to improve pregnancy outcome in asymptomatic infertile women with non-cavity distorting myoma. So the key term is cavity distorting or non-cavity distorting. And myomectomy might be reasonable in some circumstances, including but not limited to severe distortion of pelvic architecture. The summary of the whole discussion is FRITAG published in 2021. Submucosal fibroid should be removed before assisted reproductive technology or in cases of habitual abortion. Subserosal fibroid, as they do not seem to affect the pregnancy rate, myomectomy does not appear to be necessary. Intramural fibroid more than 5 centimeters, you perform surgery before ART or in case of habitual abortion. Intramural fibroid less than 5 centimeters, the reported outcome varies between no difference and significantly reduced cumulative pregnancy rate. So you have to take a call whether you want to remove this fibroid or not. Thank you very much.
Thank you, sir, for such a wonderful lecture on fibroid. And as discussed earlier, we will take all question answers after this session is over. Thank you very much. And we will move on to our next speaker, and she is Raquel Del Gallo. She is the Program Manager, Artificial Intelligence ART Fertility Clinic at Abu Dhabi. She is a graduated in Biological Sciences. Dr. Gallego holds a master's degree in Biotechnology of Human Assisted Reproduction, recognized with an Academic Excellence Award. She is currently pursuing a PhD in medicine at the University of Valencia, Spain. She is also author and co-author of over 40 peer-reviewed research papers or abstracts in international journals and conferences. Dr. Gallego specializes in time-lapse systems, especially on improving embryo selection through morphokinetics and the introduction of artificial intelligence in the IVF lab. The Spanish Society of Assisted Reproduction and Embryology has awarded their work on artificial intelligence with the Merck Innovation Award in the year 2019. With this short introduction, I request Dr. Raquel to start her lecture on artificial intelligence in ART.
Thank you very much for the very kind introduction. And artificial intelligence is a topic that I love to talk about. But today is especially exciting because we are about to start an artificial intelligence program in ART in collaboration with NYU Abu Dhabi. So let's talk about what needs to be brainstormed before starting this program and what needs to be thought about and standardized before that. So the main two applications of artificial intelligence in IVF and in any other field would be automation and prediction. And of course, automation part would help us more, the clinicians or the embryologists, the professionals, because it could help us standardize techniques, help us with classification to make it more standardized between all of us, and in the decision-making process. On the other hand, prediction, it could help more our patients because they could have better expectations on when they can have an outcome, a positive pregnancy, and the time to a live born. But of course, they are very interconnected, and prediction could also help us to manage expectations on our patients. So what are the specific questions that we can answer in these two main groups? The first one, in automation, we could talk about which stimulation protocol should I use, medication and dosage per patient, is this the right hormonal balance, when should I trigger, which fertilization technique should I use, which sperm, which is my highest grade embryo, when do I biopsy, which endometrial protocol should I use, or when do we transfer? And all of these are outputs of automation. In terms of prediction, it would be how is my treatment going to perform, how many cycles do I need to this lady to have a baby at home, how many COCs or M2 will I obtain, how many oocytes should I have to freeze in a fertility preservation program, how many blastocysts or euploid blastocysts will I obtain, number of transfers to do, will they implant, will they miscarry, will we have an ongoing pregnancy and a live born. So all of these are outputs that we need, they are the answers that the models can give us. But what do we put into the model as an input to create these outputs? We have years and years of IVF data, and we can start from pre-stimulation, the basic patient characteristics. Most of them are quite objective because the patients already come to the clinic with them. Some of them are decided by us, so they still have a little bit of bias. Stimulation parameters that are chosen by our clinicians Of course, this also depends a lot on experience and on personal decision. And implantation, the same way, endometrial preparation, which protocols, medications, and so on. And as an embryologist, for the laboratory parameters, we have a million data points that we could check about. Each different laboratory works in a different way, and since I moved to the UAE, I realized how different people work and how much we all believe in the way we work. And we think our way is the best one, and there's a lot of variability between labs. And of course, the new data sources. Of course, the ones we are more familiar with is PGT, because now we are doing PGT in a lot of cases, in our case, most of the cases. And morphokinetics also, I would say it's a very well-studied field. But the rest of them, more or less, they are quite innovative and still not easy to implement into lab settings. So they are still there. If they were easier to use, of course, we will implement them. So all of these data points can only be analyzed with artificial intelligence, all of these big data. So what are the main challenges for our artificial intelligence model? First of all, bias in the big data set, so in the global data set. So I brought two main examples to explain this. In the first one, they developed a model where they wanted to create a prediction model with images to find melanoma in patients. They put the model, and it was performing amazingly. In fact, it was performing at 20% better than the doctors. But when they got this same model and they took it to Uganda, they realized that in black population, the prediction was not doing well. And in fact, out of all of the images they put into the model, only a 20% were predicted correctly. So they realized that the training data set in the beginning only contained a 5% of black people images. And this was why the model didn't know what to do with these images, didn't know how to predict them properly. And this is a very bad targeting of the study or of the model, because in fact, black patients have the highest mortality rate in melanoma. And the 5-year survival rate for them is a 70% as compared to the white patients, which is a 94%. So of course, if you are doing such a model and such a predictive model, you should understand which patients would be more benefited about it. On the other hand, this was another study where they wanted to check the X-rays from the chest to also detect the cancer. And what they did was that they chose two main hospitals to train the model with. The first hospital gave a little bit less of images, but if you can see, the proportion of positives and negatives was quite unbalanced. There were less negative and more positives. In the other hospital, they gave way more images, and it was a bit more balanced, but a little bit more negatives. So the model, when they started using it, they realized it was not working well, and why not? And when they went back to the training pictures, they realized that this hospital were giving images a bit closer to the chest and a bit more bright in appearance, and the other one was a bit more far and a bit more dark in appearance. So the model was just learning to say, if it's white, it's a positive. If it's black, it's a negative. And I will be right a very high percentage of the time. So, of course, these things need to be checked very well in detail before doing the model. And how this goes to our settings. And in fact, in Abu Dhabi, we have the majority of our retrospective data there, and 90% of our population is Emirati, is local. So we have a very specific population here. Our population has high parental consanguinity, deficiency in vitamin D, high obesity rates, and a very low ovarian reserve and poor response. So of course, if we were about to do this modeling, we should take into account that this model will be helping these kind of patients and these kind of patient characteristics. But if we have any other, like these other 5–10% of patients that don't include into this, we should be very careful to see what the model is predicting about them, because maybe we shouldn't trust it as much. And if we use them for the training anyway, we should really check that everything is very standardized. like pregnancies, positives and negatives are similar, and everything is like standardized, so that we could really use them for them. Another thing is what we are using to train as it is, as the detail. So, of course, as an embryologist, I will explain the embryo part of it. And many studies have been using blastocyst quality to standardize the blastocyst quality, or morphokinetics to see how are we doing the prediction of the embryos. But of course, these two are still subjective because they are chosen by an embryologist, and there's a lot of variability between the people. And in fact, this has been very widely published, that there's a lot of inter and intra-laboratory variance between people and between professionals. This paper, in fact, was one of the ones explaining it better, and what they saw was that in 99 blastocysts, that were graded by very experienced embryologists, 2 of them. In 55 cases, you can see the green ones, both embryologists said that they had a good grade. In the yellow ones, the embryologists didn't agree on the grade of the embryo. But the ones that we should worry about are the red ones, that were 6 cases in which one embryologist said it was an embryo able to be transferred or vitrified or biopsied, but the other one was saying, let's discard it, it's not worth. So, of course, these are 6 opportunities for a patient or for several patients that we would be throwing away and not using. And, of course, this is also not our fault. We are a bit limited on the way we do things, and selecting embryo quality is categorical, and we are using, for example, the main ones that I know, Gardner and Acevedo criteria, which we have the several categories. The boundaries between categories is not well discriminated, and we usually, as embryologists, compare between the cohort a lot. So we see all of our cohort, and we will compare first embryo with second embryo, third embryo. We will not be subjective one by one. We will just say this one is better than this one, so A, B, and so on. As well, we are limited in the way the images are. Sometimes, if we are not able to move focal planes or we don't have moving videos and so on, we are limited in the way we see things about the embryo. As well, the evaluation time is not standardized. Sometimes the day is very busy, and we will see the blastocyst of another patient a bit later than we should have, and sometimes even an embryo is looking horrible right now, and maybe in an hour it was looking very well because it had a bit more time to develop. There are some parameters that are very difficult to assess, like number of cells in the trophectoderm or volume. And of course, the human factor is always a big factor. We are working depending on how tired we are, our mood for the day, the weather, even our personality, and this will also affect the way we grade. And this was a very interesting study that was published in ESRE this summer. And I found very interesting the question, which was, is there bias in the way we select the embryo to be transferred depending on the number of the well in the dish? And in fact, the embryologists, they were selecting first an embryo that was placed in wells 1 to 5, rather than an embryo that was placed in wells 9, 10, 11, 12, and even if they were same grade embryos. So, of course, this maybe artificial intelligence could help us on it. So, everyone can conclude on this that images is the best way to train the models because it's the most objective and it's not that much related to the subjectiveness that we can bring. But also the images bring a little bit of subjectivity because there's many studies that nowadays they are using static images, actually most of them. So at what time should we choose these static images? And if we choose them a certain time, like 115 hours post-insemination, what about the day 6 embryos? We are never going to put them into the model. Like, there's a lot of things that are missing in the model. And very little ones using dynamic images, but I believe it will start going forward. And in fact, this study was very interesting, and they wanted to check the different predictive value that different parameters were giving to to the model. And in fact, they started using only static images, then they continued putting videos of the blastos or videos of the cleavage, clinical parameters, and they realized that as they were increasing the number of variables, the artificial intelligence model was performing way better. And in fact, in the end, what they did was that they put the full video inside, and the artificial intelligence said, okay, from this video, I like only this part and this part. I don't think there's any value in this area here from maybe day something to day something, so we can remove it. And that was the best model in the end. And of course, we need to homogenize data and homogenize images. And if we have different time-lapse systems, for example, we need them to be the same for the model. If not, he could be biased. And as well, if our blastocysts are getting out of the well, this will bring a lot of variability. And this is just an example of a very good paper, actually. And this is one of the best papers in terms of modeling and algorithm that I have read. And in fact, that they explained very well how they did things. And the interesting part about it is that they were using normal objects to pre-train the model, like all of the images you can imagine to pre-train the model, so that it was robust enough to see pixels, to understand the biological figures or something like this, so that in the end we could train our blastocyst afterwards, and it was way more predictive than what it would have been before. And of course, the clinical data. Clinical data is really important, and this has been left a little bit apart. And I think without the clinical data, we cannot really create a model that will predict like reliable enough. And of course, age is always in all of our studies. Age is so important. And this study, they realized that when they were introducing age into the model, it was performing way better than before having it. As well, there are 1,000 parameters in clinical practice that we can use. And of course, there will be always more subjective and more objective ones, but we have to be there to try to choose the more objective ones and if not, see how the distribution goes along all of them and really check which one should we use. But of course, like before, we could always put them all into the model and let the model decide what's good and what's worse, what's giving more predictive and less predictive. And if it's giving a lot of predictive and it makes maybe not that much sense, check if maybe our data set is biased. So to conclude, the benefits and opportunities, we are able with artificial intelligence to analyze simultaneously a big number of data points and increase the number of the parameters we are seeing. This could save us a lot of time and improve the clinic workflow. It will increase the objectivity for our professionals and between them, and it will increase the reproducibility between the clinics as well for maybe big groups. Maybe we could also find novel parameters that could help us better to find what's associated with infertility. That would be ideal. And we could increase overall the accuracy of our predictions. Going for a better decision-making process, of course, to end up in a live birth earlier and to set this single embryo transfer goal for everyone to avoid the multiple pregnancies. And just a comment about the novel parameters associated with infertility. This was a model that was trained to play tic-tac-toe or tres en raya for my Spanish friends. And they realized that the model was saying things in a different way to humans. And in fact, we are biased as humans to see what we want to see. We have our experiences and we are looking for things. And of course, if this gets a bit out of the box, sometimes we don't see it. And artificial intelligence could help us to see out of this box and avoid our limited parameters. But of course, the other side of the picture, a lot of people ask me, is artificial intelligence going to replace us? And I would say, of course not. Artificial intelligence is only here to help, and it's still very baby to even help us yet. But in fact, it's impossible to train a model with all of the images we see throughout our lives and all of our experiences. And humans will always have one thing, which is intuition. And on this, they could never replace us. And of course, we will always have to be there to check and see if they are performing well, if the interpretation makes sense, and if we should redo the analysis. So that's all. Thank you very much.
Thank you, Raquel, for such an enlightening talk. And definitely AI is the future. With so many variables which affect infertility, AI will definitely help us. We'll take questions at the end of the session, and we'll move on to our last speaker for the session. I invite Professor Ying Chong. He's Professor of Reproductive Medicine at the University of Southampton, Medical Director of Complete Fertility. Professor Ying is a consultant gynecologist who has worked in many of the UK's leading IVF clinics and is an expert in fertility surgery and miscarriage. As a specialist in fertility treatment and surgery, her key areas of clinical interest include laparoscopic and open fertility surgery, endometriosis, recurrent miscarriage, polycystic ovarian disease, and adhesions. Professor Ying has been awarded numerous research grants and awards from NIHR, MRC, Women in Science and Engineering, and charities, and is also the editor and author of over 100 peer-reviewed papers, books, and chapters. Welcome, Dr. Ying.
Thank you, Madam Chairman. Thank you for the kind introduction. And very glad to see the diehards of us all staying still bright. Now, we're continuing with the IT team with regard to biosensing. And I'll explain a little bit about what it's all about in the next 20 minutes or so. Now, in this talk, I'd like to cover 3 areas. First of all, just some of the knowledge gaps that we have in obstetrics and gynecology in reproductive sciences, right? And then I'm going to introduce you to the biosensor landscape. What is it? What does it entail? And finally, of course, some current and future strategies that we could improve our understanding of the uterine environment and therefore individualize better. I do have a warning that I may create more questions than answers. And as we've all known for a long time, there is a gap with how many cycles we do and what we achieve in terms of pregnancy. But not only that, and if you look across obstetrics and gynecology, you will see that actually we have so many early pregnancy complications, obstetric later complications, antenatal or intrapartum, and we, the problem is our lack of understanding of the pathophysiology behind that, our lack of understanding of what actually happens inside the uterus. If we look at what we have currently in terms of assessing the uterine environment, we will quickly find that it's limited. We have maybe take a bit of biopsy, take a little bit of look inside with a hysteroscope. They're all snapshots. They don't account for cycle-to-cycle variation, and it doesn't have a global view of the uterus as such. If only, ladies and gentlemen, we can sense the uterine environment continuously, in vivo. That would help so much, won't it? What is a biosensor? A biosensor is essentially something that you can have that detects an analyte, converts that signal into a signal that we can understand. And that's essentially what a biosensor is. And this schematic gives you a little bit better illustration. You have your analyte, you have your receptor, whichever ones, and then you have your transducer, which converts the signal, whether it's optical, electrical, by mass, etc. And then you get your signal that you can then interpret. And that's essentially the definition of a biosensor. And the biosensor that we are familiar with is that of diabetes and how we analyze blood sugars, for example. And this innovation has happened way 60 years ago, started off with simple electrochemical analysis, and then gradually with time, this has developed into nowadays what you and I know of glucose analyzing in your diabetics. And nowadays, the most advanced, you have the sticker on the patient with the signal glucose on their phone, telling the doctors what is happening. And that has come and is not going away. And these complex platforms obviously has now been developed into even more complicated areas of innovation, such as that in dentistry, for example, the tattoo that changes colors, the contact lenses that tell you what is happening with your glucose, and so on, all the electrolytes, and these have morphed into a combined platform where it can be powered by motion, powered by solar energy, so on and so forth. And eventually, of course, this is to be integrated into the electronic health records, that then everything becomes very much automated. Well, that is the advanced wearable biosensor platform. And the market for this is huge, you can imagine, because, of course, the convenience that it brings to our patients and people in general in terms of their health and well-being. And so you see there as a prediction of the growth is spectacular in this area. And in terms of in utero biosensing, where are we? Have we done a lot? What has been happening in this area if we're going to sense what's happening inside the uterus? Well, there are two main areas that you can really do the sensing within the uterine environment. First, we could take the fluid, components, hormones, and so on, analyze that continuously and see what's going on, a lot of what we've been discussing today. And of course, you can also look at the biophysical profile, these simple things that we already measure in many aspects of medicine, temperature, oxygen, pH, so on and so forth. These are the biophysical profiling that we're talking about that I have a specific interest in. And yeah, I've mentioned this already. Now, if you look at the biofluids, who has been doing what? This research is going on, and it's actually a really exciting field, but in terms of uterine biosensing, it's really rather limited. People have used aptamer to look at how to detect hormones and so on, but there's still quite a bit away from translation into clinical practice. Now, I'd like to also be introducing you to this biophysical profile sensing. Now, we all know that it's really important to have a precise monitoring oxygen, pH, temperature in the laboratory, of course. Because if anything goes wrong, you have issues with development, so on and so forth. Your embryos don't do well. So it's really important that we are meticulous in the laboratory. I'm sure we all agree. And then when we come to clinical practice, the surgeons, clinicians in the audience, you know, sometimes we put the hysteroscope in and we see this uterus is totally abnormal. For example, in uterine adhesions, huge distorted uterine cavity, and you know, intuitively, intuition is very important. Intuitively, you know, this is not normal, but there is nothing to check it. And then, of course, we have the normal uterus, the normal-looking uterus that you know the embryo hasn't implanted. You've put euploid, all this, check the hormones, they don't implant. And you think, what's going on? Can I have something to test it so it can help us? And then earlier, there's a talk talking about oxygen, endometrial thickness. That is, of course, a theory that we think that could impact on why some embryos don't implant, because the oxygen tension is altered because of endometrial thickness, change within the endometrium that is suboptimal. So there's a whole list of questions up there that I've put out. The tissue density, the pathology. Nowadays, people talk about microbiota. How does that all impact on this biophysical profile? Can we look at the biophysical profile to tell us globally what is happening within the uterus? So we have this problem in terms of our understanding of when normal becomes abnormal. There is a biological gradient. Normal, everything is fine, optimally functioning, and then you have disease. But it is a gradient. So when does one intervene? How much do we know about the in vivo environment? I've been talking about it. How much actually do we know? We've done a systematic review on this topic, and I can tell you very little, but I can show you the very little data that we have got from the literature. And in terms of dissolved oxygen, you can see there mostly animal studies. Yeah? There's a different variation in terms of the cycle, physiological changes, and so on with the development. But there's very little data for us to make any sense of. And if you look at the oxygen tension, also people have measured it, and there's these little oscillations that's happening. But we don't know if that's got to do with the sensor being not so good and its noise, or is it real rhythm? And if you look at pathology, there is only one paper from Japan, and it showed some variation in terms of pathology, but really we can't depend on that because the N numbers are too small. And if you look at pH, again, you see a pH gradation from the reproductive tract, vagina, all the way to the fallopian tube, with a darker color and the lighter color differentiating the pH gradient. And so there are changes within the reproductive tract. It's not exactly the same pH all throughout. And then, of course, we have temperature. Now, we, of course, know more about temperature than any of these biophysical profiles, but bear in mind that core temperature is not the same as peripheral temperature. So what are the current strategies that people have been researching and proposing to overcome this problem of pathology within the uterus, and how do they suggest that we can overcome it? Now, one of the interesting inventions in the last decade or so is a device that has an in vivo culture system where the gametes are cultured together and they can be placed inside the uterine cavity, where then the woman carries and fertilizes everything within it, removed, take the embryo out and replace it. But of course, we're relying on the uterus being normal in this sense, right? So what to do if the woman already has an abnormal uterine environment? So this, whilst it's a back to nature strategy, very neat, some clinical data, but still it doesn't solve the problem that we have been talking about. There are some scientists that has very, very successfully cultured embryos all the way to 2 weeks. But of course, a long way away from creating, a baby from that. But it's a start, it's a good start. But of course, we don't know the developmental potential of these embryos longer term. Now, from the other end of the spectrum, scientists have looked at incubators. This study on animals trying to create an artificial womb to sustain the preterm pregnancies. And with some success, but of course, the system still needs improving. And again, it's from where the animals are preterm, but not from from the embryo end. So we're still not connecting the dots. Some people propose using temperature monitoring externally, walking through a scanner, telling you how your eggs are doing. But of course, that's snapshot, and you can't forever be staying within the temperature machine. So this is an invention that we have been working on for quite a number of years now. It's a tiny uterine in vivo sensor that is inert, and you can place it within the uterine cavity preconceptionally to understand the biophysical profile of the uterus and its environment, and then be able to, with the aim, be able to beam out the information into your laptop or your phone so that you can better understand in real time what's happening within the uterus. And early proof of concept studies were a number of years back where we've done the temperature data, looking at whether the sensor works, whether it's well tolerated in our first prototype. And of course, the temperature is shown to be a circadian, and it varies with time. And this is the human proof of concept data, 3 days, number of years ago now in Southampton, where we show that in the participants that has this sensor, you can see the variation in the temperature. And later on, we then tested the sensors on animals, on rabbits, specifically oxygen, pH, and temperature. And again, we see that the sensors are working. These are mini sensors are working, detecting dissolved oxygen, pH, and temperature. And again, the variation minute to minute, you see there in the rabbits. We have now completed the first in-woman human study just months before now. This is on 7 days of the device in our participants with a variable, different types of fertility problems across the board, including normal. And again, it's a first feasibility safety study that we conducted on 25 women, and the data has come back really reassuring. Recruitment was very good, and there were no safety issues identified. Now, what is interesting, just by simply looking at the temperature, and of course this is early days because this is only on a small number of women, but we see fluctuations of temperature, simple biophysical profile at temperature outside the range in a normal, healthy person with no infection, nothing, outside the normal range of what we would expect, right? But as I say, we can't infer too much. And in terms of oxygen, again, similar pattern, low level of dissolved oxygen percentage, similar pattern, but with ranges that are higher and much lower than what we expected in some women. If you're interested, you can email the email I put there, but due to some commercial sensitivity, I can't show you the actual data board here, but hopefully in due course, we should be able to. But ultimately, what we're trying to do is basically understand what is normal, what is abnormal, so that we can, as I said before, be able to personalize based on in vivo uterine data of our patients' treatment. There are numerous challenges in this development journey, or innovations journey. Miniaturization, biofiling, multi-platform development, and of course, ultimately correlating that to real human data, patient characteristics, and make sense of it so that it's translated to medicine. Now that, of course, is something we would want to do in due course, but of course, a challenging task. So that's certainly something we will hopefully be able to present in the future. So in summary, I hope I have introduced you the concept of biosensing, and that there are some promising work in this area that it's really exciting, and I hope that in due course, the uterine environment won't be lost in translation, and we would understand this much better to bring better care to our patients. With that, thank you very much.
Thank you, Professor Ying, for such an interesting talk. Can you please elaborate on, you said there's a biosensor which is put in the uterine cavity for the implantation. How does that work? Where it is put? If you can elaborate a little bit.
Okay. So the innovation I showed you from the University of Southampton, that's work in progress. It's in research. But essentially, it's a sensor platform. It's really a small, a bit like a uterine coil, yeah, inert. It's got multi-sensor platform on it, and literally you insert it like you insert a mini Mirena or something like that. And the data, as it's batteryless, it's wireless, so there's nothing coming out, having to be stuck to, your and it beams out the information basically. So in principle, proof of concept, it works. It's just, of course, the data is, we need to accumulate data to understand better what it means before we claim that it's clinically useful.
So it was put in fertile women. It was put in fertile women in the uterine cavity.
In the uterine cavity, in the preconceptionally.
Preconceptionally.
Yeah.
Who are planning a pregnancy.
Correct.
And if they conceive, just to see how it works.
Correct. Correct. And some women, as I showed you, that even the temperature profile, you would expect them to be within the normal bracket, but some of them actually were quite high. And we checked, obviously, they're not submerged in a jacuzzi or anything like that, so it's probably their normal profile. But what it means, I think we'll need to wait to see.
Thank you so much. Any other questions? And for the previous speaker also, house is open if you want to ask any questions.
Hello? Yeah. So what you've explained about the new novel technology that you people have been introducing or researching on, I just want to know the applications of it. With this technology, are we going to understand how to make our incubators better? Or is it an indication towards fresh embryo transfers that is a possibility?
So that's a very good question. And the purpose, really, of understanding the in vivo uterine environment is, first of all, curiosity. We don't know anything, right? Secondly, of course, knowing the knowledge would mean that we potentially can triage our women. So at the moment, of course, any randomized controlled trial or any trial, what we tend to do is say, you go here, you go here, you go. We don't actually triage them enough, and that's why a lot of studies we don't see any difference, right? But I think, if we are able to better triage, and this is just one of the mechanism of triaging, there are other ways to triage them, then I think that it becomes easier to study the effect of some interventions, simple interventions that we don't seem to see any effect at the moment, yeah? And the third thing, of course, is the data. I mean, the data is absolutely important, because if we know what is actually happening with these parameters, there's so much we can do with it in the body or externally. Yeah?
Thank you so much to all the speakers and the chair, Dr. Meenakshi and Dr. Nitin. Moving on to the next session, may I please invite on stage the chairperson for the next session, Dr. Sonu Balhara, Senior Consultant, ART Fertility Clinics, Gurgaon. Dr. Sonu is a very well-known IVF and infertility specialist, and she trained in endoscopic procedures and artificial reproductive techniques at the prestigious Army Hospital Research and Referral, New Delhi, and has over 25 years of knowledge. May I call upon our next chairperson, Dr. Dakshayani, Clinical Director, ART Fertility Clinics, Chennai. She's a gynecologist and infertility specialist with vast experience of more than 20 years in her field. She completed her post-graduation from Trinity in Dublin, and then she went on to Germany to master in the field of reproductive medicine. May I please request the chair to introduce our next speaker, Professor Baris Atta, who will talk on recurrent implantation failure with and without PGTA.
Good evening, everybody. This is the last session for the day. We had a very good exhaustive sessions and many new things we have learned from today's conference. I would like to invite Professor Barisata, Professor of Obstetrics and Gynecology and Specialist in Reproductive Medicine at Fertility Clinics. He is an MD and MSc, is a world-renowned reproductive medicine and surgery expert. His research focuses on female infertility, endometriosis, and clinical aspects of assisted reproduction. He has served and serves on editorial boards of leading journals in the field including Human Reproduction Update, Human Reproduction. He is executive committee member of ISHRE and the president of the Turkish Society of Reproductive Medicine. Professor Ata has received multiple awards for research, education, and quality of patient care from prestigious national and international institutions. Welcome, sir. And I think we have been doing PGTA and such biopsies on our embryos for the last 10 years, but we still have some negative cases coming out after the cases. So I think you will throw us more light on with or without PGTA.
I hope to. Thank you. Dear chairpersons, dear colleagues, it's a great pleasure to be a part of this team and to participate in this meeting. So as the title implies, I'll try to cover and revisit the concept of recurrent implantation failure. I mean, it doesn't sound nice. It has the word failure, and then on top of it, it has the word, recurrent. So nobody likes it, neither us nor the patients. Let's see how it affects our clinical practice. So whatever I'll cover in the first part of the talk relates to daily clinical practice from an evidence-based standpoint. Research is a different subject. So these are my disclosures, none of which are relevant. And let me start with framing the concept of recurrent implantation failure. I mean, I've been in the field for more than 15 years now. When I started, it was around, there was something called recurrent implantation failure. It was a vague term. And now, over the last maybe 1-2 years, I think more rational diagnostic criteria or more rational criteria are appearing in recent publications. So the first point I want to make is what we deal with in fertility is a probabilistic diagnosis. Even in the absence of an obvious risk factor like anovulation, abdominal surgery, or low sperm count, we do not expect every couple to achieve pregnancy in every single cycle. So it means not every egg and sperm have the potential to reach live birth. And to prevent unnecessary testing, interventions, and even stress, so we want to make sure each couple has adequate exposure for a chance of spontaneous pregnancy. And when it fails, when we expect it to have happened by almost 80 to 90%, with 80 to 90% probability, then we call it infertility and start investigating. So even at a young age, for females under 30, when human fecundity is the highest, the average probability of a pregnancy that would lead to a live birth is about 25% per egg sperm pair. So how does it apply to IVF? From the first days, we never expected that each embryo would implant. So then when should we start worrying if the next embryo will implant or will fail to implant either? So again, we need to take a probabilistic approach. You see photos of very nice developed expanded blastocysts with good trophectoderm, good inner cell mass. Actually, this is the same photo duplicated. So what would you expect the probability of this embryo implanting and leading to a live birth? I mean, it looks nice, but it depends on whose embryo it is. Basically, if it belongs to someone who is 29 years old, as opposed to belonging to a woman who is 42 years old, they will have very different probabilities of or chances of implanting and reaching live birth, even if the only problem was aneuploidy. So as you see, the embryo from the 29-year-old woman would have an approximately 60% chance of being euploid, and assuming euploid blastocyst implant at a rate of 60%, if this embryo did not undergo genetic testing for aneuploidy, you can assume the chance of implantation side by reaching live birth would be somewhere around 36%, as opposed to the same embryo, if it belonged to a 42-year-old woman, without genetic testing, you can assume it would have an euploid rate of almost 20%. And even it implants at a similar rate, provided that it's euploid, the probability of implanting at the end and reaching live birth would be 12%, which is threefold different. So if we ignore the probability of euploidy and the effect of female age on it, our estimates or our expectations could be seriously off the mark. So how do I come up with these figures? So when we published 10 years ago with Santiago Munne, that's an analysis of 30,000 embryos. You see, sorry, how does it go back? Can you go back one slide somehow? Okay. Euploid rates decline seriously with age, and what's happening? All the following studies done in different centers with similarly high number of embryos corroborate it. There is some variation, but we can say within each age bracket, it's more or less consistent. Only the most recent study, probably by increased resolution of the NGS, reports even lower euploid rates. So how can we use this information to adjust for our expected implantation and live birth rates per embryo without genetic testing, and how it informs our expectations for cumulative probability of implantation and live birth over a number of successive transfers. So it's possible to calculate this. There are few assumptions. One is we assume an euploid rate in the age bracket. We can use the data from the literature unless we have our own data. Then we assume euploid embryos implant at almost similar rate regardless of female age. And then using the mathematical formula, we can come up with graphs like this. So that's what we published. I think it's been slightly more than a year now. So as you see, even in the youngest age category, the x-axis shows the total number of transferred embryos, assuming these are blastocysts, they have 5 embryos. Given those euploid rates and depending on the assumed implantation rate for an euploid embryo, you can see, the first one gives you something about 35, and 3 of them gives you something about 75. And it is, in a sense, an arbitrary decision where you draw the line to call it implantation failure, recurrent implantation failure. If you take a similar approach like the definition of infertility, you should say, it should be above 85 to 90%. If you take a statistical approach, you can say, 2 standard deviations away from the mean would be 95%. Or you can choose something else, but it will have implications. Anyways, for 95%, you would need, even in the younger woman, almost 6 unscreened blastocysts. And as the woman gets older, to reach similar probabilities, you would reach a very high number of unscreened blastocysts to be transferred. Let's say, if you're treating a patient who is 41, even if you transfer, say, 8 blastocysts over time without screening, you will expect that the chance of implantation and live birth would be somewhere around 70%. So that means if the only problem was aneuploidy, there is still 30% chance that she would fail, even if there's no other problem. Okay. So and what happens with euploid embryos? If you calculate the same, again, depending on the anticipated implantation rate of euploid embryos, regardless of female age, if you transfer one at an implantation rate of 55%, with 3 embryos, you reach something about 90%. And the paper published by Pirtea, using EVRMA New Jersey data, actually shows in real life, once you exclude obvious risk factors, with consecutive transfers of 3 euploid blastocysts, live birth reaches over 95%. So that tells us most of the time, given that we had a proper initial assessment before starting treatment, euploidy can account for a huge number of failures, and 95% of couples would reach a live birth with 3 euploid blastocysts. So none of the former definitions, even though they had a similar concept deep inside, trying to exclude older women, poor quality embryos, etc., did not have a particular calculation. So the definitions were more or less arbitrary, and the common thing that they share is they require too few numbers of embryos to call recurrent implantation failure. And it would really have implications, as we'll discuss. So this is just about to be published. It's available online on ESHRE website. That's a good practice recommendation paper by a group of experts from ESHRE. Now, using a similar probabilistic approach, what is recommended is you should wait until the couple reaches a 60% chance of cumulative probability, 60% cumulative probability of implantation to take any further action. So how do they calculate this, or how do you calculate the number of embryos to be transferred? Again, they've used the European IVF monitoring data, divided women into age brackets. The brackets are a bit larger, but as you can see, if you use blastocysts, even in younger women, you would reach 3 to reach 60%. Slightly older, you would need 4. Over 40 years of age, 6 embryo transfers would only give you 60% chance, cumulative probability of implantation. So still 40% could be just due to aneuploidy. And if you're using euploid embryos, in women younger than 1, based on European data, you would already reach almost 60%. In 40-year-old, it is slightly lower, so they recommend waiting until failure of 2 blastocysts. So now that's the definition. You can choose a different cutoff, but it should be a rational choice. Then, if available, one can use their own euploid data, adjusted for age, to have specific or individualized calculations. But how does this information lead us in clinical practice? Again, I'm not referring to research context. So how does it affect our diagnostic strategy? How does it affect our further management of the couple? And at the end, I'll just say a few things about how does it affect our research design. So besides embryo aneuploidy, there are several factors that we know at least may affect the probability of implantation and live birth. You can categorize them as lifestyle factors, gamete quality, anatomic factors, and others. So lifestyle factors include smoking, alcohol consumption, or obesity. Yes, it may have an effect of implantation, but assessment of it is very simple. You just, measure the height and weight of the patient. You ask the patient, the couple, if they smoke or they consume alcohol. So you don't need to wait until they fail several cycles. Okay? And the intervention, if you would do, is easy anyways. Just recommend them stopping it, or even though the beneficial effect of weight loss is controversial, you don't need to wait several cycles to fail. Whereas gamete quality is basic to what we do. Unfortunately, quality is a vague term, and at the moment, we don't have in clinical practice a reliable measure of it. Okay? So in practice, it doesn't affect what we do in clinical practice at the moment outside research. The anatomical factors We've just listened to fibroids just an hour ago. I mean, if there's intracavitary pathology, there's fair evidence suggests it affects chance of implantation. And again, to treat that, except for the septum maybe, we don't need to wait until failure of several cycles. Diagnosis just requires a proper ultrasound examination. And assessment of tubal patency is part of routine basic infertility assessment. So we already have this information before several cycles fail. And if, depending on the pathology, if we are convinced that it affects the chance of implantation, we would treat it simply even before the first cycle. Okay? There may be a few exceptions here about septum and intramural fibroids. I'll go through them in later slides. And for adnexal pathology, if a woman has obvious hydrosalpinx, then we don't need to wait. Regardless of our criteria for recurrent implantation failure, we would take action properly before the first ever cycle anyways. And things like endometrial receptivity arrays are at best experimental at the moment. The currently available commercial one is recently proven, say, not beneficial, I would say. And thrombophilia is irrelevant. So what is left? I mean, if we do a proper history taking, a proper physical exam, proper ultrasound assessment before the first cycle, what is left and what else would be required if a couple meets a rational criteria to be diagnosed with recurrent implantation failure, except for aneuploidy? So I would say what is left is maybe a karyotype analysis. Rarely there may be a carrier of a balanced translocation, okay, which may require genetic testing for it becoming unbalanced. And it may also affect the way we counsel the couple based on their new anticipated probabilities of producing euploid embryos. The second thing, it's controversial, but studies on effect of hydrosalpinges on IVF outcome are not necessarily restricted to ultrasound visible hydrosalpinges. And if the period between the time when tubal patency was assessed and when the couples failed several cycles to reach recurrent implantation failure threshold, if you suspect there may be other factors leading to tubal obstruction, even if it's small enough to be seen on ultrasound, maybe you may consider a test of tubal patency to diagnose what is called arguably an occult hydrosalpinx. Okay, so except for these two, for a routine clinical practice from an evidence-based medical medicine standpoint, I don't see any other tests that would be required by recurrent implantation failure. Going forward in this recent upcoming good practice recommendations, what was reviewed and what is discussed as next assessments, if a couple meets recurrent implantation failure criteria, reassess lifestyle factors, which we already do at the beginning, reassess endometrial thickness. This is something I disagree. If premature progesterone exposure has been ruled out in the former cycles and the endometrium has a proper trilaminar pattern, then vitamin D studies, karyotype, 3D ultrasound, hysteroscopy, chronic endometritis, thyroid function, and progesterone levels in frozen embryo transfer cycles, you should think how it affects your daily practice and how it applies to your practice. So in our practice, actually most of them do not apply because we already do them at the very beginning. I mean, we don't wait until the couple fails several cycles. I mean, we monitor progesterone levels, in our monitoring for fresh and frozen cycles anyways. I mean, we can discuss the rationale later, but we prescribe vitamin D routinely anyways. Then the only thing left, I mean, at least for my own practice, is karyotyping. So I would see little relevance of the term recurrent implantation failure to direct clinical practice from a diagnostic standpoint. Then, briefly, how it may affect further management strategy. Remember the table. If there's something that I know would already affect the possibility of implantation, I would treat it before the first cycle or whenever I see it. What is left one thing is, as we just listened, intramural fibroids without an intracavitary portion. So good quality studies like prospective studies suggest intramural fibroids have an effect on chance of implantation and may be associated with increased risk of miscarriage. The missing piece of information is we don't have solid evidence that surgery restores these numbers. Okay? So, and then to justify surgery, I think it may make sense, at least in a young patient, to try a reasonable number of embryo transfers, and then if she reaches a point where I would have expected her to have an ongoing pregnancy and a live birth by, say, 80% or by 90%, or depending on actually like 60%, then we may discuss with the patients and decide to embrace that uncertainty that maybe surgery would improve the condition, but surgery has its own risks, costs, etc. So I wouldn't recommend it in the first place. Or again, given the recent publications, you may apply the same to a uterine septum. Or if a patient has, say, a focal adenomyosis like adenomyoma, which may be amenable to surgical treatment with doubtful benefit, if she fails multiple cycles in the absence of another factor, then maybe it may be the time to consider that uncertainty. I think that's the only few things currently where recurrent implantation failure concept may be useful or guiding us in treatment. Then what are the other recommendations? So fibroids, septum, this is not covered in this document because I guess the group considered them as already factors that would explain implantation failure. So this strictly relates to couples who have no other obvious anatomic abnormality. But anyways, you see like recommended things are again vitamin D, chronic endometritis treatment, intrauterine HCG injection, and maybe PGTA and blastocyst embryo transfer. Again, we need to consider if it applies to our own practice. So in our own practice, actually it doesn't, because we do blastocyst transfers for everyone anyways, and we liberally use PGTA, and then we supplement with vitamin D. Why I ruled out HCG injection is because when I read the document, it's my own opinion though, the evidence supporting HCG is pretty weak. And similar things with similar level of evidence, if the group didn't feel it was appropriate, it's recommended against. Okay? So I fail to see the biological rationale, except for research setting, I wouldn't recommend it. That's not what that's what I'm doing. And chronic endometritis, it's an uncertain diagnosis. Regardless of the method you use for its diagnosis, its effect on IVF outcome is also controversial. And rather than doing these, say, controversial diagnostic steps, if the couple reaches the RIF threshold, it's relatively easy to prescribe a round of antibiotics if that's what your concern is. But I wouldn't do it in the first place because even altering the microbial flora may have an effect, maybe a negative effect on the outcome. So we should be careful before labeling people, couples, for their mental health and our own mental health and prognosis, calling them with recurrent implantation failure, because it's a vague term, it has a lot of negative connotation, and it really stresses people out, and it may cause them to drop out from further treatment. Remember Professor Gianaroli's lecture in the morning, it's really important to keep them, because each new oocyte, each new embryo is a new chance. Right? So we should try to prevent dropouts with preventing undue stress. That's one thing. And secondly, we shouldn't encourage them or we shouldn't cause them to spend their money, moral, time for probably useless or unnecessary interventions or diagnostic tests that wouldn't lead our further, that wouldn't guide our further management. So that's why I think we should be conservative. One last thing about research. The probability that you will find a particular pathology you are looking for in a research population would depend on how homogeneous your study group is. Okay? So as embryo aneuploidy is the leading cause of implantation failure, it should be ruled out reliably before we start any project on either diagnostic way or in a therapeutic way for recurrent implantation failure. Otherwise, our study group would be mixed up with a lot of other couples who just failed because of embryo aneuploidy. Whatever you're looking for would be diluted, would be more difficult to find, would be more difficult to treat. So false negativity is a risk. And also considering there are hundreds of papers on recurrent implantation failure with these variable definitions, another risk is false positivity. The more tests you do, sometimes something just appears positive just because of chance. Then a lot of couples around the world undergo those tests, those treatments without any biological rationale. So that's why we need to be conservative. So the point of my talk is, once we do proper evidence-based medicine diligently, recurrent implantation failure has little use. Whatever we should do it before the first cycle properly, and then there's little left for recurrent implantation failure, and we should keep people in treatment loop so they can try with new embryos with new chance. So now I hope this sets the stage for another talk from a research perspective. So I'm sorry I'm a bit over time, but thank you for your understanding.
Thank you, Professor Baris. We'll take the questions later on, sir.
So our next speaker, Dr. Diana Alexandru. Dr. Diana is a consultant in clinical immunology and reproductive immunology at EV Madrid, Spain. She's an associate professor in the immunology program at the Department of Microbiology at Madrid and professor for the master's degree in human reproduction at Rey Juan Carlos University. Dr. Diana has published numerous scientific articles, book chapters, and abstracts on immunology and human reproductive immunology, and has been involved in several research projects. Dr. Diana will be talking on immunological aspects of recurrent implantation failure.
Thank you very much for your kind presentation and to the organizers for inviting me to be part of this very interesting and high-level panel. There is not a clear definition for recurrent implantation failure. However, a quite recent research and paper reported that recurrent implantation failure is a rare occurrence, less than 5%, with two conditions: euploid embryos and 3 or more of them transfers, and the normal endometrium. And the same study suggested that the implantation failure mainly results from the embryonic causes. Starting at this point, other study presented last year at ESHRE tried to answer the question, is the embryo, is the endometrium, or are there problems in both sides? 7,491 embryo transfers using oocytes were reviewed, and they look for a biochemical miscarriage rate in different groups. Groups with transfer using only PGTA, transfers with PGTA plus endometrial transcriptomy for receptivity, endometrial transcriptomy for receptivity alone, and controls, neither transcriptomy for receptivity nor PGTA. And the results showed the same 8% biochemical miscarriage rate in all groups. Nor PGTA, neither transcriptomic, endometrial transcriptomy for receptivity modified the embryo loss rate. And for sure, there should be a different mechanism not associated with the chromosomal structure and a transcriptomic of the endometrium involved in this, our embryo loss rate. We would like to live in an ideal world and see only perfect patients, young patients with a high number of euploid embryos, and beautiful and functional endometrium, and the 95% of pregnancy rate after 3 euploid transfers. But the reality in our society today, in 2023, is completely different. And in our clinics today, we face with a different scenario: an increased maternal age, other underlying infertility-related diagnoses, such as PCOS, obesity, hypertension, diabetes, autoimmune disorders, or local problems as adenomyosis, endometriosis, uterine abnormalities, or poor endometrial responses. And it's very easy to guess that their reproductive outcomes differ pretty much from the ideal patient's results. For success of the pregnancy, there is a need for a competent blastocyst and the euploid blastocyst, a normal and functional endometrium, but a good crosstalk between the embryo and the maternal tissue. When we transfer competent and euploid blastocyst, the first moment is the apposition and the adherence of the embryo to the maternal tissue. And this step requires a good receptivity. So when we have the information coming from a transcriptomy, the endometrial transcriptomy for receptivity, we have the information limited to the superficial layer of the endometrium, to the epithelium, and limited to this step. But for the embryo invasion into the maternal tissue, there is a need for a good transformation of the endometrium in a process called decidualization. That's why an aberrant decidualization leads us to implantation failure and to miscarriages. The transformation of the endometrium into that process called decidualization is made through the action of the progesterone. And the differentiation of the stromal cells into the decidual stromal cells after the interaction of the progesterone with these receptors is a crucial step for the blastocyst invasion and the maintenance of the pregnancy. Once the decidualization begins, the decidual stromal cells start to be active and secrete a wide range of cytokines, growth factors, and angiogenic factors, which will change all the maternal environment in order to prepare it for helping the embryo invasion, to tolerate, to supply the embryo with nutrition, oxygen, hormones, vitamins, all the embryo needs for it keeping growing and until the end of the pregnancy. One of the results after the activation of the stromal endometrial cells is the production of IL-15, which will induce changes in the maternal immune cells into the endometrium, mostly on the uterine NK cells, which are the most abundant immune cells into the decidua. Until that point, that at the end of the first trimester of pregnancy, 90% of the immune cells into the decidua are represented by uterine NK cells. But at the same time, and very important in a new knowledge, is that the stromal endometrial cells, one, respond to the action of the progesterone and start the process of decidualization, start to express some immune molecules, the new one, HLA-F, which will keep doing a job for the mother immune system in order to boost its activation to be able to help the embryo invasion into the maternal tissue. And we have here the first moment of the embryo invasion. The brown cells are the extravillow trophoblast cells invading the maternal tissue, and the other cells are the mother's uterine immune cells. Those cells are the uterine NK cells, which are the abundant one, and the other one, T cells, macrophages, dendritic cells. And how can we see in this picture? The decidual stromal cells are participating actively in the changes in the maternal immune system, but once they have response to the progesterone properly, and that decidualization. But for the embryo invasion, there is a need for a good identification of the embryo and to be allowed to go ahead into the maternal tissue. And this identification is made into a mechanism, a crosstalk between the mother and the maternal tissue. And this crosstalk starts with that check of identity, which is made through some receptors, some molecules on the surface of uterine NK cells called key receptors, and some tag identification on the surface of the extravillow trophoblast cells called HLA-C. If this identification occurs properly, in one hand, the embryo is allowed to go ahead and keep invading the maternal tissue, and on the other hand, signals will be sent to the other maternal immune cells to stay calm and to transform itself into a tolerogenic state in order to activate and to maintain the embryo invasion and placentation. But the immune system doesn't work alone into the endometrium. There is a need for a good interrelationship with the hormone system, with the metabolic system, reproductive tract, microbiome. But there are two jobs coming from the mother immune cells. One, to promote the embryo invasion, and the second, to tolerate what is already inside of the decidua. But those excess could fail, and the disruption in this allowance or in this tolerance could lead us to an interruption in the process of the embryo invasion. In one hand, we could have a lack of activation, so less help coming from the mother cells, mostly from the immune cells for the embryo implantation, and in the other hand, an excessive inflammatory environment which is harmful for the embryo, but at the same time impairs the maternal tolerance into the decidua. The most known example of this interaction is what we know in PCOS, obesity, and insulin-resistant patients. There is a vicious cycle between hyperandrogenism, hyperinsulinemia, and chronic inflammation. And when we go into the endometrium of those women, first of all, we will find a different transcriptomic with the dysregulated genes related to the immune system, with an increased inflammatory profile, an increased production of the very powerful inflammatory cytokines, increased population of different cells as macrophages of the dendritic cells into an inflammatory state. But at the same time, we find a decreased level of those cells, or uterine NK cells, which are there to help our embryos to implant. Other model is adenomyosis. When we have a study into a uterus of the women with adenomyosis, again, we will discover chronic low-grade inflammation with an immune dysfunction, with an excessive population of very powerful inflammatory cells as Th17 and production of IL-6 or IL-17, other pro-inflammatory cytokines. But very important, there is a dysregulation of endometrial expression of sex hormone receptors and co-receptors, an altered vascularization, and an abnormal endometrial gene expression with changes in 25 protein involved in immune responses, inflammation, and complement activation. And recently, we know that the risk of adenomyosis patients having a non-receptive endometrium is 42.5% higher compared to controls. And their responsivity to progesterone is not corrected by the timing of the progesterone, because there is other mechanism involved in the responsivity of the stromal cells to the progesterone because of some resistance in its receptor. Other model is the endometriosis. Again, we found two axes of the immune system altered in those endometrium. In one hand, too much inflammation with an increased population and pro-inflammatory macrophages versus anti-inflammatory macrophages, but at the same time, those cells which are there or should help the embryo invasion are impaired because of the higher expression of inhibitory receptors on their surface and the lower frequency on the activated. So less help for the invasion and too much inflammation in those endometrios. At the same time, in chronic endometritis, there is an increased inflammatory with the presence of many inflammation, but at the same time, a downregulation of those markers of the decidualization, which lead us and show us that there is an impaired decidualization in women having this condition. Right now, we are looking for some tests to tell us which patients has a disruption into the maternal immune cells or a problem into the decidualization. And there are some new tests, as endometrial decidual score, BCL6 test. They are at the beginning, some information that we could receive from those tests, but probably the most known test from all of the immune available tests is the immune histochemistry for uterine NK cells. And most of readers think that if their name is natural killer cells, they should be involved in killing our embryo and should be harmful at the endometrial site. But it's not like that. There are good cells helping our reproductive function, but at the same time, the studies and the recent meta-analysis show that the number of the uterine NK cells into the endometrium doesn't mean anything. When they studied those cells into the endometrium of women with recurrent implantation failure, yes, they found an increased percentages of uterine NK cells in their endometrium, but when they studied the reproductive outcome by the percentage of the presence of the uterine NK cells, they don't see any differences, significant differences amongst different groups. But all those studies only used immune histochemistry looking for uterine NK cells. And at that point, we have information only about one single marker, which is CD56. That's why we perform a study, a prospective study, which we want to see the subset of the uterine NK cells in our samples. And we we performed that biopsy in recurrent reproductive failure patients, and we observed that the patients with poor reproductive outcome, they have an increased percentage of cytotoxic natural killer cells into the endometrium. Compared to controls. But when we split the analysis by their receptors, the key receptors, we didn't find any differences about the presence of those cytotoxic cells into the endometrium. Okay, at that point, we thought maybe that this balance is coming because of the contact with the embryo. And we start studying the binding to check if the embryo it's able to have a good interaction with the maternal cells. To this purpose, we use an artificial embryo, which is a peptide surrounded by 4 different HLA-C. We choose the HLA-C2 most frequent allele in Spanish population, and we put that artificial embryo in a contact with the maternal uterine NK cells in the women biopsies. And after that, we study the binding between that artificial embryo or HLA-C tetramer with the mother cells. And when we study taking in account the mother's case, we didn't find any differences among 3 genotypes, KIRE, AB, and BB. What does it mean? It means that, okay, there are more cytotoxic uterine NK cells into the endometrium of women with reproductive failure, but when we go to the receptors in charge of helping the embryo to implant, we don't see any differences. So the presence there doesn't have any impact on the reproductive outcome on one side. And the other side, there isn't a problem in the binding between the embryo and the mother's uterine NK cells. So there should be a problem after that. In the signals, the mother cells should transmit to the other cells into the endometrium in order to do their proper job on helping the embryo invasion. And that's why a lack of activation or less job or less work coming from the maternal uterine NK cells is not very good for our reproductive outcomes, because there is a need for the endometrial cells to sustain the embryo invasion and implantation. And here appears that crosstalk between the mother cells and the embryo cells. And this crosstalk is made through some molecules which the embryo present in their surface, but at the same time to some other cytokines to keep that dialogue together. And among all those markers on the surface of extravillolar trophoblast cells in the maternal cells, the more immune environment into the endometrium, less support for the embryo invasion. When we transfer an embryo using our own eggs, only the paternally inherited HLA-C is a stranger, a non-self. And this paternally inherited HLA-C needs to find the right and proper activating receptor in order to activate the uterine NK cells, the mother uterine NK cells, in order to promote those immune signals for a correct interaction of the embryo and supporting its invasion. But if the paternally HLA-C find the inhibitory receptors, those signals will be suppressed and won't be enough help for the embryo implantation. But when we change the egg, the scenario is a bit different because even that egg donor HLA-C behaves as paternal. So there will be two different strangers presented to the maternal tissue at the same time. And if we transfer two embryos using egg donation, there will be 4 different antigens presented to the mother's immune cells. And even the donor HLA-C needs to find the proper activating receptors on the maternal cells in order to promote the proper signals. And we know right now that the higher the amount of C2 into the embryos, the lower our live birth rate is. And that's why the embryo implantation is not depending for one single factor. It's a very complex process, and for sure there is a need for a competing, the euploid blastocyst, but there is a need for a synchronicity among all the maternal system involved in the decidualization, in the maternal and fetal crosstalk, in the activation, the proper activation of the immune system, the maternal and fetal tolerance of course, an epigenetic phenomenon we have during not only the first trimester, but during the whole pregnancy. And the embryo implantation fails when there is a lack of synchronicity among all those systems. And it's very important to know that the recurrent implantation failure or an implantation failure could be a result of one factor or multiple factors and may not result the same time from the same factor each time. So there is a need for individualized protocols to diagnose the recurrent implantation failure, to ask for some specific tests, and even more when we are ready to offer some kind of treatment to our patients for solving their problems. Because one piece left affect our reproductive outcome. And the modulation of the help coming from our side into those processes start even with the hormonal substitutive treatment. And we know that we need to individualize those protocols for those patients having adenomyosis, endometriosis, or PCOS. When there is too much activation into the maternal tissue, we need first of all to see where is the origin of that activation, because if it's coming from the metabolic system, we need to solve that system with that measurement, weight controls or other controls of glucose or insulin, and not suppressing the mother immune cells. If there is a real hyperinflammation coming from the mother immune system cells, calming down the mother cells, yes, it is useful to improve our reproductive outcome. And at the same time, the control of the infectious factors and all together will help us to have a good maternal environment and will help each system to do its proper job in order to sustain that embryo invasion, a good placentation, and to sustain the success of the pregnancy until the end. Thank you.
Thank you, Dr. Diana. So we'll be taking questions later on. We're running really short of time. Thank you for the excellent talk.
Okay, thank you.
Sorry. We now invite Dr. Miguel Angel, He's the co-founder and medical director for Fertility. He's the director there, international. He's a master's in human reproductive medicine at UAB 2010 to 2023. He has written more than 35 chapters of books on reproductive medicine and has edited 8 books in this discipline. He has published more than 100 scientific articles in specialized journals, and since 1998, he has presented the findings of his research and at the most prestigious congresses around the world. He has had the honor of being invited to lecture before most important societies of reproductive medicine, such as European and American ones. His research lines are in the field of deferred embryo transfer, fertility and pollutants, and poor ovarian response. And today he will talk about air pollution and fertility. Thank you, sir.
A pleasant presentation. First of all, I want to thank the scientific committee to invite us, Professor Fatemi, Barbara, and Mr. Suresh, to be here. So we're going to talk about air pollution. And why we're going to talk about air pollution? Because we are in Delhi. And I Googled yesterday that the most polluted cities in the world, and Delhi is the 4th city most polluted in the world, 2022. So I'm going to share with you our experience researching in air pollution in the city of Barcelona. And we're going to do a short review of what is air pollution. So in 2015, I was doing an exchange professors in UCSD in San Diego, and I met Linda Judis, and we were talking that we are preparing a new grant for trying to do what's the effect of air pollution in fertility. And we are talking that probably there's a growing body of evidence that now should suggest that environmental toxicants play an important role in human reproduction and human fertility. But not only in fertility, it starts years before. This is a communication, a press release of World Health Organization that just shows that outdoor air pollution is caused as carcinogenic. And in particular matter, the fine particles that are in the air are due to carcinogenic effect in humans. So many societies, it appeals right now that American College of Obstetrics and Gynecology, International Federation of Obstetrics and Gynecology, on all of these societies, that air pollution is related with problems in health reproduction. This is my city, and you could see we have air pollution too, and we have some days that we have high peaks of air pollution, and we try, our council tried to reduce air pollution, cutting the traffic to the main areas to try to reduce these peaks of air pollution. But there are policies that we need to try to change or try to convince to people to reduce that, because nowadays we have a lot of evidence that air pollution affects our reproduction. Not only reproduction, in human health, the most frequent associated damages in human health, it's going to be respiratory mortality, asthma, rhinitis, lung cancer, but not only respiratory airway, central nervous system, strokes related to it, cardiovascular system, increases mortality, and all it's mediated for an inflammation in the human body and in the tissues. But focused in obstetrics and gynecology, we have several evidences that air pollution affects, for example, premature birth, decreased birth weight, decreased fetal growth, and in sperm, it's a surrogate marker of fertility. It shows that it decreases sperm quality. But which are the sources of air pollution, and we are the major air pollutants? In this picture, you could see that there's a part that is produced natural production, natural phenomena, like volcanoes, like lightning, like wildfires, that produces big amounts of air pollution, of these particles, but other part is produced by humans, but human action. It's called in the cities, livestock, fertilizers, industrial plants, sewage, and the most that we know are airplanes, cars, trucks, etc. All of these sources are the sources that produce air pollution. And we are the most important air pollutants. There are four. These four are, the first one is nitrogen dioxide. Nitrogen dioxide, it's a good marker of traffic, and induces inflammation, and it comes from nitric oxide that it combines with ozone that produces nitrogen dioxide. It's very, very related with global warming, with acid rain, and it is more powerful than CO2. So it's one of the components of these pollutants. Probably the most researched or more investigated is particulate matter. Particulate matter are fine particles that are in the air and are composed basically by black carbon, organic substance like, for example, pollen or dust, with heavy metals too. And these particles are going in the air, and for example, in COVID era, we know that the virus go traveling with these particles and go more dissemination. Particulate matter, it has different sizes. So you could see here, this is a human hair. These are particulate matter, and they are divided in function of the sort of the size. So there are 0.1 microns, 2.5 microns, 10 microns. And you could see, compared with the hair or compared with a fine beach sand, that these particles are really, really small. And what is important, the size of these particles? This is important because they could go inside of our body. For example, particulate matter 10, it stops here in the upper respiratory tract, but particulate matter 2.5 go to the lung, to the alveoli, and particulate matter 0.1 goes straight to the bloodstream, so straight to blood and affect many, many organs. Where can particulate matter? The sources that I explained before, there's a natural phenomenon that's it's animal waste, wood smoke, geologic dust, but there is a main production that humans produce in commercial cooking and from stationary sources, traffic, etc. So particulate matter is one of the most studied pollutants. And in 2020, it was the 8th cause of mortality in the world. And more than 3 million have premature death due particulate matter 2.5. It induces, as you could see, oxidative stress, chromosomal alteration, all is described in vitro and animal models. The other one is sulfur dioxide. Sulfur dioxide, it comes from the combustion of the fuel, and it has similar effect, decrease DNA synthesis, so increases miscarriages because damage DNA, and induces abnormal chromosome aberrations. So it's another pollutant that we need to keep. And the last one, it's carbon monoxide. Carbon monoxide comes directly from burning of cigarettes, burning stationary plants, burning in traffic, and carbon monoxide has more affinity than oxygen to hemoglobin, so displays hemoglobin and induces epoxy in the tissues. So This increase in animal models, this increase errors in implantation, and increases miscarriages. But all of these are many, many times described in animal model or in vitro models, but we want to know what is happening in human model. So in 2016, we published this paper that we tried to review all the papers that is published about sperm quality. And we find in this paper that most of the studies that we include in this systematic revision has altered parameters in number of sperm, in motility of the sperm, on the morphology of the sperm, or in DNA fragmentation. Which is the origin? Probably the origin is that this effect of pollution increases the oxidative stress, and this change it do a dysfunctional spermatozoa and could create infertility. The other paper that we published the same year, it was another systematic review, including only the papers that affect human fertility, not animal, not in vitro models. And we find that human fertility is affected in spontaneous conception and in IVF too. So in this paper, we include these previous papers that shows that the distance to a roadway or particulate matter influences the risk of infertility or increases the chances of miscarriage. For example, Mark Newbacken, this is one of epidemiologists of our team, in the city of Barcelona, could describe that in the neighborhoods that they have more exposed to high pollution, the fertility rates are lower than in the neighborhoods that are less exposed to air pollution. When we analyze the model in vitro fertilization, we control ovarian stimulation, we control the culture, and we control the transfer. We saw, again, that we have an effect when particulate matter increased. We saw an effect in the fertility with a diminished fertility in our patients. So this is not stopped here, it continues. And this is another paper from our colleagues of Harvard with Chavarro that they involved in a prospective cohort of 700 IVFs, and they found that the proximity to a highway decreased the live birth rate and implantation rate. It's a marker that the proximity to a highway could be a marker of air pollution and problems in health or in reproduction. But we want to know, we know that chronic exposure to air pollution affects fertility. There's another paper of Lamarca that chronic exposition in Modena affects anti-Mullerian hormone 2, ovarian reserve. But we want to know if these peaks of air pollution could affect our rates of implantation or our rates of miscarriage when we perform IVF. So, as always, come the Chinese with 6,000 cycles and do a retrospective study that shows that try to know which part of our current practice in IVF are more affected with high pollution. And they find that there's an increase of miscarriage related when between the transfer of the embryo and the serum HCG test. So they find this increased risk of miscarriages in this period. This is another group, a French group, that tried to do something similar, but they find in a retrospective cohort that the exposure during 2 months previous controlling ovarian stimulation and during controlling ovarian stimulation, they reduce they observe a decrease on ovarian reserve and they observe a decrease in the amount of of embryos the day of the transfer. So we are finding in many papers, in some papers, that air pollution, acute air pollution could affect the fertility. But we don't know exactly what is the problem. We demonstrate the problem in oogenesis, in rodents. They demonstrate the problem in implantation, in animal or in vitro models, but not in humans. And we are looking for try to be which is the most important part of the cycle to be affected for air pollution. And in 2021, we published this paper that with Mireia. Mireia was a predoc that stayed with us. And we tried to find which is this window that is more affected for air pollution. For do this study, we use a model that is developed for in the Scape. We work with our colleagues that are our neighbors in the research park. They are epidemiologists. And this is a huge project in Europe. In many cities of Europe, they include many samplers in each city. For example, in Barcelona, we have 500 samplers in all the city. So with these samplers, we know every day which is the amount of air pollution that we receive. And with geolocalization, we could know exactly in your street and in the floor that you live, the amount of air pollution that are receiving individuals. This is validated because in previous studies, they use backpacks with the samplers, and they have the same relation that you have in your backpack when you are doing your work, you do it at home, or the same amount you have when you are at home. So the most important amount of air pollution that you receive is when you are at home. So for this study, right now we could know every single day which is the concentration of these particles in Barcelona. These are the main streets you could see. But around these main streets, we have all this concentration every single day. So we could know day per day how is the amount of air pollution that one patient is receiving. For design this study, we include 486 transfer. We include all these levels of these pollutants, and we try to stratify in 4 windows of exposition. The first one, 15 days before embryo transfer. Second one, 30 days of embryo transfer, the day of the embryo transfer, and 7 days after embryo transfer. What we found, the first that we found is the mean during all the year in Barcelona city, we are over the normal values that World Health Organization allow to be. So in a city that is not recognized as a city with a lot of pollution, we are over these levels during all the year. And when we analyze one per one of these pollutants, we don't find any significant, statistic significant evidence that one or another one has effect in reproduction. When we talk with Mark is the epidemiologist, they say, no, you couldn't talk with one by one, because when you are breathing all together. There are mix, there are combination. So you need to do a copollutant analysis. And when we do this copollutant analysis, we could find that this particulate matter increase the risk of not pregnancy in IVF. And when we talk about miscarriage, this particulate matter in the 3 days previous the transfer increase again the risk of miscarriage. So we couldn't say 100% that this is the window that for sure we're gonna know the effects, but all of these days, as you could see in this slide or in the previous one, has increased this risk of miscarriage, of no pregnancy in our patients. So we couldn't predict every day or say to a couple, today you don't do the transfer, but these studies allows to us to do recommendations for change the policies. So When I started to talk many years ago, someone told me that if you couldn't resume in one slide that you said before, you don't know anything about your talk. So now I'm trying to do it. So first one is, today you could know that air pollution is an important, plays an important role in our health and in reproductive health. It reduces spontaneous fertility. I show you that it reduces spontaneous conception in these areas and increases miscarriages. The second is that it has a negative impact in IVF cycles and in IVF rates. Reduce pregnancy rates in centers that without labs, without lab filters. I hide this slide in question of the time, but the studies are very clear. Before and after we have filters in the lab, we couldn't culture embryos nowadays without filters, so it's important. There's an effective impact in the inflammatory system with particulate matter. And we couldn't say exactly if it is more affected folliculogenesis, embryonic development, or implantation in human model. We know it that all are affected in animal model. And for sure, the last sentence is the most important. We need to change our policy in order to try to reduce in our cities our levels of contamination. Thank you very much.
Thank you, Dr. Miguel. Dr. Erica, do we have time for questions or we'll move on to the next?
Sorry, because of shortage of time, we are going to even cancel the last panel, and I apologize for the same. May I please invite Professor Dr. Hooman Fatemi for closing remarks, please.
So again, apologies that we had to cancel the last session. It was a long day for all of us. But if you have any questions, we are always willing and happy to reply. You can ask it on personal level to all our clinics with the physicians, and we can communicate directly. So to wrap up the day, I think we had really top speakers from around the world, great friends, great speakers, great science on top level. And I hope we can replicate that on a regular basis in India in order to move more towards evidence-based medicine. And I think, as you have seen, there is need for evidence-based medicine, especially as you have seen, not only geography, culture, ethnicity has an impact on infertility. You have seen from Dr. Miguel's talk, pollution. I mean, in India, you have a high rate of pollution in various cities. All that might have an impact. So in order to close, I think the message is we have to put a question mark behind everything. We have to unlearn and relearn everything that we know in order to improve. Thank you again, all of you, all the speakers, all the organizers, local team, for doing a great job of organizing this meeting. Thank you very much and have a nice evening.